Hi everyone, welcome to Intellipaat for data science session. Data science, it's a term we hear in our day-to-day lives. All of us must have thought about becoming a data scientist at some point of time. But there are some questions that are holding us back. So in this session, we have collected top 5 common questions that people usually have while learning data science. So today, I have my colleague Satish, who is an expert in data science, and he will answer the question that people have in their mind. Hi Satish.
Hi.
So Satish, what's the right path to become a data scientist?
Uh, that's a very good question, Laksh. To become a data scientist, first you must need to earn a bachelor's degree or you have to complete your undergrad in any disciplines it can be. Either it can be IT or mathematics or computer science or any related fields. Then nowadays, if you could see, there are various options available also with various specializations as well. And on top of it, you might also need to consider a certification specialized with data science technology. And then you can just plan your career to pursue a master's degree with data engineering or data related domains or fields as well. And finally, on top of it, once you feel that you have all the desired qualifications or the desired skill sets, then you can apply for the entry level meaty roles in the field of data science.
Well, that's very insightful.
Thank you.
So what's the scope of data science in India?
Yeah, I'm more glad to answer this, Laksh. In the recent times, if you could well notice, data science is one of the most trendiest and hottest job profile, not only in India, on a global scale too. And data science promises more demanding and meaty careers for all the aspirants, that includes non-IT professionals as well. And in the recent years, data science had expanded its professional horizons in IT as well as non-IT industry too. And in the recent survey of various tech entities globally, they have recognized this data scientist role is one of the most trendiest job of 21st century as well, because there is huge career prospects involved beneath it. And on top of it, in order to get you more clarity, just go to any employment website, let it be naukri.com or indeed.com or shine.com, wherever it is, just type data science, the keyword type data science. You could see ample opportunities pertaining to the roles and the responsibilities and the subdivision roles, which are highly targeted meaty roles with exceptional remunerations as well. And on top of it, data science is one of the most meatiest role in not only in terms of the job roles and responsibilities, and also in terms of the packages or remuneration too. In terms of packages or remuneration, the average salary or package or remuneration offered to the data scientist role is comparatively higher than the other roles pertaining to the IT field. It can be of various disciplines as well. Okay. So I would strongly recommend data science technology for any person who is willing to pursue it on a short-term goal basis, as this is the right time, as data science technology is booming in a very hot scale, and the prestige that it carries over is also exponentially growing on a day-to-day basis. I hope I answered your question.
Well, that was very informative, Satish.
Thank you.
So what exactly a data scientist do?
Before explaining you what does a data scientist do, I would like to record a small thought, my thought of information. Technology, data, science. Split the words. Data means information, science means analysis. It's all about analysis of the data. Today, the world is completely data driven. By the end of 2020, the data was warping at the rate of 45 zettabytes as well, as recorded by the top-notch tech entities and R&D units present globally. And today, I would always say data science is all about analyzing the unusable, raw, messy or unstructured data, okay, by using some important concepts and tools like statistics, R or SAS or Python as per the organization bandwidth or the enterprise bandwidth what they use, analyzing, applying or all these concepts and tools on the unusable information, analyzing the data and deriving the inference. And this technology also acts as the ladder for the enterprises to derive the business insights, enhancing the enterprise performance as well. So this is the role of a data scientist. And if you ask me, I would strongly say that data scientists are said to be the superheroes of IT industry as well.
So what's your advice to the people who are aspiring data science?
I was expecting this question. That was a very good question as well. If you would ask me, my sincere suggestion for all the aspiring data scientists would be don't leave your learning process. Keep on upgrading yourself and upskilling yourself and keep yourself aligned to the latest industry trends. The reason why I'm insisting on the learning process is let's take you are a data scientist. If you might be having all the relevant academic as well as the technical skill sets, but if you don't have the capability to possess the right real-time problem solving approach, your complete knowledge goes on vain. So you have to be keep on aligning yourself to the ever-changing global project requirements, your end user requirements as well as the project requirements as well. So only if you have the relevant right problem solving approach, you can justify or quantify your role or profile as a data scientist. And that's what the enterprises also look forward in you precisely. So my strongest recommendation for anyone, irrespective whether they are from IT or from non-IT or anyone who is looking out for a transition into data science technology, I would strongly recommend them to don't leave the learning curve or the learning process in data science technology. And on top of it, data science tools might come and go, but the concept and the skeleton of the data science approach in the technology remains the same. So it's always advisable to keep yourself updated in the field of data science in order to be an aspiring data scientist or to excel well in the field of data science. Yeah.
Thanks for your advice, Satish. So, what are the prerequisites to learn data science?
Yeah, I feel this is one of the most important question, and it is one of the primary question which is haunting every professional's mind today. I'd like to thank you for creating a platform for answering this question. Likewise, I said you before, there is no any mandate requirement that a professional has to be from an IT domain. Today, 73% of the professionals in India, okay, who are pursuing data science course or any certification are from non-IT industry. Because as I said before, data science has expanded its professional horizons in manufacturing industry, product industry, service industry, e-commerce industry, supply chain industry, healthcare, retail, and even media or entertainment industry. So the career prospects is laid over in IT as well as non-IT industry as well. If you would ask me, my sincere advice or thoughts on it would be, there is only one prerequisite required. That's only the interest and passion to learn data science. That is all. So my strongest suggestion for all the aspiring freshers or aspiring data scientists would be the interest and passion to learn data science, and if they have an attitude to solve the real-time challenges by thinking creatively, and if they are more passionate towards on the data analyzing skills, okay. And precisely, if you could see, data science is all about not just about analysis. It combines mathematical skills, it also combines programming skills, it also combines some IT, precisely it's computer science based skills, and aligning towards a data visualization techniques which acts as a pivot or a ladder for the enterprises to derive the business insights. So if on telling about this flow chart, you can see people from diverse cultures and diverse backgrounds are most welcome to pursue data science. This would be my strongest recommendation.
Thanks for your answer,
Thank you.
Satish.
In this session, we are just going to cover, or we are just going to offer you a 360-degree view of knowledge pertaining to the technology of data science, where this session also covers interview preparation and hands-on demo for learners or viewers' clarity. Let's get into the session.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Now let's go ahead to the nitty-gritties of how data science functions by understanding what is machine learning exactly. Alright guys, so machine learning is basically train machine how basically a certain task has to be done, right? In the most simplest explanation, this is what it is. I'll repeat it for you. So it is the science of teaching a machine how a particular task is done, right? Now in the further slides, I will tell you how this process is actually implemented. But if someone asks you what is machine learning, this is what you tell them. It's the process of making a machine learn how to get a certain task done. Okay, now let's go ahead and understand how machine learning basically works. How is this process basically implemented? So the first thing that you do as data science, the keyword says, it's all about data, right? If you want to make a machine learn something, it can only do so by making use of data. So first what you'll have to do is you will have to prepare your data in order for your machine to learn things. Okay, now let's say how you can go ahead and prepare data for a machine to learn. Okay, so let's take a very small example and then you can imagine it on a bigger scale. So let's say you have a data set which has been given to you by any company. Let's not get into the details of what this data set talks about, right? But let's just say there is a data set and there are 100 rows in that data set. Okay, what you do, the very first thing what you do when you have to basically prepare your data is you split this data into 70/30. Okay, so you will basically have 70 records in one file. So you had one file, now you have split it into two files. In the first file you will have 70 records and in the second file you will have 30 records. This is basically me trying to explain you that you have to divide the data set into a 70/30 ratio. Okay, now the data set with more number of records would be the training data set. So this would be the data that you will use to train your machine. And the latter part of the data set, right, the data set which is there in the second file which has less number of records will be your testing data set. All right, this is clear to everyone? If it is clear, please write a yes in the chat. Okay, moving forward, now let's take an example to understand the same particular concept that I've told you. So let's imagine you have images of fruits. You want to make your machine learn how it can identify fruits. Okay, so what you have is you have 100,000 plus images of fruits. And what you do when you start preparing your data is you divide the images into 70/30 ratio. So you will have 70,000 images which will be your training data set, and then you will have 30,000 images which will be your testing data set. So whatever I told you earlier, I've just put it into perspective that when you use fruits as an example, when you want to make your machine learn how to identify fruits, you first need a lot of images of fruits. So you have 100,000 plus images of fruits. Now before you begin training your system, you will have to prepare your data. In order to do that, you will first have to divide the data into a 70/30 ratio. This should be clear to everyone now. Next, what you do is you start implementing machine learning. Okay, now that you have your data prepared, you go ahead and now you implement machine learning. So let's go ahead and understand how that is done. All right, so guys, in the process of machine learning is basically divided into three phases. The first phase is the training phase, the second phase is the testing phase, and the third phase is the predicting phase. In the training phase, you feed the machine with the training data set, right? And don't worry, just listen to what I'm saying right now. I will give you an example and things will be more clear in just a second. Okay, so the first stage is training. So you feed the machine with the training data set. Once the machine has been trained, then what you do is you test the machine with the testing data set to see whether the machine learning model is working as expected. The third stage is the predicting phase. So what happens in the predicting phase is that now you give the machine any random image and you ask it whether it is able to identify that image or that data or not. Okay, so first what you do is you train your machine, then you test whether that machine learning model is working as expected, and then you give your machine arbitrary data and it tells you whatever you have taught it. Okay, now let's put it into perspective and let's understand this process using an example. So we will be taking the same example forward. So we had the testing data set of 70,000 fruits. Okay, so we feed these data to the machine learning model, and now the machine learning model understands, okay, what a fruit is. Now, to verify whether your machine learning model is working as expected, what you do is the remaining part of the data set, you feed it to the machine and you ask it what it is. So if it tells you that all of these are fruits, if they basically the machine learning model predicts the correct value, because in this case you already know that the images that you're giving to the machine learning model are fruits, right? So if your machine now is successfully able to predict that yes, these are fruits, you have successfully identified that your machine learning model is working correctly. Okay. Now in the third phase, what you do is the predict phase. What you do is you give your image, or you give your machine learning model any random image, and it tells you whether it's a fruit or not. Okay. Now this is exactly how machine learning model works, but the only difference when you implement it in real life is that you basically take care of a lot of things, and we will be understanding that slowly and gradually as we move along in this course. Okay.
Let's get started. The first question that comes to everyone's mind, okay, is that what is data, right? Data is nothing, right? But it's essentially just collection of facts, collection of information, which could be used for bringing about a meaningful output. Okay, data could be of various formats, right? It could be in the form of, let's say, in the form of numbers. Okay, it could be in the form of names. It could be in the form of various formats, right? For example, right now, while I'm talking, right, while I'm basically speaking, what I'm doing is I'm basically generating data, right? This speech that comes out of my mouth right now is being recorded, and it's being used. It could be used for future reference, right, for something meaningful, right? And that meaningful thing could be basically aided for a better or an improved learning for some of you, right? So when we speak, right, that's also data. When we consume information, let's say when we are watching a video on YouTube, that's also, you're also generating data there, right? Whenever you're interacting with, let's say, that button that helps you play that video, you're essentially doing nothing but generating data, right? When you scroll on Facebook, right, when you like a post on Facebook, you're not doing anything but you're generating data. Okay, so everything today, right, is essentially data, right? Because it could be used, right, for some or the other business purpose. Okay, so data could be numeric, it could be textual, right? It could be speech, right? It could be video, it could be images, it could be binary numbers, it could be formulae, everything that could be potentially used for bringing about a positive outcome. Well, positive is not the right word because you could use it for negative outcome as well, but whatever can be used for bringing about a meaningful outcome, that's essentially data for you. Okay, traditionally, right, traditionally the data that we had was mostly structured and small in size. Okay, and you could use, let's say, simple business intelligence tools, right? Let's say Excel or Tableau, okay, for analyzing this small, simple, unidimensional data, right? But unlike the data in traditional systems, the data today is mostly unstructured, or let's say semi-structured. Okay, when I say unstructured or semi-structured, what I mean is that the data that is getting generated from various sources, let's say uh, text files, right? Financial logs, multimedia forms, right? Images, video, audio, information that gets captured on sensors, right? Every machine, every machine nowadays has some sort of sensor in it, right? Which records information, which saves information. Okay, that information that gets saved in sensors, right, and instruments is also semi-structured or unstructured data. Okay, any data which is not in the form of rows and columns, okay, it's essentially either semi-structured data or unstructured data, right? Which means that you will have to apply additional effort to bring that data into a structured format, which you could then use for for bringing about a meaningful outcome. Okay, so I mean I right now, most of the data that gets generated is semi-structured data or unstructured data. Okay. In fact, it's a slight cliche, but um, the amount of data that we have generated in the last 2 years, okay, is equivalent to all the data that was being stored and generated before the last 2 years, right? In the history of mankind, all the data, if you put together all that data that was saved, that was stored before, let's say 2019, it is equivalent to the amount of data which has been stored in the last 2 years. Okay. So now that you're taking so much effort, now that every business, everyone is essentially taking so much effort to capture, to store all of this huge unstructured data, right? It is actually a responsibility for these businesses, right? That we basically come up with more complex and advanced analytical tools, right? And algorithms which could aid, which could help in processing, analyzing, and drawing meaningful insights out of this huge unstructured data, right? So data science is so popular today. It's because we are generating so much data, right? And businesses are realizing that they could potentially use this data to identify insights which could help them grow their business uh, by several times as compared to what they would have done before or be without using this data. Okay, all the businesses are realizing the power of using data for bringing about data driven decisions, right? Data driven decision making is something which everyone is realizing is so important, because if you as a business are not using data and your competitor is, then you're essentially losing out on a competitive edge from them, right? So that's one of the reasons why data science is so popular today, right? It helps you come up with a competitive edge, right? It helps you get insights out, right, which otherwise might not have been available to you. Okay, so that is one of the reasons why data science is so important. And this is not the only reason, right? This is not the only reason why data science has become so popular. Why data science is so popular today is because of the number of applications that you could possibly derive from learning data science, right? There are innumerable kind of use cases, right, that you could potentially derive out of data science. Also the usage of these use cases are so varied that you can apply data science across various domains and industries, right? It's not just limited to a particular domain. Let's say I just gave you an example of predictive maintenance, which is most common, let's say in a manufacturing setup, right? Which means within manufacturing you could definitely use data science, but it doesn't mean that you cannot apply data science in, let's say, insurance or banking, right, or healthcare, right? Data science today is being used, and there's so many popular use cases of data science across so many different industries, right? Just to give you a small glimpse, okay, let me show you a very interesting infographic. Okay, so this is an infographic which captures some of the most widely used business use cases, right, applications of data science across different industries. Okay, and this is not exhaustive, right? It doesn't capture all the use cases, it doesn't capture all the industries where you could potentially use data science, but I just want to give you a glimpse of what are the possible industries where you could apply data science and what is the outcome that you can derive out of using data science. Okay, so here is a very interesting infographic. Let me talk through couple of these. For example, in marketing, okay, in marketing there's so many different use cases of data science today, right? Customer churn, right? Churn is a very important use case of marketing, right? Today, if you can predict in advance, right, that this customer is going to churn, right, this customer is going to leave my services and join a competitor service, right? If that is something that you can predict in advance, right, then imagine then imagine that you can take efforts, right? That you can make efforts to improve the churn rate and improve the retention of your customers, right? So if you know in advance, let's say if I know in advance, I am a business, I know in advance that these are the 100,000 people that are most likely to leave my business in the next 30 days, right? Then in the next 30 days, I know where I need to focus on. I know that these are the 100,000 people who are most likely to leave, and also using machine learning, I can understand that what is that pain point which is forcing them to leave, right? Whether it's cost, whether it's customer service, whether it's user experience, what is it that I need to improve for specific components, for specific segments of customers that would help me retain my customers better. Okay, so that's what customer churn analytics, right, or churn prediction enables you to do, right? It enables you to understand in advance who are the customers that are most likely to churn, right? And it also enables with their toolkit to know what is the reason why this customer is leaving, right? And if you know that this is the reason why this customer is going to leave, you have, let's say, 30 days or 60 days to improve upon that parameter so that you can prevent that customer from churning, right? Let's say if I know, and based on this knowledge, if I'm able to retain, let's say, 50% of these 100,000 customers, then that in itself is a very big win for me, right? I'm able to retain 50% of the customers that would have otherwise churned, that would have otherwise moved out of my organization, right? All the effort that I had taken to acquire these customers would just be gone in no time, right? So that's where customer churn plays a very important role, right? What you do essentially is that you train your machine to understand the differences, to understand the relationship between customer churn, right, and various independent parameters such as, let's say, cost, right, let's say customer service, let's say user experience, right, let's say uh, competitors, right? What is it that is leading for a customer to leave, right? And you try and use machine learning to come up with an equation, right, which could be then applied for customers in future and help, and that will aid in making predictions. Okay, so that's customer churn. There are a lot of there's several other applications as well. For example, cross selling and upselling. You can use machine learning to understand if a customer buys X, right, what is that next best product that you can uh, push to the customer, right? And there's a good likelihood that that customer will end up buying that product, right? That customer, when it came to you, he came to you with the intention of buying X, right, which would have led to $100 sale for you, right? But because of knowing that this customer might already need another product, right, this comes from the understanding of their transactional behavior, this comes from the understanding of their demographic behavior, right? You are able to predict, okay, that when customer buys X, right, he or she is also likely to buy Y, right? And you basically make that available to that customer, right, in the form of assortment, in the form of recommendations, right? And when you do that, instead of generating $100 sales from product X, you are also generating, let's say, $150 sales from product Y, right? Now it is likely that not it is likely that 100% of the customers who you have recommended Y might not buy it, but even if 25% people buy it, that's incremental sales for you, right? So that's cross selling. There's also a concept of upselling wherein you see that if a customer has bought a slightly inferior service, and this is mostly true in the case of services, right? You try to identify who are the set of customers, right, who are most likely to move to an updated service, right? Today, let's say I am using an internet service from a telecom provider um, where I use let's say 500 GB of data. Okay, now every month, right? Now using this information and using this information from a lot of other customers, what my telecom provider could predict is that because I am already using close to what my quota is, what if they propose to me a plan, okay, which offers me, let's say, 100 GB more, right, with some additional cost, right? And I'm most likely to buy because I'm already sort of exceeding, or I'm very near to what my threshold um, my quota is, right, for data consumption.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so basically providing me an upgraded service, right, at some additional cost, right, which is of course as a profit generating source for the organization, right, revenue generating source for the organization, right. So that's cross selling, that's upselling. Digital marketing is very popular in the market right now, right. You use ads, right, you use, because everyone is on social media, right, everyone, uh, let's say everyone uses Instagram, everyone uses Facebook, everyone uses YouTube as well, right. You push ads on these platforms so that, and you do this in a very targeted manner, right. You understand what are the demographics that you need to target to, let's say, promote your business, right. Who are the set of customers that should see your ad, right. And you push ad campaigns on these webs, on these platforms, and basically use these ads to improve awareness of your brand, or you could also use these ads to drive traffic to your own website. Okay, so digital marketing is very popular today because of the absolute scale, right, absolute volume of audience which is available on these social media platforms, right. Digital marketing, sentiment analysis, again, right, it's a very popular advanced analytics use case where you use social media reviews, right, social media comments, etc., to understand the perception of customers about a particular brand, right. Let's say if I'm Apple, right, I'm coming up with iPhone 12. Okay, I can, and let's say people have bought iPhone 12, right, from Amazon, and there are 100,000 people who have bought it. Out of those 100,000 people, there are 10,000 people who have written a review about their purchase on the website, right. Now, of course, it's almost impossible for a human to read through 10,000 reviews, or if even if they do that, it would take them several days to do that, right. What you could do is you can essentially capture that data and try to generate the sentiment of those reviews, right, whether the sentiment is positive, whether the sentiment is negative. If there's a negative sentiment, what are the primary themes, what are the primary reasons why your customers are coming up with a negative sentiment, right, so that you can work upon them and improve them, right, for future purchases. If there's positive sentiment, then you understand what is it that is driving positive sentiment, and you do more of that, right. So a lot of different use cases of analytics, of data science across marketing, social media, automation. Of course, automation is all about machine learning, data science, right. Tesla is coming to India soon. Tesla is all about AI, right. um, so it's all about AI. It's all about reducing the effort for human beings, right. There's a lot of interesting use cases of healthcare, of analytics in healthcare, right. Clinical trials, by the way, is one very popular use case of data science in the healthcare industry. You can use statistics, you can use data science to predict the effectiveness of let's say a vaccine, right. If, because of the recency of it, I can say that, let's say, um, when India was coming, or when any healthcare firm was to generate, was basically building a vaccine, they have done clinical trials, right. They've used data science, they've used statistics to understand what is the effectiveness of their vaccine, right. uh, how this is done is a slightly um, complex approach, but let me give you a very quick overview of how this could be done, right. Let's say, you, like, anyone who's trying to build a vaccine is trying to build a vaccine for, let's say, 100 million people, right. Or if they're in India, they're building a vaccine for, let's say, 1.3 billion people, right. And there are almost thousands different traits of people, right, or 1,000 different varieties of people who could possibly consume that vaccine in the future, right? So when you have to you have to do clinical trials, when you have to justify that your vaccine is working, it is effective, and it does not have any side effects. When you're doing sampling, right, of course you cannot, when you're doing clinical trials, you cannot you cannot use everyone to do a trial on, right? You will have to pick a sample, okay, and that sample has to be such stratified, it has to be done in such a manner that it captures the uh, captures all the attributes of the entire population, right? Unless the sample which is used to test the effectiveness of a vaccine to be declared whether it's a good vaccine, whether it's a poor vaccine, whether it's let's say 90% effective, you have to ensure that the sample that you have taken into consideration, that the sample of humans that you've taken into consideration for testing your vaccine is representative of your entire population. If it is not representative, right, then it is a risk, because let's say you did not take into consideration all the diabetic people, right, into your sample when you did clinical trials, and you said your vaccine is 90% effective and it does not have any side effects, but later on when it was rolled out to everyone in the population, right, and let's say for all the diabetic people there were several side effects that were observed, right, or it did not show any effectiveness for diabetic people, then that's a huge disappointment for the vaccine, right? That's basically a bloat, a black mark in their on their name, right? So statistics is also very important there. Data science is very important in the sense making sure that your sample is representative, your sample is chosen um, such strategically, right, in such a manner that it takes into account all the different demographics that could potentially exist in the entire population. Okay. um, Credit and insurance is another very popular domain where data sciences is used. Okay, every transaction, every credit card transaction that you do, by the way, it goes through a machine learning model. That machine learning model predicts, okay, whether the transaction that you made is it has certain signals of a fraudulent transaction or not. Only if the model says that this transaction that you've done does not have any signals of fraud, that's when that transaction will go through. Otherwise that transaction will be blocked, right, and it will go through a manual test. Okay, so fraud detection model is so important, of course, because of the volume of credit card transactions that happen today. Every day I'm sure millions of transactions are happening across the world, right, and the amount of monetary value that is associated with those transactions is huge, right? Even if let's say 10% of those transactions were fraud transactions, then it's a huge loss for the credit card organization, right, because it has to repay its customer on any fraud that has happened to them, right? So for that reason, what credit card companies do is they basically make use of historical data. They make use of machine learning to identify traits of fraudulent transactions and traits of non-fraudulent transactions, conceptualize that in an algorithm such as, let's say, linear regression, logistic regression, etc., right, and use that model, right, predictive model, on every transaction that goes through. Okay, only if the model predicts that this transaction is a non-fraudulent transaction, that's when it will go through. If it says that it's a fraudulent transaction, then that transaction might be blocked, or that transaction might have to go through a manual review, and then it will take some time for the reviewer to understand what that transaction is all about. You might also get a call to understand whether the transaction is fraudulent or not. Okay, so a lot of different use cases across healthcare, across sales, across travel, right? Everywhere there's data science, and as I said, right, this is not exhaustive. There's so many other applications which you've not even touched upon in this infographic, right? So because there's so much that you could do potentially using data science, that's why data science is so popular. That's why data science is almost indispensable in today's world. Okay, so why data science is important? Because it helps you in understanding your data, right? It helps you in identifying interesting insights, right? Insight is nothing but an information, a finding which is actionable for the business, and it basically can be used, okay, to come up with an action, right, which would lead to improvement for your business or improvement for any mostly for business, right? So yeah. And then of course, by identifying those interesting insights, you could make informed decisions about your business, right? You can come up with actions, you can come up with strategies, right, to efficiently counter those insights, to efficiently handle those insights that you've sort of extracted from data science. Okay, all right. So what we're going to discuss now is understanding what is data science. So to start with, in the most easiest manner, if I have to define data science is nothing. Okay, data science is nothing but it's the science, okay, of applying mathematics to data. Okay, it's the science of applying mathematics to data so that you can make the data talk to you. Okay, when I say you can make the data talk to you, it means that you enable interpretability of raw data, right? You make data talk to you in the sense that you are able to generate insights, generate hidden patterns out of that data. Okay, that's how I would define data science. Also, let's say if I were to formulate a chemical equation, right? I'm sure a lot of you might have, like in chemistry, you might have learned about different equations, right? Something like H2 plus O2 gives you H2O, something of that sort. If I were to build a similar equation, okay, my equation wasn't correct, by the way. When I said H2 plus O2 would give you H2O, okay, you'll have to balance it. But if I were to form a chemical equation, an equation which will give me what data science is, okay, this is how I would do it. I would say it's nothing but data, okay, plus math, okay, and in my right hand side I get insight, okay. But we are not done yet, because to process this data through math, you need a very important catalyst here, right, which is nothing but technology, right? You need technology to be able to process data and apply math on it, right? If you're not able to use tech, if you didn't have technology in here is nothing but the computers and the supercomputers that you use to process large volumes of data, right? The memory that you use to process large volumes of different varieties of data, right? And then apply mathematical algorithms to them, then apply statistical algorithms to them to generate hidden information, to generate insights which were otherwise hidden to us, right? So that's what data science is, okay. And by the way, there's no perfect definition to data science, right? You like even this definition, the definition that I just presented could also, I mean, I'm not saying it's a flawed definition, but I'm saying that there's no perfect definition in the sense because it's such a vast concept that you can't really create a one sentence definition which could encompass everything that data science is comprising of. Okay, so data science is nothing but it's essentially a blend of various tools, algorithms, right, and different machine learning principles with the goal to discover hidden patterns from raw data. Okay, the ultimate goal here is that you generate insights, to generate patterns which were otherwise uh, not visible to our naked eyes, right? Now you might ask me, right, some of you might ask me that how is this different from what a business analyst does, right? Or how is this different from what a data analyst does, or how is this different from, let's say, what a business intelligence officer does, right? All of these roles are in the domain of analytics, right? But how is a data scientist different from these two or three other roles that I mentioned? The answer to this basically lies in the difference between explaining and predicting. Okay, the answer to this basically lies in the difference between explaining and predicting. Okay, what analysts, or let's say a business intelligence officer, would do is basically what they do is they've been deriving findings. Okay, they derive findings, they derive insights by processing the history of data. Okay, they look at the historical data, they look at the trends, and then they present to you what is the information that is coming out from that historical trend. Okay, on the other hand, what data scientist does, that's the data scientist not only does exploratory analysis to discover insights from historical data, but they also use various advanced machine learning algorithms to identify the occurrence of a particular event in the future.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Right, so data scientist doesn't just explain what has happened in the past, okay, but they also use the learning of the past to predict something which is going to happen in the future. Okay, an example to that would be, let's say you were looking at the sales of an organization. Okay, let's say I build a time series graph. Okay, a time series graph. Here I have time, which is, let's say, month year. Okay, this is month, and here I have sales of a product. Let's say sales of iPhone. Okay, this is first month, second month, third month, fourth month, fifth month, etc. This is the sales, right? This is the sales, and let's say all of a sudden there was a huge spike. Okay, and then let's say it's sustained. Okay, what a data analyst would do is that, or what a business analyst would do is that they will make this information available to you, right, by processing data. Okay, also they might do a detailed deep dive to understand why this spike was observed, what was the reason of the spike, right, in the sales of iPhone in the market, right, whether it was let's say because there was a discount that was offered on the product across the world, or let's say there was a different model that was released. Let's say iPhone Red was released in this month, and hence this happened, right? So they will do a deep dive. The data analyst would do a deep dive and understand why this happened. But what a data analyst wouldn't do is that beyond what has already happened in the past, they will not come up with prediction of this. What a data scientist would do is they would basically consume this information, okay, historical information, and try and correlate this trend with a lot of independent variables, right? When I say independent variables, I mean variables that could have caused, that are basically responsible for this trend, right? There are different things that are responsible for sales of a product in a particular manner, right? That it could be, let's say, the purchasing power of people, it could be macroeconomic factors, it could be um, different features that you've introduced in a mobile phone, it could be discounts that you offered, etc., right? So what a data scientist would do is it would basically try and find relationship of sales of the product, okay, with all of these independent variables. They would try to encapsulate that in the form of an equation, right? And using that equation, they will try and predict the sales of this product in the future. Okay, so that's what a data scientist does. A data scientist doesn't just explain what has happened in the past, rather they build algorithms, they use machine learning algorithms to make predictions in the future as well. Okay, and we will learn this better, right, in the next slide. I'm going to do a very clear segregation of where is it that the skill set of data scientist is essentially concentrated. Okay, but you should understand that a BI officer or a data analyst would essentially analyze previous data to find hindsight, right, and insight to describe business trends, right? It enables you to take data from various external and internal data sources, prepare it, run queries on it, right, and create dashboards to answer questions like, let's say, quarterly revenue of an organization, or let's say any other ad hoc analysis, right? They can also evaluate the impact of certain events in the past, right? But data science, it is more forward looking, right? It's a more forward looking approach. or you could say an exploratory way by which uh, you can focus on analyzing the past or current data and use that to predict the future outcomes, okay, with the aim of making informed decisions, right? So you try to predict the future, but knowing that based on any, like if you do not do any interventions, this is how the future is going to look like. But if you could do certain interventions, then you could of course change uh, that pattern, change that trend, right, by putting additional efforts, putting additional incentives for the user. Okay, so what data science lets you do is it basically tries to answer more open-ended questions like why, what, and how an event would have happened, right? Rather than just describing that this event happened, right? It tries to focus on the why, what, and how of things, right? And using that, they come up with more meaningful conclusions. Okay. Also, data science is an umbrella term, right? It's basically a combination of multiple domains or multiple tools, resources, you could say, right? And some of those resources are mentioned here, right? So it basically takes into consideration visualization. It takes into consideration data manipulation, right? So collecting data through various sources, aggregating it, transposing it, cleaning it, improving the quality of the data, etc. All of that comes under data manipulation, right? You will have to do that in irrespective across all your data science projects, right? It also includes statistical analysis, like statistical exploratory analysis to get a better understanding of your data, right? The relationship between various dependent and independent variables, right? And then use all of this learning to build a machine learning model which has a good accuracy, which has a good predicting power. Okay, that's what data science essentially enables you to do. Moving on, what are the different types of data analytics? Okay, uh, this is important for us to know that what are the different domains of data analytics. Okay, because it would help you distinguish between different roles which are there, right? And it will also help you understand where is it that data science focuses on, where is it that you should try to develop your primary skill set on. Okay, so there are four major domains of data science. Okay, the first one is called descriptive analytics. Descriptive analytics is nothing but it's essentially focused on describing what has happened in the past. Okay, this is what business intelligence officers do the best, right? So creating dashboards, creating reports which describe historical events, describe the trends of historical events or trends of any variable. Okay, let's say trends of sales of various products, trend of revenue of an organization, trend of or like of course or pre-post analysis of a particular feature, etc., right? Where you're just trying to describe information, right? Describe what has happened in the past. That's descriptive analytics, right? So all the reporting, dashboarding, etc. comes into descriptive analytics. Okay, uh, this is a domain where data, like there's some focus of data analyst, right? And the primary focus of business intelligence officer lies. Okay, so this is that domain. The second domain of data of analytics is called diagnostic analytics. Okay, diagnostic analytics is basically when you try to do a deep dive on a particular event that has happened in the past, right? So remember I was showing you that trend, right, where we were looking at the sales of iPhone in the last 12 months or in the last 1 year, etc. Okay, and we saw various spikes and troughs. Right now, if you decide to do a deep dive, okay, on a particular trend, uh, on a particular pattern, to understand why that pattern had happened, right? Let's say if you saw that the sales of your product increased in July, and you do a statistical analysis to understand why that peak happened, right? Why you try to understand the why and how of a certain event by doing statistical analysis, by doing correlation analysis, by doing exploratory data analysis, right, to understand the root cause of the problem, right, or to understand the root cause of of a positive trend as well. That's called diagnostic analytics. Okay, what you need for diagnostic analytics is descriptive analytics, right? So you basically consume a historical trend, right, and then you decide to do a deep dive on it by trying to validate or disprove various hypotheses, right? So for example, uh, if you saw a spike in the sales of iPhone in July, okay, you can come up with various hypotheses, right, that why that sales could have gone up, right? It could be because of discount, it could be because of new product, it could be because um, of a particular campaign, it could be because of um, let's say like probably there was no other competitor in the market. So a lot of different hypotheses, right? And then you decide to do an analysis to either prove or disprove each of these hypotheses. That is something that you do when we talk about diagnostic analytics. Okay, so that's diagnostic analytics. Analytics is something where business analysts and data analysts are concentrated. Like this is what the primary skill set of data analysts and data and business analysts is. Okay, so this is DA and BA. Okay, this is the first one is basically the prime focus of business intelligence officers. Okay, people who do MIS officers as well. Okay, the third domain of analytics is called predictive analytics. Okay, predictive analytics, as you would know, right, and I think I've been speaking about it over the last few minutes as well. It's basically a technique where you use historical data, right? You use historical data, feed it to a machine, right? You let the machine use its intelligence to derive relationships between the dependent variable and various independent variables, right? And then using that relationship, come up with predictions about what is going to happen in the future. That's what predictive analytics is all about. Okay, so basically using techniques like machine learning, deep learning, etc. Okay, to come up with models, right, that can predict the occurrence of an event in the future. That's what predictive analytics is all about, and this is where a data scientist should focus on, right? This is the primary focus of data scientist. Okay, however, it doesn't mean that the data scientist should not be able to do the first two, right? Data scientists should of course have the skill set to perform both descriptive analytics and diagnostic analytics, right? Because those are important for you to get a better understanding of your data, right? And once you have that skill set, once you've done that, only then you can do a good job of doing predictive analytics, right? So the primary skill set of a data scientist is still predictive analytics, but it doesn't mean that he or she doesn't need to do descriptive analytics and diagnostic analytics, right? You might not spend, let's say, 50% of your time doing descriptive and diagnostic analytics, but still 20% of your time would go into doing a descriptive analytics or diagnostic analytics, and 80% of your time would be on predictive analytics and prescriptive analytics as well. Okay, so prescriptive analytics is the fourth domain of analytics, where instead of predicting outcomes, right, you use concepts of diagnostic, descriptive, and predictive analytics to prescribe outcomes, to come up with recommendations. Okay, a very good example of this is recommendation engine, right, wherein you use machine learning not to influence an insight, right, to grow a business, rather to come up with a recommendation, right, to come up with an output to the end user that they could consume directly. What you're doing in recommendation engine, for example, the Netflix recommendation engine, what it is doing is it is prescribing to the user that why don't you watch this movie X, right? Because of all the other movies that you have watched, I feel that you have a very high likelihood that you are going to like this movie, right? So I'm prescribing you that you watch this movie. That's what Netflix is doing, right? So wherever you're prescribing an output, wherever you're recommending something as an output, as an outcome to your user, okay, that's prescriptive analytics. Okay, so our data science primarily works on predictive and prescriptive analytics, right? And let's say 20 to 25% of their time also goes in performing descriptive analytics and diagnostic analytics, right? In the same manner, a data analyst would be primarily focused on diagnostic analytics, right? This is where a data analyst 80% time of a data analyst would be concentrated. then the rest would be concentrated across other domains, right? So they might develop a skill set of doing a little bit of linear regression, etc., right? Which is something that will come under predictive analytics as well, right? So primarily a data analyst is focused here, primarily a data scientist is focused here, and primarily a business intelligence officer is focused here. I hope this is clear. Okay, now what we are going to do is we are going to learn about the life cycle of a data science project, right? Or let's say life cycle of data science. Okay, why I'm calling it a data science project? Because this essentially captures all the different stages, right? All the different phases that are actually involved in any data science related project that you pick up, right? Like a proper data science project, right? Which means, let's say if you pick up a business problem, okay, you will have to go through multiple stages to reach a desired state or reach a final end state, right? Which would be building a prediction model that can give you the output with, let's say, 90% accuracy. Okay, so let's try and understand what are the different stages that are involved in any data science project. Okay, here are, let's say, 5 different stages. Okay, 5 different stages that are involved in any data science. I mean, this is very general, like very you would say very standardized sort of an approach, right? You could say that this is relevant to.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
85-90% of projects, right? But in certain projects, you might want to skip a couple of stages as well, right? But in most cases, you would end up performing each of these stages that are being referred here. Okay, so we start with data acquisition, we go to data pre-processing, we go to model building, we go to pattern evaluation, and then we go to knowledge representation. These are the 5 steps, right? 5 stages which are common, and this is in sequence. Okay, this is in chronology, right? You cannot do data manipulation first and then do data acquisition. No, it's all sequential. Okay, and finally you reach your end your desired output. Okay, desired state. Now, what do each of these stages encompass? Okay, so see, every data science engagement, every data science project basically goes through these 5 stages. Okay, and as I said, right, when I say every, I'm talking about, let's say, 85 to 90% engagements. Okay, the first stage of data science, okay, is called data acquisition. All right, it's called data acquisition. Now, as about extracting data from various data sources, right? It could be cloud, it could be different databases, right? Relational databases, etc. Right? Making use of ETL tools. It is correct. Okay, that's right. That's what data acquisition is all about. Okay, there's just one very small piece of information which I would want to share with all of you, which is very important even before data acquisition. Okay, so even before you start a project, okay, it is very important for you to understand what is the business problem that you're trying to solve. Okay, when you know what business problem you're trying to solve, it is important for you to come up with a factor map. It is important for you to come up with all possible hypotheses, right, which could lead you to an answer to that business problem. Okay. And why it is important for you to, and this is something which comes under scoping. Okay, so you're basically trying to scope your business problem in the sense that you're trying to identify all the possible parameters that could have an impact on the problem that you're trying to solve, right? Let's say the problem that you're trying to solve is customer churn. Okay, you're trying to solve, you're trying to build a model, right, which could predict in advance whether a customer is likely to churn or not. Okay, now even before you start collecting data, it is important for you to do this step, right? Because only if you know what are the parameters that could have an impact on your final output, which is data, which is customer churn. Unless you know that, you can't really start collecting data, right? I mean, unless you know what variables will lead to a data churn or could lead to customer churn, what data would you collect, right? So the first step is essentially discovery. Okay, or scoping, right? So what you would do is you would try and come up with various hypotheses, right? Let's say hypothesis one is I'm trying to solve for customer churn, right? So let's say we try to problem solve and understand that what are the different parameters that could impact customer churn, right? So the first one um, could be the cost of services. Okay, cost of services, right? Let's say I'm talking about a telecom provider, then I would say what is the cost of the internet or data services that the telecom provider is providing, the telecom provider is giving. Okay, that's let's say one variable that could be one hypothesis that could lead to customer churn, right? If the cost is high, that could be a valid reason for customers to move out. Okay, what could be the second reason? The second reason could be let's say demographics, right? It is possible that the certain cities, let's say the network provider is concentrated in tier 1 cities, they do not have enough they're not paying enough attention to, let's say, tier 2 cities, tier 3 cities, suburban cities, right? So let's say demographic of customer, where the customer is located, could also be a reason for customer churn, right? Demographics. Okay, then the third reason could be, let's say, the kind of internet service that a customer is using, or let's say the kind of data services that customer is using. Okay, you might be on a low bandwidth internet service, right? And because you're on a low bandwidth internet service, you're facing problems, and hence you decide to move out, right? So the kind of internet service that you're using. Okay, then there could be many other reasons as well, right? There could be reasons uh, like the customer has been trying to reach out to the customer service department, but he did not get a satisfactory response, right? So customer service, a poor customer experience, let's say. Okay, and similarly, there could be, like, when you build a model, right, you would do a detailed problem solving to understand what are the various parameters that could lead to customer churn, right? And now let's say these are the four, and similarly you will build a map that will try and cap it'll be you will try to build a very exhaustive sort of a like factor map, right, which will capture most or all of the factors that could lead to customer churn, right? And now that you know that you basically, these are all the parameters that could lead to customer churn, now you could go about doing your data acquisition, right? Now you know that I need to get data which is about the transactional behavior of customers. So I need to get transactional data which will tell me the cost of the data services. I need to get data with respect to the demographics of my customers. I need to know where they are located. I need to know what is the age group. I need to know whether they are male or female. I need to know how many people they have in their home, right? So that's demographic. Third is I need to know what is the kind of internet service that they're using, right? So I need to dig into the data which captures the internet, like the latest snapshot of the services that the user is subscribed to, right? Then I need to understand whether the customer has been satisfied with the kind of services, the customer service experience of the customer. So I will basically log into the call data, right, the call center data, and try to find out how many calls the customer has done and what was the average handle time of those requests, or let's say whether the customer had a good experience or not, right? Something of that sort. So this scoping would essentially help me identify what are the possible data sources that I need to then collect data from, right? And when you do this, that's when this step would come, which is called data acquisition, right? So the first step is scoping the problem. The first step is understanding what data to collect, and then going about collecting that data, right, from various databases, right? So it is possible that not all of this data is available, right? It is possible that not all of this data is available at the same in the same database. You might have to go to different databases to capture all of this data, right? So that is something that comes under data acquisition. I hope this is clear. Okay. Now the second step is data pre-processing. Okay, what data pre-processing means is that when you collected data from various sources, right? Let's say you've collected data from 10 different sources, right? You have transactional data, then you have customer service data. Okay, customer service. Please pardon my handwriting here. Then you have data from, let's say, demographics, right? And then you could have, let's say, 4 other data sources, data tables as well, right? Now what you will have to do is you'll have to merge all of this information together in a singular composite database, right? You'll have to create a data model, right? You'll have to create a table. Okay, and that table could be in R, it could be Python, it could be in any language. Okay, you'll basically have to consolidate all this data together, right, to create one composite database. Okay, you cannot let data be there across different data tables or data sources, because a machine learning model can only work on one database at a time. Okay, so you will have to bring all of this information together. You will have to create one composite data set, right? That comes under data pre-processing, which is joining data from various data sources. Secondly, what you will have to do is you will have to improve the quality of your data, right? Which means it is possible that you have transactional data for all your customers, but you do not have, let's say, demographics of 20% of your customers, right? If you don't have demographics for 20% of your customers, it means you will have to reject their transactional data as well, right? So when you're creating a composite database, you will have to make sure that the quality of your data is good and the data is complete, right? Wherever there are variables which are missing for a particular customer, you will have to either impute that data with the most accurate interpretation, or you will have to reject that data, right? So basically, uh, joining data through various databases, aggregating data, summarizing data, transposing data, transforming data, cleaning of data, missing value treatment, outlier treatment, all of that happens in data pre-processing. Okay, basically what you're doing is you're preparing your data so that it could be used for mathematical modeling. Okay, so this is what you do in the second step, right? Now the third step is called model building. Okay, what this step basically includes, this step is basically what you will do is you will determine the methods and techniques to draw the relationship between variables. Okay, these relationships will essentially set the base for the algorithms which you need to implement in this stage, right? So basically what you'll do is there are various machine learning algorithms that you could use. Okay, there are various machine learning techniques that you can use for a particular type of business problem, right? For, let's say, for building a predictive model that could predict customer churn, you can use various techniques, right? You can use decision trees, you can use random forest, you can use gradient boosting, you can use logistic regression, you can use support vector machines, you can use uh, multiple algorithms, right? There are so many algorithms in the market which will lead you to some output. Okay, so in this stage what you would do is you would basically, and there's no one, right, there's no data scientist who can predict, okay, uh, without trying, who can predict that this is the algorithm that's going to give you the best output irrespective. Okay, it's always good to test out multiple algorithms to see which algorithm gives you the best accuracy, which algorithm gives you the best output, right? Because there are different data distributions that could suit a particular algorithm best, right? And Of course, with experience, you might get some understanding on what data distribution could suit a particular technique, right? But even today, for example, even today, I try to build a model, right, after testing out at least 4 or 5 different techniques, right? And whichever technique gives me the best interpretability, the best accuracy, the best robustness, I try to choose that methodology finally, right? So model building is when you use the data model, test out, iterate through various techniques, right? And then evaluate, right, which technique gives you the best output, the best, most accurate solution. That's the technique that you use and build your final model on. Okay, so that's all of this comes under model building. Okay, now what you've done is, okay, so far what you've done is you basically collected data through data acquisition. You process that data, right, to create a composite data structure which can be used for model building, and then you've iterated through various models, through various machine learning techniques, and you've chosen that this is the machine learning technique which will give me the best output, and you built your model. What happens next? The next step is basically called pattern evaluation, because in this step what you would do is you would try to interpret your model. Okay, your model is giving you certain results. Okay, it will tell you that this customer is most likely to churn, this customer is least likely to churn, right? But where is the insight here? The insight is when you try to evaluate the pattern associated with your predictions to understand what are the reasons for customer churns and what are the reasons for customer retention. What leads to customer churn? What leads to customer retention, right? Unless you do that, your business will not have enough insight, right? Even if you, let's say, for example, I have predicted that customer A and customer B and customer C are going to churn in the next 90 days. What would the business do if they do not know what they need to do to stop those customers from churning, right? Unless they know what is driving that customer to leave the organization, it is very difficult for business to come up with incentives, come up with interventions, right? So in this step, what we do is we try to correlate the results of the model. We try to interpret the results of the model with the the independent variables that you've included to understand the reasons for the output, right? The kind of output that you're getting, right? So you create segments, right? Let's say your model has predicted 100 customers for churning, right? You create out of those 100 customers, you will basically evaluate their pattern and find out that the first 10 customers are churning because they are not satisfied with the price of the services, right? They're churning because they feel the price of their services is too large, too huge. The second set of customers, let's say the next 20 customers, are not satisfied with the customer service that they got. Okay, now when you do this, when you create 5 different segments, let's say, your business now has targeted way to influence these customers, right? And so the first 10 customers who are leaving because they were not satisfied with the cost of the services, you can give them discounts, right? The business can come up with, let's say, a different plan altogether which will suit their requirements and help them retain with the business for longer, right? The second set of customers who are not satisfied with your service, with your customer service, you can proactively call them and of course apologize first of all and say, like, we're really sorry for the kind of services that we've given you, but we are happy to help you now. You are our valued customer. Please tell me how we can help you. What is the problem that you've been struggling with? And you try to get the best resolution out, right? So basically in this step, what you do is you interpret the findings of your model, you try to correlate it with your uh, with your um, with your data, with your various variables, to make the recommendations, right? To come up with recommendations, to come up with outputs which are actionable for the business to implement. Okay, that comes under pattern evaluation. Okay, and finally, the last step of your data science engagement is called knowledge representation, right? Knowledge representation is nothing but when you present the output of your model, when you present the learnings of your model, when you present the output of your model to an audience. Let's say any machine, let's say any project that you pick, right? Any project that you take has to be finally presented to, let's say, the leadership of an organization or any business stakeholder, right? That is what comes under knowledge representation. Or you might, let's say, if you were to summarize the results of your model in a presentation, in a PowerPoint presentation, or let's say you have to publish, let's say, a paper, right? A research paper which captures all the learnings of your model, etc. All of that comes under knowledge representation, right? Usually knowledge representation would mean visualization of our data, right? Visualization of the output in the manner so that it basically becomes interpretable and understandable for audience who doesn't really understand data science so well, right? Usually the CXOs of your organization might not understand technical terminologies which are associated with data science models, right? So you will have to create visualizations, you'll have to create graphs to break down those technical terms, right? Break down those technical analysis in a simpler manner, which is understandable, which is something that could be consumed well by your primary audience, right? And that's something which comes under knowledge representation. Okay, and when you do that, it means that the last phase of engagement has ended, which means you've presented your results. Then the leadership will take a decision whether they need to productionize your model or whether they need to reject your model. You will tell them that our model is coming up with an accuracy which is 80%. 80% of the times we'll be able to tell you that this is the customer who is going to churn, right? And we will also tell you that the reason why they're going to churn, right? And if our predictions are good enough, then you'll be based on what interventions you decide to take, you'll be able to retain, let's say, 30% of these customers. If the business is happy with the recommendations that you're giving, right? If the business is satisfied, yeah, this is a very good model that you made, then the final step would be then productionizing your model, making it a part of your whole data infrastructure, and then so that this could be done in a more automated manner, right? Then converting it into an application, right? An AI tool which is integrated with your database. Okay, so that's knowledge representation. By the way, when we get into building machine learning models, right? In fact, this whole course is structured in a way that you do all of this one by one, right? So data acquisition, of course, we will not do because it doesn't come under the purview of R. Like you already have some data available with you, right? So you might not do any data acquisition, right? Data acquisition is usually not done in R. It's done in using ETL tools like Alteryx, SQL, etc. Okay. So assuming this step is done, from here onwards, which is data pre-processing, model building, pattern evaluation, knowledge representation, all of this we will do in R, right? In any problem statement that we do, we will basically walk through each of these stages. Okay.
So now let's take a look at the data science process. How does a data scientist go from analyzing the problem to coming up with a solution? So the first step, as always, is understanding the business problem. It's quite important to understand the business problem and then understanding it correctly so that on a later stage, you are bound to be solving the right kind of problem that needs to be solved. Then comes data gathering. This is why the first step was so important, because if we did not understand the problem correctly, then we would end up gathering data that is not really required. Data gathering basically means the task of getting data from multiple sources and then storing it in a specified format like CSV file, SQL files, so on and so forth. And then from that data, we move on to the next step, which is data analysis. In this, we extract some key highlights or information about the data that we have, the formats of the data, what are the minimum and the maximum values, how much data do we have, how many rows, how many columns, so on and so forth. Then we move on to processing data, in which we remove unnecessary columns. We understand how to convert one form of data into another to make them both conform to a similar format, and so on and so forth. Then we take a look at data visualization. We visualize the data to extract some information out of it, to understand the trend, to understand the size of some data, or to figure out the range of the data. If there are some outliers, if there are some data points that are just way outside the limit of normal data points and they are influencing our predictions badly. Then we move on to data cleaning. We remove the outliers, we remove inconsistent data, we remove columns that do not have a good amount of data in them, and so on and so forth. And finally, after we have done with all that, we move on to creating a model. A model is a mathematical representation of a real world information that we have extracted from the data that has gone through all the previous steps. So the first step in the data science process, as already described, is understanding the business solution. Now, this is really important, mainly because if you don't understand the business problem correctly, then you end up solving the wrong problem and end up spending a lot of time. So to give you an example, suppose that you were to build a movie recommendation system. Now, this is pretty vague description of what the problem is, because a movie recommendation could be a movie recommendation engine that suggests you movies based on the movies that you watched previously. It could also be a movie recommendation engine that recommends you movies based on your geographical location, or it could be movie recommendation engine that looks at the movies that have been watched by users who are similar to you and then suggests you those movies. So depending on the kind of problem that we choose out of these three, we will have to gather different kinds of data, which is why understanding the problem is the first and the most important part of this process. Then we move on to understanding. We ask the why. So why are we trying to solve this problem? What benefit does it provide us, or why would this solving this problem is so important to us? And then we move on to understanding the end product. As we discussed, what kind of things we're trying to solve, what are the problems that we might face, and what is the thing that our product is supposed to produce at the end of the day. And then we move on to determining the data sources for this problem. Depending on the kind of problem that we're trying to solve, the data sources could be very different from each other. We could extract data from one source, and we could also extract data from another source. Depending on the data source that we have chosen, we will get the right kind of data, or if we have chosen the wrong data source, then we'll get the wrong kind of data and we won't be able to solve the problem that we wish to solve. Then we move on to gathering information and gathering the required context. And when we get the required context, when we get all the information that we need to solve this problem, we move on to the next step, which is data gathering. So data gathering is the process of retrieving data from various sources, which is to be used in a data science process. So to give you an example, a data science process, data can be gathered from various sources such as CSV files. We could get it from the internet using a web API or web scraping. We could also get data from SQL databases. We could get it from NoSQL databases. We could get it from a third-party source. We could get it from user surveys. There are lots of ways that we can get the data from, but the main important part is we're gathering the right kind of data. So if we end up gathering the wrong kind of data, what ends up happening is that we get the data that we wish to solve the problem. However, we have gotten the wrong kind of data, and that data is not useful for us to solve the problem, and we have essentially wasted a lot of time in gathering data that we do not need. So when we move on to the next step, we need to understand that we have gathered the right kind of data, which is why the first step was so important. Then comes data processing. So when we're trying to process some data, what we're trying to do is we're trying to convert data into easily readable formats. Now, when we say easily readable, I mean easily processable. So if we have multiple data sources from which we have extracted a lot of dates, and if all those dates are in different formats, some of them have months before dates and some of them have dates before months, then it would be really difficult for our program or our data science process to understand just which one to use and when to convert which. So for that, we need to perform data processing and then bring them all into a same format. And then our data science process can you work on that unified format that we have converted our data into. Then comes data analysis. So data analysis is the task of analyzing data sets to summarize their main characteristics. What is the mean of the data? What is the most frequently occurring value in the data set? What is the minimum and maximum value? How much is the difference between the minimum and the maximum value? Is it normal to have that much of a difference? So on and so forth. Now, these characteristics also allow us to understand the shape of our data. We can also take a look at the standard variance or the standard deviation of our data set to understand just how different our data is from each other, and what are the things that we can do to make sure that our data and process does not get bogged up in later stages because of some problem in our data. Then we move on to data cleaning. Now, data cleaning is also very important. Data cleaning basically means removing inaccurate or unwanted or unnecessary data from our data set. Since we've gathered a lot of data, it's quite possible that we have data that is in incorrect format, that is unwanted, that is inaccurate. It could be that the people who were recording the data did not have the equipments to record the data. Their equipments were faulty. It could be that the data that we have is in a format that is no longer used, and the data needs there's nothing more we can do but to just drop the data set. Or maybe that data set does not contain a lot of values. So for instance, if we're gathering a lot of data and at the end we have some sort of unique identification number, and that was introduced on a later stage, lots of the records in that data set might not have that number. So what to do in these situations is you need to take a look at the data and understand how you're going to clean it. You could just fill all the missing values with 0, or you could fill it with the mean of the entire data set, or you could also drop all the data sets that contain null values or that have missing values. Then comes data visualization. So data visualization is a graphical representation of the information or the data that we have. It allows us to visualize the data, it allows us to understand it, it allows us to see some trends, some patterns in the data that we have in front of us. Taking a look at a large blob of numbers is not really helpful, but if you visualize it, if you convert it into a bar chart, if you convert it into a scatter plot, then it's quite easy for us to understand what that data represents.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So why should you visualize data? Well, to view changes that are happening over time seamlessly. So if you're trying to make a stock market predictor and you wish to take a look at the data of a particular company's stock market performance, you could just visualize it and understand how is it doing since the day it was released till today, or till the day that we have the data available to us. Is it performing well? Has its value increased? Has its value decreased? What was the sharpest decrease in the value, and what was the time period in which that sharp decrease occurred? So on and so forth. Then we understand the correlation between two or more variables. Correlation basically means the impact one variable has on the other. So for instance, the age and the bone density of a patient. So as the age increases, after a certain age, a person's bone density starts to decrease. So that's a negative correlation, because as age is increasing, bone density is decreasing. So that way we can understand what are the relationship between the various variables that we have in a data set. Then comes the task of simplifying complex information into user-friendly formats. So it's quite easy to interpret a graph and then to interpret some large amounts of data. And then finally, to tell a better story, which a bunch of pictures over time. So data visualization is mostly used to understand the trend of the data. This is basically a story that we're trying to tell, and this is why we use data visualization. Then comes creating a model. So when we're trying to create a model, what we're trying to do is we're trying to create a mathematical representation of the information that we have extracted from the dataset. This mathematical information could be reused to perform some tasks like classification, or maybe make some prediction about what the future sales are going to be like, future stocks are going to be like, depending on the data and depending on the things that we're trying to do. So as you can see, we get a lot of raw input data. Then we apply our algorithm, convert the data or split the data into training set and testing set. And then in the training set, we perform some supervisor task, which takes a look at the data set and extracts some useful information out of it. And that information is to map to the desired output. And then finally, we create a process through which new incoming data could be used to make predictions, to make classifications, to make some future prediction using the model that we have just created. So there are a lot of algorithms to create a model. So if you want to use one algorithm, what you should understand is firstly take a look at the data, take a look at the data set, and then use multiple algorithms on subsets of data and figure out which one is performing the best for you, and then choose that. And then comes testing the model. So once you've created a model, or once you've created multiple models based on the data set and the algorithms that you've used, how do you test which is the best one? So this is done by checking the accuracy score. How much of the data that we set aside was correctly predicted? How much of the testing data was correctly predicted? So if we have 10 records and we know the predictions that should be made, and then we feed it to our model, and then we take a look at whether those predictions were met correctly or not. And if not, then how wrong were they, depending on the kind of predictions that we're trying to make. So that's how you test a model. So when you're trying to test a model, several key terminologies come into mind. One is confusion matrix, and accuracy score, and so on and so forth. Confusion matrix is just a way of visualizing the correctly interpreted data, and accuracy score is used to give a percentage to the amount of data that was correctly classified or correctly predicted. So if we had 10 records and we wanted to make predictions, and 8 of them were correctly predicted and 2 of them were incorrectly predicted, we would get an accuracy score of 80%.
We are going to introduce some basics of statistics, as well as introducing you all to these statistics before we start any probability, anything on probabilities. First, when I say statistics, what exactly triggers in everybody's mind? So you might have seen your daily newspapers where people talk about how much pollution is there in northern central part of India, like Delhi, and what is the percentage of carbon content in that. And also you see that how many people, and also, yeah, coming to the sports, you might have seen that how IPL is going on nowadays, and how many runs that particular batter is doing. So all these numbers, okay, actually shown that who is performing better. Or if I take an example of one batsman, how his record has been from past several years, how many runs he made, what is the average he made, and what is the best he made, I mean to the maximum runs he made. So all these things, actually all these measures generally describe the data or the performance of that particular batsman, or anything, the situation or the scenario that you are expressing in the form of data. From that data you are actually trying to tell some numbers out of it. Let us look at this example. An university is actually trying to show that who are the people who are graduating into chemical engineering, and there are many graduate engineering graduates are there, out of which how many of them are chemical engineers in 1998 and in 1988. So if you look at this one, from within 10 years, 1988 to 1998, what is the ratio of these chemical engineering graduates are changing? For example, here in 1988, if there are total graduates are 140, out of which 120 of them are chemical engineering graduates. Now in 1998, out of there are, let us say, 130 Indian graduates, out of which only 90 of them are chemical engineering graduates. So now what this chart will give you, what is this actually talking about? This is actually talking about a data of engineering graduates, out of which how many of them are chemical engineering graduates. So you are representing the complete data in the form of simple charts or simple measures. Here it is just in a number. Okay, based on that you are actually describing the data. Let us talk about this figure 2. Here, what exactly this is representing? It is representing that you are having some stock price of Facebook, all right, and how it is varying from 2009 to 2018. And since we are in the year of 2016, it is projecting that is the projected stock price, okay, projecting the stock price in 2017 and 2018. So for example, if a person is at this time instant, let us say 2013, he has the history of the data 2009 until 2013, and he is projecting this data, means projecting the sales or the stock prices, okay, in the future years. So I'm not going to talk about how Facebook is performing and all these things, but this is an example I'm just taking to explain you that what anybody expects out of the data in the simple charts to describe about statistics of the data. So in this session, I'm going to talk about more about descriptive statistics. Okay. Descriptive statistics is the term given to the analysis of data that helps to describe or to summarize, okay, in a meaningful way. For example, if I'm giving you this particular sheet of data, Excel sheet of data, and I would ask you that what exactly this data is representing, okay. So for an analyst, okay, who is going to sit down and looking at this data, he will first try to understand what is this data all about, and when he is going to communicate, he would actually start analyzing this data in this way. For example, if I'm looking at population projection of Delhi, okay, so this is a year, okay, and these are the as of 1st March, okay, these are the males, these are the females, and urban, rural, as in 1st July, similarly the values. So as in 1st October, this is the value. If somebody comes and asks you about this data, forget about statistics. If somebody comes and asks you about the data, the first and very important point, a very important way to describe this data is, hey, this data is talking about the number of males, females, okay, in urban and rural areas. They have recorded in 1st March of every year starting from 2002 to 2026, okay. Since we are in the year of 2016, these are all the projected values, okay. That is what the population projection of Delhi. So we are actually trying to predict what could be the population in Delhi. I don't know how they have predicting and everything, but this is the data I got it from the survey department. Now I will have to give some kind of summary of this data. So whenever you are trying to give the summary of this data, then you have to then that particular field is called descriptive statistics. Okay, as I mentioned earlier, descriptive statistics is the term given to the analysis of the data. So you are going to do the analysis of the data, and here you are not going to do any projections or any predictions, any estimations. No, you are just, you got the data, you are actually giving the summary of the data. So now it is very important because you are going to take the raw data. This is called raw data. What I mean by raw data is that which is in the very, very basic form. No analysis has been done. No pre-processing has been done. What I mean by pre-processing, most of the data that we get out of all these surveys or any kind of experiments, the data will contain a lot of unnecessary information that is called noise. So when we have this noise, okay, so before we conduct any analysis, we try to remove that noise. But here the question comes, how do I discover that noise? That I'm going to cover in the later sections. But to explain you that what is raw data is the data that you are getting in the very basic format on which you are going to perform some analysis, okay, and to describe the complete data in a very descriptive format. Is that clear? So now, in simple sentence, if anybody asks us what is descriptive statistics, which means that descriptive statistics enables us to present the data in a more meaningful way. Okay, in the simple way, I can say it is a simple interpretation of the data. All right. So simple interpretation, just now the way we have done here, This data is actually explaining about the population data, population projection of Delhi from 2002 to 2016-26. Okay, and on March 1st, 1st July and October. Okay, so now similarly, yes, if I talk about this particular table, okay, can somebody interpret this data by yourself? Please look at this table and try to see that what exactly can you interpret here. Yes, if we interpret this data, okay, this data is talking about near about 22 languages, okay, and people who are actually talking, of course the table title itself is showing, but let us only from the data itself, let us interpret this data. And okay, in 2001 and 1991, how many people are speaking Assamese in 1991 and in 2001? Okay, male, female, and the percentage it is showing, right? So now this is simple what the data is. Now I'm going to ask you that what is the percentage of the people who are speaking Hindi, okay, and those are males? Another question, how many people who are speaking Manipur, okay, who are females in 2001? And I also asked the questions that from 1991 to 2001, what is the percentage growth of people who are speaking Bengali in Delhi? Are you getting my questions? So all these questions can be answered from this data only. But in order to answer all these questions, first of all, we have to do a very simple operations on the data, which means that so simple measures that we have to find out. For example, if I'm taking an example of Sachin Tendulkar, I would say Sachin Tendulkar is a very good batsman. He is maintaining a very good average. What do you mean by average? The average is a simple measure that is completely describing his performance from the past 10 to 15 years. Similarly, if I say that one particular simple, what is that simple measure that I can get out of this data to explain, to interpret this data in a more meaningful way? That is what we are actually talking about, the descriptive statistics here, right? So the questions that I have asked, can anybody able to answer those? For example, what is the percentage of growth of the people who are speaking in Bengali from 1991 to 2001? Those are especially females. If I am asking this question, then I will go to 1991 female, and in 1991 female who are speaking Bengali, and 2001 who are speaking Bengali. Then what is the percentage of growth? So the percentage of growth is nothing but the difference between these by the original. So that is one measure. Percentage of growth is one measure that gives you the complete understanding of the people who are speaking Bengali. But from this data, there can be many questions can come out of it. So let us represent all of them in a simple form, so that that particular form, it may be a visualization graph, a plot that can provide you the complete set of information. This slide is mainly talking about collecting the data, understanding the data, finding the useful information in the data, interpreting the data, and visualizing the data. So somebody has collected this data, okay, and we are trying to understand this data. And after understanding the data, we are trying to find out what is that useful information that is needed. So useful information means those are patterns in the data. There can be many patterns. You can retrieve many information out of it. I mean, it's many information points out of it. But from the business point of view, if a person asks a question from the business question, how do you really interpret it, find out that pattern? The pattern may be, I wanted to know the people who are, okay, this is the question perhaps I can ask you. I wanted to know how many people are there from South India. Okay, so South India, here in this data, South India is not well defined, but that is the question I'm asking you. So you know some of the South Indian places and you know some of the South Indian languages. So you filter out those languages, okay, and then for example Tamil, Telugu, okay, and any other languages here you can see Malayalam, okay. So for example, these some of these South Indian languages I filter them out. After filter them out, I will call all these Telugu, Tamil, Malayalam or any other language into one particular bucket, and I would say that yes, these are all South Indian languages. How many of them are there? I filter out their information. So how do I represent that one in this very simple form? Okay, that means, see, it's not a pattern, but it's a kind of information that I'm trying to get out of this data based on the business question that was asked, right? So based on that business question, I found that information, and then I'm interpreting the data. Interpreting means I'm doing some operations on the data, and then show it in the same visualization format, maybe bar charts or simple any other charts. All right. So here, what I wanted to emphasize is that whenever you get this data that is in the raw data form, and you try to get all this raw data form into a very simple descriptive statistics form, or a simple measure like average or a percentage of growth or a maximum, minimum. So these are all some terms that generally people use to communicate or to interpret the data. Okay, so what is statistics? Okay, as I mentioned, that is an example here. Descriptive statistics means it's a collection, presentation and description of sample data. So descriptive statistics are used by the researchers to report on population and samples. Just now that's what we have seen. And in sociology, right, and it is a kind of a tool that we use to comprehend the complete raw data in a more meaningful format. Okay, that is descriptive statistics. So you got the data and you're explaining about the data. Very simple. Okay, so what is inferential statistics? Inferential statistics are those from that data you make decisions or you draw some kind of conclusions out of the data. For example, I'm going to the same data here. Okay, I was talking about number of people, maximum number of people, percentage of growth and all these things. Now suppose if I want to take a decision that as the population is increasing, right, that first of all, yes, whether the population is increasing, yes, it is increasing. That is the how do you know that population is increasing? That we can find out from the descriptive statistics using the univariate profiling. I will show you what is univariate profiling, bivariate profiling, okay, in the later parts of the course. But just for now, to understand that whether this number of males is increasing and females are increasing. Now the question I wanted to ask here is that I wanted to I wanted to see, suppose I want to take a decision that that is more relevant to female population. Okay, so now I'm going to take a decision. All right, first let me answer this question. Male is increasing the most or the female? Is it in urban or in rural? If it is in urban, what is the projected growth rate? If it is rural, what is the projection growth rate? So the questions that I'm asking, okay, those are all some kind of, I want to draw out some conclusions out of this data. I want to take some decisions out of this data. Should I focus more on the urban? Should I focus more on the rural? Okay, so the descriptive statistics just give you the information about the data, but inferential statistics is the one that helps you to infer some thing from the other. I want to infer that, okay, I will put it like this. So, for example, in the rural area, okay, this is the population that is increasing, okay, and this is the population of female, those are increasing, okay. Now, I wanted to ask this question, as the female population is increasing, is it increasing at the faster growth than the male growth? I'm repeating my question again. The female growth rate, okay, I mean to say the projection, what it may be, is increasing much faster than this. Yes, I will answer that. Okay, in order to do that one, first we have to see the velocity of the population growth rate in each year. What I mean by velocity is nothing but the number of popular. For example, from 2016 it is 11,827, okay, and 2015 of the same time, okay, I'm calculating the velocity in 1 year. 11,827, okay, minus 11,481 by 1 year, nothing but the difference, okay, how much it is changing here, how much it is changing within the same year. 9,458 minus 9195. You can do simple math by yourself, okay, on a simple paper, and see that which one is increasing in 1 year. Now, if I ask the same question for the complete like this 2002 to 2026, you actually find out the difference between this and the number of years. Similarly, here, okay. So then you can easily answer that which one is actually growing at a faster rate. All right. So these are all some kind of, just I'm actually giving you some examples here. But what we are trying to achieve here is that to introduce all of you that from the data, okay, once you get the data that is in the raw data form, fortunately this data is very clean. What I mean by is that there are no missing values, okay, which has a very clean numbers. So we can draw, we can actually describe about this data in the more descriptive form, okay. And if I want to draw out any conclusions or any kind of decisions, then I generally do some analysis that is called inferential statistics. That is what these are the two different segments, I would say two different segments that describes about statistics. Is that clear? Now, for example, from the industry standpoint of view, generally you might see different kinds of yeah, every day you see these e-commerce sites, right? There you will find out different types of products and everything. But from the business point of view, let us say you are hired by one big e-commerce site where you are going to give some kind of suggestions to the management to take decisions, okay, in terms of revenue growth. Let us take this particular example, okay. Look at this particular page and there are 4 products, okay. Samsung Galaxy S3 Neo, that is blue and white, and there is Core 2 Samsung. So there are different products, and now everybody looks at these prices, EMI, and the specifications of these. So now the question here is that tomorrow, given the market changes, dynamics of the market, and as well what I mean by competitors and the product values, so how do I design, how do I come up with the optimal price, okay. How did they come up with the 7,180 instead of 7,200? How did they come up with this number? Why did they come up 12,480? So how do you decide, okay, the optimal price of these products, okay, so that your sales will be maximized? So I had shown an example of an e-commerce site where we wanted to decide the optimal price of these 4 products. Those are shown here. Defining the optimal price is one of the business problems. Similarly, there can be many business problems like how do we maximize the revenue, or how do we increase the, of course, maximize the revenue through sales only. And in order to maximize the sales, there are many ways. One is the optimal, how do we decide the optimal price, or which products are more interest to the users, and what are the features that customers are looking for. So there are many dimensions that we have to consider in to maximize the sales. For any business problem, whether it is maximizing the sales or for deciding the or understanding the customer intentions, what I mean by intentions, customer intentions are what exactly he is looking for in my e-commerce site. So for any business problem, we have to start collecting the data. So how do we collect this data? So do we collect this data from Monday to Friday, or during the weekends, or for continuous periods of months? So what is the time frame that we are actually looking for collecting this data? That is very, very important. Perhaps I wanted to look at this data as per the quarter level. In the first quarter, what are my sales? In the second quarter, what are my sales? So whether my sales have been improving or not. So these are the some kinds of data points that I'm actually looking for. So now, if we take these 4 products, and before I start analyzing or taking any decision, I would like to take the help of descriptive statistics to understand the data. Let us take a very simple example here. In this example, I am showing product 1 sales, product 2 sales, 3 and 4 in different months starting from January 2015 to May 2015. So looking at this data, what can we really infer? Okay. Before we infer anything from this data, let us get the summary of the data. Okay, so what is the summary of the data? If you look at this one with a naked eye, I can say that all right, there are very good number of sales in February. Here product 2 also there is good number of sales in February, whereas in product 3 in March there is a good number of sales, and in product 4 in February. So not only like that, okay, so we have to use some kind of measure that we have to use before we summarize the data.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let us take an Excel example. Okay. So these are the 4 products that I'm talking about and their sales. So when you want to summarize this data in Excel, okay, because everybody is having a good exposure to Excel, so that's why I'm taking the example of Excel here. So if I want to see, if I want to get the summary of this data, so I will prepare another table for each of these product, okay, within this time period that is having these are the measures. What are those? Which is, what is the minimum number of sales happen? 220, this one. What is the maximum number of sales? 542. What is the sum of the total sales? Okay, which is nothing but in this given time period of this data that I collected for these products, out of these products, for the product one, the total sales are happened is 1753. Okay, and also mean. What is mean? Mean is nothing but it is the average of the sales those are happening. Average is the sum of all the sales from January to May and divided by the number of months. Okay, since I am looking at the data at the months, then it is the sum of these product sales by the number of months. Okay, that is nothing but 1753 by total 5, which is 350.6. So the average number of sales happened is 350.6. And what is the median? Median you calculate, okay, you just keep all these values in the increasing order. What I mean by increasing order, which is starting from 220, 224, 311, 456 and 542. This is what the increasing order. Okay, just for your information, I'll write down here 220, 224, 311, 456 and 542. So when you calculate the median, okay, you have to just start moving from left 1 point as well as right 1 point. Okay, again left 1 point and right 1 point. So which is nothing but the center of the all these arranged ordered numbers. So which is nothing but this is the median. Okay, so here what we have to keep in mind is that when I'm going to discuss about the distributions, okay, whenever you want to see the profile, what I mean by profile is that any variable, okay, I'm going to explain about variables as well very soon. Any variable that is going to, I mean to say here, the variable is sales of the product one. Okay, for example, any variable, let us say this is the variable. In that variable, that will have mean and median. Okay, so that, okay, first I want to describe about the profile. Profile is nothing but any variable that will have certain characteristics, okay, that can be represented in the form of min, max, sum, mean, median and standard deviation. This is called profile. If somebody comes and asks me, hey, what is the profile of the sales of product 1? Then I would say, hey, the profile is, it has a minimum number of sales of 220 and maximum number of sales of 542. The total number of sales of that product from January to May is 1753. And the average sales happen to be 350.6. And the median is around coming out to be 311. So whenever I say the profile means, immediately it should trigger in our mind that this will have all these values. Alright. So if somebody comes to you and asks you, hey, can you perform some profiling on this data? Which means that they are expecting all these different values to understand what is happening in that particular variable. Now, I just mentioned that please keep in mind this mean and median are very important characteristics of any profile, which means that the distribution I'm going to talk about of any variable can be easily characterized by these two values, and also these two values help us in identifying the whether the distribution is the required distribution or are there any skewness in the distribution. So anyways, so keep in mind that these are very two important parameters of any profile. So now here I'm talking about the similar way for the product 2 and product 3, product 4. So this is the complete summary of the data that I'm presenting it here. All right. So now, is this summary sufficient for you? Is this summary sufficient for you? No, this is not sufficient. There are some more other characteristics that I'm going to introduce that would be helpful for us to characterize the data. Let us take an example. Okay. Let us say this is an example which is actually talking about how do you compare the two distributions of, okay, two distribution. Before I use the word distribution, I just use very simple English. There are salaries of two companies in San Francisco and New York of different designations like junior software engineer, senior software engineer, project lead, manager, and senior manager. So these are the salaries of two different companies. Okay, one is in San Francisco, another is in New York. Now, if somebody comes to you and asks you, hey, can you just profile this data? When you profile this data, okay, means the salaries of these people, what do we want? Okay, the first one is, what is the minimum salary of the company that is located in San Francisco, which is 5,000, and what is the maximum salary, which is 55,000. And it is good that it is already in the ordered one right here. The salaries, as the designation is increasing, it's quite obvious that salary would also increase. So now here I wanted to know what is the mean of the salary. So here I have just populated my summary. When I actually summarize this data, the minimum of both the companies is coming out to be the same, maximum is same, mean is same, and median is same. But if you and I observe this data of this very small data with the naked eye, we can see that the senior software engineer of a person of this company in San Francisco is higher than in New York for the same designation. Here, in the project lead, New York organization is paying more than San Francisco. But when you summarize the data is coming out to be same. I mean to say that summary is looking same, right? The min, max, mean, median are also looking same. But this is not the actual case here. There is some variation among this data that is called the variability, or we can say that dispersion. So I'm going to describe about dispersion here. Dispersion describes the variability of the data. So we need few more measures to actually evaluate the characteristics of the profile. The first one is the range. Range is maximum minus minimum. Oh, here also the max and min, the range is coming out to be same because the max and min are same for both the companies, right? Then let us go to the other one, which is mean absolute deviation. Mean absolute deviation, which is nothing but, suppose you are having 5,000, this junior software engineer who is earning 5,000, how far is he from the mean value? The mean value is 30,000 here, right? The mean value is 30,000. And how much this person is varying from the mean, and which is the absolute value. That is the mean absolute deviation. Mean how much this particular junior software engineer from San Francisco is deviated from the mean, which is an absolute value. All right. So which is nothing but 30,000, so 5,000 minus 30,000. Okay, similarly software engineer of this San Francisco. So I calculated for all of them, and when I sum all these values, the mean absolute deviation is coming out to be 15,000 here, whereas for New York it is coming out to be 25,000. So which means what exactly this is actually giving me the information? This information gives me that the company in San Francisco, the people who are earning money are very close to the mean than the people who are in New York, right? So these people are, let us say these people are 5,500, three of them are, three designations are complete, are 25,000 distance away from the mean, right? And these people are again 25,000 points, I mean the salary points away from the mean, right? So the mean absolute deviation is nothing but the sum of all the mean absolute deviations, okay, which represents this one. So here we found this particular MAD, mean absolute deviation, is helping us to find out the variability across the two profiles. Am I right or not? Neither the mean nor max or any other mean, median, range was not actually giving us the variability in the data, but mean absolute deviation is giving us. Okay, now we are going to the variance. Variance here, okay, which is the same difference but square of that, and we calculate the variance as the sum of all these values, which is the variance. Similarly for the New York, and then once we calculate the variance, we can calculate the standard deviation. How? Standard deviation is equal to square root of variance, right? So which is,
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
here in this case the standard deviation is 17,078 and 25,000 for the New York based organization. So this value is giving some information. What is that information it is giving? Which gives how much these salaries are varying from the mean, okay, how much it is deviated from the mean. Okay, so this is second measure, I mean to say third measure, range, which is coming out to be same. Mean absolute deviation, yes, it is giving good value, good information, as well as variance. Now let us see what is coefficient of variation. What do you mean by coefficient of variation? The variation, that is, which is nothing but the variance that we calculated, okay, and then standard deviation we calculated, okay, and the mean. The coefficient of variation is nothing but the standard deviation by mean. How much it is deviating divided by the mean value. So the coefficient of variation, so it is coming out to be 57%, whereas here 83%. So if you look at these three measures like mean absolute deviation, variance and coefficient of variation, these are all actually capturing almost all the same kind of information but in a different units. What I mean to say is that mean absolute deviation gives us the information that most of the salaries are not away from the mean, and here the coefficient of variation, which is also giving the information that there is not much variation in the data when compared to the people who are in New York. All right, so there are cases where whenever you are summarizing the data, you are getting the same kind of values, but data is not capturing that. Okay, I mean to say the data properties are different. So now these are the some of the measures that will help us in identifying the different properties of the data. Now I will explain these skewness with the graphical plots as well. In fact, I would explain all these concepts with the plots as well, but this is an example trying to show you that whenever you get the data, what are the different characteristics that I should consider to describe the data. So coefficient of skewness, yes, coefficient of skewness is actually, this is the, I'm straightforward giving you the formula here, which is the mean minus median by standard deviation. Whenever mean is equal to median, the coefficient of skewness will become 0. And whenever the coefficient of skewness is 0, then you should be very happy that the distribution is not skewed. Skewness is a property of the data that is centered towards, that is centered means that is actually not for, that is the mean and median are not equal, where it is moving towards either left or right side, which means the distribution is skewed. Skewed means it is actually not following the very good distribution. We have worked out on very small data as an example, where we were trying to compare the salaries of two people coming from San Francisco, New York. Why can't we do the same thing for a very not very big for a data set that is reasonably better? Okay, so I'm not talking about any very big data table. Let us talk about a small data table that is having total 100 customers who had come to my website and had purchased different products and their gender, what kind of product they had, what color of the product. Here I have taken Samsung Galaxy of 3 different phones, okay, and their color, the characteristics of the product like memory size, price, and what is the EMI value that it is actually showing there in that website, and number of sellers. Okay, so it is also the feature of the product, who are all selling, and RAM size, whether it is having dual SIM or not, and what is the resolution of the camera. So now similar data set, assume that you have collected for your experimental study data, okay, from the experimental study data, and you want to get some summary of the data at any point. Okay, whenever you are going to handle with the data, it is always better to first get this summary of data irrespective of whatever may be the data. Okay, so now let us say, now I want to apply the I want to just summarize this data by using the descriptive statistics. So there, if I am actually going to do that, the first thing, summary of the data, I would say that number of rows is 100, okay, and number of columns, how many columns do I have? 11. Now I want to calculate the mean, max, mean, median, standard deviation, and number of unique values. So here I just want to explain you one more concept, that is the type of variables, because if you are actually looking for minimum for anything, something like for the gender, so is it possible to find out the minimum? No. So you can find out the minimum value, maximum value, or mean value for only continuous variables. Right? Continuous variable means those are numerical variables, and those have some value. Okay, There can be situations that the values will be numerical but may not having some value. So in order to explain this particular, before I go and summarize this data, it is very important for us to understand what are the various types of variables that we generally encounter in our data. Okay, so you might say that, hey, by looking at this one I can see the numbers and the strings. These are the only two types, but from the statistics point of view, it is better to understand various types of these variables. So now let us look at these basic definitions. So population, okay, these are the basic definitions. I will explain this population sample and everything. Okay, population is the group from which data need to be collected. Let us say a large population of software engineers in Bangalore, which is one of the examples. Okay, and out of which you are selecting some 100 people for your study. For example, whether they know any particular computer programming language like Java or Python or any other .NET. So you want to see that how many people know a particular computer language, programming language. So you may not go to each and every software engineer in Bangalore. Okay, so you take some sample there. I want to explain what is variable. A variable is a feature characteristic of any member of a population differing in quantity and quality. Okay, please remember this, quantity and quality. Based on this quantity and quality, we are defining the quantitative variable and qualitative variable. Quantitative variable is the variable that is actually differing in quantity. Okay, and qualitative variable is that is differing in the type of quality. For example, you may have, okay, for the product I'm having color, it is a qualitative variable, okay, which is not having any quantity, means any number associated with this, no. Okay, and similarly, if I'm talking about the stock price is going high, okay, the stock price is going at low, so there I'm actually talking the qualitative nature of the particular variable, right? So these are the first quantity and qualitative variables. And then discrete variables. Discrete variables are those variables, those will not have any floating values. Okay, these are called, in programming language we call them as integers, right? So int, generally whenever we write any program we say int. Okay, so what are the examples of the discrete variables? So how many number of licenses you have, how many number of insurances you have, how many products, how many number of products, number of cars, number of widgets. So you cannot say that I visited this shop for 2.5 times. You always say that I visited this shop for 2 times or 3 times. Okay, so such kind of variable is called discrete variable. And then continuous variable is the one which is again quantitative variable that has some floating values, like this product value is $233.35, or this particular one costs $2.57, so which has some floating value. So whenever we get the data, so it is always better to develop a hierarchy of the data. Okay, a variable type hierarchy, it is better to have this one, that will give you a very clear picture of what kind of variables I have. So out of these variables, what kind of descriptive statistics methods that I can apply on them. For example, if I'm telling you, if I'm showing you the data of a product which is having different colors, then I might ask you a question, which color is coming out to be the most? Which color of this product is having the least? I don't ask you that what is the minimum value of this color, right? So similarly, whether the product is having a camera or not, I'm saying that yes or no. I'm not there. Can you find out the mean value of that one? No, right? So mean, median, all these things can apply to only quantitative variables. right? So that's what, whenever you perform any arithmetic operations on them, then we can call them as quantitative variables. Okay, whenever no arithmetic operations are not possible, when no are possible, that means you cannot do any arithmetic operations, then it is called qualitative variable. All right, so again, in this quantitative variable we have two types of variables. One is the discrete variable, another is the continuous variable. Similarly, in the qualitative variable, okay, again you have two branches. One branch is that, okay, nominal variables. Nominal variables are those variables whenever I say male or female of any gender variable that has the values like male, female, then there is no grading, there is no grading or there is no ordering on these variables. Okay, whereas I say that, hey, my son got A grade in mathematics, B grade in physics, C grade in natural science. So when I say these grades, you are actually finding the relationships among these grades. Okay, like something like A grade is always greater or B grade is less than A grade, some kind of relationships that you are maintaining.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
For example, the same example, like whenever I say that my stock price, this particular company stock price is going very low, medium and high. So if I use these values to any variable, though it is qualitative, but we are actually maintaining the grades among the variables. All right, so here male, female, female, male, female, there is no grade here. New York, Texas, or if I say Chicago, Seattle, so there is no such kind of grading is there, correct? So this is about the qualitative variable. And also, suppose in the ordinal variables there are chances of coming some numerical values. For example, this particular customer who visited my site gave 5 stars. Okay, 5 stars grade. He provided a review, I mean to say. So 4 stars, 3 stars. So though it is a quantitative number, but it is still talking about the qualitative nature of it, right? 5, 4, 3, 2, 1 star ratings are still coming in under the ordinal variables. Okay, so which means that you cannot add uh, you cannot add 5 plus 4 here. You don't need to add. That shows that what is the nature of the or the kind of grading that it has been provided by the customer. All right, so my point here is that whenever you get the data, on this data first build this hierarchy. This is the first and fundamental rule that you should follow, and that gives you very clear picture that what are my variables that I am having. If there are 300 variables, do that. Okay, just put all your qualitative variables here and nominal variables just put down here, put down at the bottom, discrete variables, continuous variables. Then on these continuous variables, whatever we discussed in the previous session like mean, median, all these things can perform in a similar way here also, but on these quantitative variables only you can do the mean, median and all these things. Then you may ask the question that what will we do on these type of variables. On these type of variables we can perform only least, highest, how many number of females are there, okay, how many number of unique values the particular value has. Gender will have number of unique values will be male and female too. Okay. Whereas in continuous, number of unique values can be very high. If I start taking 2.1, 2.5, 3, 3, 7.5, so it is a continuous value. It's a curve. It's continuous curve. But here it is a kind of only unique values that you will have. That means the points you have. Okay. So now if we go back to our data and look at the data, and now if I'm start doing my data summary on this one, what I will do first, I will take the number of rows, number of columns. Customer names is my first variable, right? Customer names. So customer names, can I get min, max or anything? First of all, why can't we build this hierarchy? For now, I'm going to show you the data summary here, and also this is also I'm leaving it to you for your assignment because I had already explained this example, right? So do this one, but I just want to give you some kind of directions. Okay, customer names, gender is male, female. I cannot find out min, max. Then for this variable, and names of the products, this variable and this variable, these are all non-numeric. I cannot perform any kind of, I know this is an assignment. Okay, before you follow this session, better you work out yourself and then see whether you are matching to this discussion in terms of variable hierarchy. Okay, so now memory size. It seems to me that these are all some numerical variables. Okay, I'm just trying to make it as a numerical variables. Okay, and here dual sim, yes or no, it is just like a nominal variable, non-numerical. Okay, I will put it like that, non-numerical. Okay, and resolution of the camera, again this is a numerical variable, right? So in on these things, okay, memory size, what is the minimum memory size, what is the maximum memory size, what is the mean memory size, what is the median, what is the standard deviation, so I can find out all these things, right? Similarly, if from this distribution also see that what is the mean absolute deviation, I want you to do this one as your assignment. Okay, on this data, I want you to do this one and find out what is the dispersion in the data and see that whether you can really communicate these values in simple English to any of your seniors or your colleagues or to anybody. Okay, but what I'm going to focus right now in the next session is how do we visualize these summary in terms of plots. Okay, in terms of plots would give you more visualization, more information. Obviously visualization will give you more easy description than something like all these numbers and everything, but it is the first good practice if you can really find out all these values, coefficient of skewness, coefficient of variation, variance, and mean absolute deviation for this data that I'm having. Not only for this data, any of the data that you may have. Okay, first do these operations and keep that with you as a reference throughout your statistical studies. This is also called a data dictionary. Okay, data dictionary means when instead of going and looking at the each and every data, if you go to this particular data summary, I will also call it data dictionary, you will have the complete information of the data variables, their distributions, means how they are actually mean, median, max, or varying. In fact, we are going to introduce the percentiles and everything. Okay, how they are actually varying, whether there is a skewness in the distribution. Skewness is nothing but how the mean and median are varying. So that is that complete information is available in this particular data dictionary. So what are the applications of this data? Where exactly this data dictionary will be useful? If you have this data dictionary in hand, so in the future when you are going to build a machine learning model, or you are going to infer some kind of rules out of it, or you are going to take decisions in those places, these values would help you to see that whether your decision that you are actually taking is valid or not. So such kind of information would be available from this data dictionary. So I'm leaving this assignment to all of you, okay, just to follow the same thing on this data. I'm going to ask this question: what is probability? Okay, so this is very common question that people generally ask. Okay, who is more interested in visiting my shop? What will be my inventory cost for the next festival, Diwali season? I'm going to put a lot of products so that people can buy them. So what will be my inventory cost? Can you go and tell them that okay, your inventory cost will be $20,000? No, you cannot come up with a very certain answers. And who is more interested? Here also it is very difficult to capture the customer behaviors, and you cannot really give such kind of very certain answer. Okay, and also what will be the airfare during the summer season? Okay, there are 8 mistakes in a page. How many mistakes you find in 200 pages book? Given the market conditions, what will be the share price of Facebook tomorrow? How many number of cars are having airbags on a given national highway during the weekend? So these are all questions that people may not have very certain answers. Okay, certainty here is that you will have a very high confidence in your answers. Okay, if you are having such a high certainty, then you can say that your probability, your confidence is very high, and the probability is almost close to 1. So if I look at any time, whenever we talk about probability, if I say that it is nothing but, okay, it is nothing but just it is nothing but the gradation from 0 to 1. 0 is that impossible event. Okay, impossible events are those events that will never happen. For example, uh, I don't have any impossible events at this point of time, but yeah, any impossible events, something like okay, Obama becoming the president of India, that is an impossible event for me. Okay, so those are impossible events, and slowly you will actually talk about unlikely. Okay, please remember these words. Whenever people say that likely means very close to 1, unlikely means not very impossible, but yeah, chances are very less, like that. Okay, even chance means which is the 50% probability. Okay, if any of your friend asks you, okay, are you coming to the party tomorrow, you say that yeah, it is 50-50, because there are many kind of constraints you have in your mind, that you may have to go and attend some conference, you may have to meet your other friends, so you don't know. So since you don't know, you will actually give that okay, it is high, it is a kind of 50-50. So whenever any kind of event is going to happen, so you should be able to term those events in terms of likely, unlikely, even chance, it is highly certain, it is completely uncertain. Okay, so highly certain, or it is impossible event. So in those ways you have to frame your questions. Suppose if you are an analytics person, and your manager is asking, hey, tell me that tomorrow what is the probability that the number of customers visiting our coffee shop will be more than 200. So you tell that okay, without calculating anything. What I mean by is that how many number of people were coming last week, before last week, last month, without calculating, without taking the data into consideration, you will say that sir, very unlikely. So what I mean by here is that he is not using any data,
okay, not using any data, but based on his self I won't use the word guess, self observation, he is actually telling that particular probability value, right? So we are going to cover what are those different types of probabilities in the later session. Okay, there are subjective probability. Okay, it is a person's belief. Empirical probability, which is nothing but he takes the data and talks about it. And then theoretical probability. Theoretical probability is mostly like I mentioned, right? What are the high school standards? We learned all the theoretical probabilities, okay, which is nothing but actually you just say that how many ways that it can occur, which is something like how many satellite launches will be successful. So you don't have any kind of data, but you are going to predict some kind of theory. Theoretically, you are talking about, not something like based on the experience. I'm going to talk about it. But before that, we have to understand the sample space and events. So you may have observed that since beginning of this class, I have been using the word event, right? And all combinations, right? And some event and what is the possibility that particular event, right? So here sample space is nothing but which is actually having a kind of all possible combinations, and events is the one that you are more interested in. You are more interested in, what I mean by is that you are going to calculate that particular one. Okay, so for example, who is more interested in visiting my shop? Okay, the sample space is that there are many customers, C1, C2, C3, C4, C5, and like that. Then what is the event here? You have to define that event. Okay, you have to define the event. Event is the one that you are defining, and then you are calculating that particular probability based on that the event that you are more interested in. So E is an event where the customer with age range 18 to 35 visit my shop. Another event I can tell you, E is the event where the customers, okay, with customers who are males or customers who are females. So you are more interested in solving understanding one particular probability, that you will call it as an event. All right. So whenever I say that event, means that I'm more interested in finding out that particular probability. Okay. Now, what will be the airfare during the summer season? Okay, air ticket prices are there. Okay, if I'm taking that, that can be samples, it can be high, medium, low. These are the total possible set. Okay, and what is the event here? The event is an event where the prices are high. You wanted to know that how much the particular prices will be there. What is the probability that the prices will be very high during this particular summer? Okay. Similarly, there are 8 mistakes in a page. Okay, you are actually reviewing a book, and while reading those books, okay, so you found on an average 8 mistakes in a page. So now somebody comes and asks you how many mistakes you find in 200 pages. Okay, this is something like you have to estimate that. Okay, let us talk about the event. Okay, it is M is an event where the number of mistakes in a page is even number. Okay, it is just, I made it up, but it is something like event is that, okay, events, the mistakes can be even number or odd number. So you are more interested in the even number. Similarly, given the last month's share prices, what will be the share price of Facebook tomorrow share prices? So the sample space will be share prices you are having. But what is the event here? T is an event. Okay, I'm just defining different words here. Don't worry about these words. Okay, it is an event where the share price is lifted by 2%. Okay, that is your more interested event. I wanted to know what are the chances that it will be lifted by 2%, or what are the cases where this is actually lifted. So something like that. Okay, and similarly, how many number of cars are having airbags on given national highway during the weekend? So cars are the sample space, C1, C2, C3. So case and event where the cars are sedan type. So there are many possible different cars. Total number of cars are, let us say, 100. Okay, and during the weekend you found it, and how many of them are actually having airbags, and in event that you are more interested in sedan type, how many of them are actually, okay, are having the airbag. So what I'm trying to explain here is that here these are some examples I provided. Whenever you are solving a problem, don't think that your boss is not asking you to solve the probability problem. Okay, when any problem that you are solving in the industry means you can really formulate the problem in those terms. Your communication with your boss, your colleagues should be in such a way that you should define it. Okay, this is my sample space, I have taken this many event, and and this is the event I'm interested in. And many times I'm telling you, many people are taking the data, and without understanding the problem in those terms, they will just go and solve the problem, and finally after 1 week of cycles, they'll come back and say, I didn't find any results. Why? Because you did not really understand the problem. Okay, maybe the, for example, this is the one. The cars are sedan type. Did you see that how many sedan types are there here? If there are only one sedan type, okay, then the probability will come out to be very less. In the similar fashion, whenever you are solving any problem, you should completely understand the complete sample space, and you have to define your own events first, and then you jump into solving the problem, whatever the problem that you are going to solve. Without doing these steps, if you are solving the problem, then I would say that we are wasting time. Okay, so now going back to the three approaches to probability, as I told you, right? One is subjective probability, which is a person's belief. My belief that Hillary Clinton wins these elections is different from your belief. Here, I and you are not using any data, but we are using our previous experiences or readings from the newspapers, news channels, and all these. Based on that, I'm coming with some belief that this is the value, that particular probability that Hillary Clinton would win. It varies from person to person. Okay, I would say that there is a high probability that Messi would come back. You would say that no, he would not come back because he is imprisoned. Okay, and there is something like a big project is there, and the revenue is coming out to be something like $300 million. Now, given the chances that that particular probability is success is less than 20%. Okay, I mean to say it is going to fail. 20% means 80% chances that it is going to fail, but the revenue is coming out to be $300 million. Then will you take up the project? So your personal belief tells you that should I really take this project or not? How many chances that my career would go up, okay, if I take this project? So these are all subjective probabilities. Okay, so as we go down, I'm going to teach you that how we can introduce these subjective probability values in solving your problems. And second is empirical probability. Empirical probability is nothing but you conduct the experiments and then you calculate the probability. You conduct the experiments. If I'm throwing a dice, or if I'm catching a bus or catching a metro, how many times am I going to miss? So you calculate the data. Okay, for example, Sachin made more than 8 centuries against Australia. What is the probability that he would make century in today's match against Australia? Here I have the data of that particular cricket player Sachin who made centuries. Okay, so now based on that I'm going to calculate the probability. Now coming to the theoretical probability, here you are not conducting any experiment. Here it is not your personal belief, it is something like theory. You would say that, okay, if I want to catch this train, okay, what is the probability that I'm going to catch the train or miss the train? Then you will actually calculate where am I staying, how many times, what are the possible chances that you would go, can I catch the train? So you will take all those possible combinations and then you will tell the probability. There you are not empirically, you are calculating the data. You're not actually telling the subject that, oh yeah, I can catch the train with 80%. That is completely without calculating data from your personal belief. You're telling that is subjective probability. If you're collecting the data every day and you're doing and calculating them, that is empirical probability. If you're just calculating just like a mathematics, that okay, this is the chance, this is the chance, this is the chance, then that is called theoretical probability. Okay, so whenever you are calculating any probability problem, working on probability problems, first you have to really define that whether that person is talking about subjective probability, empirical probability, or theoretical probability. Many of our discussions that happen in industry are subjective probabilities. Okay, which is something like experts talk about these things. Experts, subject matter experts, based on their 20 years or 30 years of experience, they would say that this is something like going to happen. But that particular era is going to be changed with the data is arriving into our servers. Okay, like, which means that we are getting more data, that is we are having more empirical results, the real values we are having. So industries are actually using both SMEs and empirical probabilities and then getting the most powerful insights in terms of business decisions. Okay, theoretical probability, of course, it is something like you don't have the data, you don't have subject matter experts, and you will just calculate these things.
Basics of R programming, right? When you get started with R programming, what is it that you need to be aware of? Okay, I think even before that, it's important for all of us to know why is it that we're using R, right? Why is it that we're using R as a platform, R as a software uh, for this session, right? Why is it that R is an important, right, and a useful resource for all of us? There are several reasons for it, right? I can just briefly talk about why R Studio or R is like it's very popular and it's very useful. The first reason, of course, is that it's a free open source platform, right? It's available under an open source license, which means anyone can download and modify the code, right? In practical terms, this means that you can, of course, you can download R and R Studio and use it free of cost. Okay, even if you want to build applications, right? Even if you build uh, web applications, etc., using R, it's all free, right? You will never have to pay anything to R. The other benefit, right, which is slightly more indirect, is that anyone can also access the source code, right? Modify it and improve it, right? So let's say if you are a statistician, right? If you are a programmer and you realize that there's something that you could improve in R Studio or R, right? That's also something you could do, right? You have access to the base code, the source code. Of course, it doesn't impact other people's uh, like the version that other people are using. It only impacts your version. But if you want to make it publicly available, there's also a way of doing that, right? Let's say you decide that there's a modification, there's an enhancement that I could do in R Studio. You can process it, right, and then you can pass it on uh, to the R forum, right? They'll evaluate what you've done, whether it's actually incremental, it's actually beneficial or not, and then if they feel it is beneficial, then they'll probably apply it on the latest version. Okay. The second advantage, of course, is that it runs anywhere, right? The R development core team has put a lot of effort into making sure that R is available for different types of hardwares and different types of softwares, right? It works in Windows, Unix systems, Linux, etc., Mac as well, right? So it works. It's basically compatible with all operating systems. R also supports a lot of extensions, right? R performs a wide variety of functions, right? Such as, let's say, data manipulation, statistical modeling, graphics, right? One really big advantage of R, however, is its extensibility, right? Developers can easily write their own software, right, and distribute it in the form of an add-on package. Okay, because of the relative ease of creating these packages, right? Literally thousands of such packages actually exist in the market today. Okay, this is also a very important thing for all of us to know, right? Because what this means is, right, that let's say anything that you want to do, okay, let's say if you want to perform linear regression, right, or let's say you want to perform any machine learning algorithm, okay, it means that you do not have to write a code right, from scratch to perform a particular operation, right? If you have to code out the whole algorithm, it would take you days to write that program, right? To write that code could take weeks as well, right? Because making sure all the formulae, all the backend is properly coded out, right? It's a difficult thing to accomplish, first of all, right? But you don't have to do all of that, right? There are a lot of people, lot of statisticians, lot of programmers who've already built out those functions, built out those packages, and they've made it available for everyone else to use for free. Okay, so anything that you want to do today, right, most likely there'll be a package, there'll be a function which is already available, right, for you to leverage. Okay, which means it reduces a lot of effort, it reduces a lot of, it makes sure there's a lot of reusability, right? You do not, if any work that you want to do, you do not have to sort of reinvent the wheel every time. Rather, you could leverage what is already available, right? There are a lot of packages, a lot of libraries, right, which we would use from time to time as well, right? When, let's say, if you want to build a recommendation engine, we would leverage a library, we would leverage a function, right, which, let's say, a programmer has already coded out and made it available for public use, right? So instead of writing out the whole algorithm, we would just leverage that function, right? Spend time in, let's say, improving that output, spend time in interpreting that output rather than just coding it out. Okay, so that's another advantage of R. It connects with a lot of other languages as well, right? It connects with SQL, it connects with a lot of databases as well, right? So if you want to extract data directly from R and RStudio, you could do that. And very importantly, it provides a very, very engaged community, right? Many people who use R eventually start helping new users and advocating the use of R in their respective workplaces. Okay, so let's say if you want to reach out to someone for help, right? Let's say if you get stuck on a particular code, it's very, very likely that you would be able to find a solution about it on the web, right? Stack Overflow, etc. will have millions of solutions, right, that are available to problems, right? Because the problems that you face won't be unique, right? Someone would have faced similar problem in the past, right? So that already be a solution available for it, right? So that's one very important use case. But the otherwise, let's say, even if you're stuck with something which you are not able to find a solution to, right, you could just create a question, right? There are a lot of mailing lists, right, where you can just draft your question and you could expect a response within a few hours.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, so you would technically get a lot of support, get a lot of help from a lot of other people, right, who are working on RStudio. Let's spend some time just understanding the entire interface of RStudio, right? First of all, I think it's important for us to understand what is, like, all of you have downloaded two different softwares, right? You've downloaded RStudio, okay, and you've also downloaded like the base package of R, right? R 4.0.1 hypothetically, or some other package in Windows. Okay, why have you downloaded two different softwares? Okay, the reason we have downloaded two different softwares is because the first software that you download, which is called, let's say, R 3.5.5 or R 4.0.1, whatever, right, is essentially the base programming language, right, that you basically work on. Okay, and there's another software that you use, that you've downloaded, which is called RStudio, right? So what RStudio it essentially is, it's an IDE, it's a user interface, right? It's a user interface wherein you will write your codes, you will get your outputs, you will get your charts, etc. Right? If you were to code on R, like the base package of R, it would mean, the base version of R, it would mean that you'll not be able to, let's say, it's not as intuitive as an RStudio, right? Which is essentially just made so that your life as a coder is easier, much easier, right? So on the same software, on the same platform, you're able to write your queries, you're able to see how they're executed. If there are any errors, you're able to see it in front of you. All the objects that you created, that you manipulated, are also in front of you, and any output, right, in the form of charts, visualizations, is also available to you in the RStudio itself. Right? Otherwise, all the work that you'd be doing would be in like a command line sort of an interface, right? Where you're writing a code. You cannot save it for future in reference. You cannot, if you want to consume the output, you'll have to possibly export that file to your local machine or a cloud and get it, sort of access that, right? And then look at the output. So it's not very intuitive. It's not very user friendly. For that reason, right, we are making use of R. Anything that you write on RStudio will go and base platform, the base software, right? And the output will basically get fetched from there. Okay. So you will need both the softwares to be present on your machine. Only then you can build programs, only then you can build out your codes. Got it? So RStudio is essentially the interface, right, which you'll be using. You would probably never even go and try to open your R, this software, right? So if I press R, there are two softwares that you see, right? This R, and there's this RStudio. This one, right, which is just R, is essentially the base programming package. Okay, this is where all your codes that you write on RStudio will go and sort of also fetch output from. Okay, but this is not very intuitive, right? It is not very user friendly. For that reason, we're using an interface which is RStudio. Okay, people who are familiar with, let's say, Python, think of RStudio as something like a spider, right, or a pie chart, where you would write and manipulate your queries. Okay.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So whenever you open up your RStudio, I think all of you should open up your RStudios now. As soon as you open up your RStudio, you should see these 4 screens in front of you, right? These 4 panes in front of you. I will briefly talk about what is the function of each of these panes. Okay, each of these 4 screens that you see. If someone is not able to see 4 screens, rather if you see just 2 of them or 3 out of them, what you could do is you could just go to view, okay, view and panes, and then you tick this show all panes, right? If you activate show all panes, what would happen is all the 4 windows, all the 4 panes, right, that you are seeing on my screen will be activated in your machine as well. Okay, so let me briefly take you up around the RStudio software, right, the RStudio interface, and tell you what is the significance of each of these screens, right? What is it that you should expect to happen in each of these 4 panes? Okay, so this screen that you see, right, on your top left corner, okay, this is called the source window or the script window. Okay, it's called the source window. Okay, you can also call it the script window. All right, I will tell you the significance of this, right? This window that you have on your, let's mark it as 1. Okay, this window that you have on your bottom left corner is called the console. Okay, this is your console. Okay, we'll come back and discuss what is the significance of console. Then you have something called as environment, right? The third window, which is the top right corner, is called environment. Okay, and then on the bottom right corner, right, you have your 4th pane, which is called, it's essentially called the plots window or the package window. Okay, the plots pane or the package pane. Let's start with the first pane, which is the source or the script pane. 1 second. Yeah. Okay, so this pane, right, what is it all about? This window is, as I said, it's called the script window, or it's also called the source window. This is where you will write all your codes. Okay, anything that you write on your code on this window will basically be a program, will basically be part of a program that you're creating. Okay, for example, let's say if I have to create a variable, I have to create an object, right, whose value I'm storing as, let's say, 500. Let's say I want to store what is the price of Apple, okay, as on today. I could create an object. Let's say that object I'm creating has its name as price Apple. Okay, and I could save its value as, let's say, 50. Okay, what I've done here, okay, what I've done here is that I've just written out a line of code, okay, on the script window, right? This is something that I've done so far. I haven't executed it yet. Okay, anything that you write on on the screen, unless you purposely execute it, okay, it will not get executed, it will not get implemented. Okay, how do you execute this? How do you write this? There are two ways to do it. One, you can just go to the end of the line of the code that you've written, right, and just press run, right? This button that you see here, okay, the button that you see here is called run. The purpose of this button is to execute your code. Okay, let's say if I go here and press run, my code gets executed. Okay, how do I know whether my code has been executed? Right, I would know that if this code gets transferred to the console window. Okay, if my code gets transferred to the console window, it means that my code has run, that my code has executed. Okay, now what else do you do? Like, what is the other way in which you can execute your code? The other way you can execute your code is, let's say, you can execute your code just by pressing Control and Enter. Okay, let's say if I want to print, okay, print hello everyone, I could just select it. Even if I don't select it, let's say if I place my cursor somewhere on this line and press Control Enter, okay, or let's say press Command Enter, okay, for people who are using a Mac, okay, what would happen is this code will get executed. How will you know that it gets executed? Right, it will show up on your console window. Right, so this window that you see right on your top left corner is called the script window, wherein you would write all your scripts. Okay, you also have the option of saving scripts. Right, any program that you write, any script that you write, right, you have the option to save it. How do you save it? You could just press, of course, this floppy button that you see, you can press that, or you could just do Control S. Okay, it will prompt you to save this file as an R file. Okay, it's an R script file. Right, let's say I just name it as test. Okay, R test. Okay, this gets saved. It means that, let's say now this code is saved for you. Right, next time when you want to store the price of Apple as 50, and next time when you want to print hello everyone, you will not have to write it out again. Rather, you could just call this, you can just open the script, right, and you can execute it directly. Okay, the reason why we save scripts is because we want to make sure that our codes, our programs are repeatable. Okay, any program, any code that I write today, right, could be of use for me tomorrow or day after tomorrow or next week, right? Also, I want to make sure I keep building on top of it, right? So it's important that you're able to save your codes, and it's important that you're also documenting your codes well. Okay, so this is the window where you will write all your codes. This bit, right, that's when I will refer back to your questions and try and answer them. The next window that you have is called the console window, right? This window. What happens in the console window, right? Console window is essentially that place, right, where you will be able to see all your outputs. Okay, so if a code that you've written, if a script that you've written, right, in the script window, if it reaches the console, right, if it gets transferred to the console, it means that this code has run. Okay, in some cases, right, when you expect an output to be generated by a code, right, you will also see that output here. Okay, for example, this code that I had written, right, which is print hello everyone, right, I'm expecting R to print hello everyone, right, in the console, and that's what has happened here. Right, as a result of this code, it will also show you that which code has been executed, and then any output that you're expecting out of that code will also show up in the console window. Okay, so console window will show all the output, right, any output. If at all your code is expecting an output, it will show up here. There are some codes which will not generate an output, right, because let's say if you're trying to create a variable, right, there's no output that's expected out of it. Creating an object will create an object, but it will not output it. Right, so only if a code deserves an output, only if your code is expecting an output, it will show up in your script, in your console. Okay, so that's the purpose of the console. Another thing that your console does is that it shows you any errors or any bugs that your code is generating. Okay, for example, if I write buggy code, let's say if I write something like this. Okay, now this thing that I've written is not a valid syntax, so it is expected to give me an output. It is expected to give me a error. So when I run it, right, when I run it, it tells me that, okay, this line of code, okay, has of course been executed because it's getting shown in the console. But it also tells me that there's an error that I am getting out of it. Right, the error is object y not found. Yeah, object y not found. Okay, so any outputs, any errors, right, that you see, that you are experiencing will show up on the console window. Okay, There's also something called terminal and jobs, but we will not talk about it right now. It's not very significant. It's not very important for you right now. So we'll ignore it for now. Okay, let's just concentrate on things which are important for you to understand right away. Okay, so we've covered the script window, we've covered the console window, right? Now we will move on to the right hand side of the RStudio platform. Okay, this window that you see on your top right is called the environment window, right? What do you mean by the environment window? Environment window is that window, right, where you'll be able to see all the objects that you have generated, all the objects that you have created. Okay, all the objects, all the variables that you've created will start showing up on your environment. Environment is that place which tells you, right, it gives you all the, basically gives you a summary of all the data objects or functions, right, or variables that you have created and stored for future reference. Okay, for example, I had created this variable called price of apple, right, and stored its value as 50. You can see this object or this variable being present in the environment. Correct? Okay, I can try creating another object, right, and as soon as I execute it, right, it will start showing up in your environment. So let's say I would call something as test object, okay, and I will store values between 1 to 10 in it. Okay, see, as soon as I do it, as soon as I run this, an object test or underscore object gets created and it starts showing up on your environment screen. Okay, also you should realize that by the way, these objects, right, or these variables that we're creating, these are by default getting created as global objects or global variables, which means you can use these objects, right, any object that you've created across any program, right, that you write within the same RStudio session. Okay, you can be working on multiple projects at the same time. Correct. Let's say you're working on project number 1, which is doing linear regression on a test object, right? And then on the like along with that, we're also working on another problem, which is, let's say, a logistic regression problem. Okay. So what would you do in that case, right? You will have two different windows open, right? Let's say this is my script number 1, this is script number 2. Okay. But your environment is common between the two scripts, right? So the same environment, the same set of objects can be leveraged across both the programs that you write. Okay. In case anyone doesn't know how to open up a new R script, you could just go to file. Okay, within file, just do new file. Okay, and click on this button called R script. Okay, what it would do is it will open up a new R script window for you, right? And you can have multiple R scripts open at the same time, right? You have different tabs in Excel. You can have different script files open as well. Okay, so this is the environment window, right? It will show up all the objects, all the variables, all the functions that you're creating, right? Anything that you have created will show up in your environment. Okay, it also has something which is called the history window, right? History is like, it's important. I mean, I don't know if it's important. I have not used history a lot, but what it stores is essentially all the codes, right? All the executed codes, right? All the executed programs, all the executed scripts will show up in your history. Let's say even if you clear your console, right, you can still access the history of your code, right? History of what you've executed in the history, right? In this tab. Okay. So let's say even if I clear everything in the console, right, and I can do that by doing a Control L. Just go to your console and do a Control L. It will clear your console, but it will not clear the history, right? The history will still be available for you, right? Why is it important? It's important because sometimes you might write a buggy code, right, but you would decide to clear your console, but then you would not know, right, where your code is problematic, right? So then you can go to your history and then try running it again, right? Try getting it back. Okay, so that's why you have history. You also have something called connections, right? So if you establish a new connection with, let's say, a SQL database, SQL database, or a Hive database, etc., it will show up here in your connections. Okay, I don't have any connections open right now, but if you had any, they will show up in your connections tab. Okay, so this is the environment window. The most important part of it is essentially the environment itself. All the different objects that you basically consume would show up here. And the last tab, right, which is also very important, it's actually one of the most important tabs in RStudio, is basically this plots window, okay, or the packages window. So there are multiple tabs in this window, right, and each of them are very important. For example, you have something called as the plots window. Okay, something called as the plots window. Any visualization that you create, any chart that you create, okay, will show up in the plots window. Okay, I can give you an example of that, but it is just, I'm just trying to show you how a plot gets populated in the let's say in your R script, right, in your R programming. Okay, I'm just generating another object, okay, which has, let's say, values between 100 to 110. Okay, and then I can do a plot between the two of them. Plot. Okay, the lengths are different. See, okay. Okay, so if you see, I just created a scatter plot, right, between a set of values in the y-axis and a set of values in the x-axis. But the plot that I generated, right, as soon as I run this, okay, it shows up the output on the plot window, right? So any charts, any plots that you generate will show up here. Okay, you have the option to zoom them. Okay, you have the option to, of course, go back to the same visual, and you can also export these outputs as images, PDFs, or you can copy them on a PPT, right, or any other Word document, etc., that you might have open. Okay, so this is the plots window. It's important because you will generate a lot of visualizations. All your visualizations will come and sit here. Okay, then you have something called as the packages window, right? This is a very important window, guys. Okay, when you work in RStudio, you will basically leverage several packages, several libraries. Okay, some of them native to R. Okay, some of them native to the R software that you've downloaded. Okay, but some of them that you have, let's say, installed from outside. Okay, so from when I say outside, it doesn't mean you've installed it from like it's still essentially an R program. It's still essentially an R library which is custom made for RStudio itself, right? The purpose of installing a new library or a new package could be, let's say you realize that there's a function, right, that is available in another package, right, but it's not available in the base package. For example, if you want to perform, let's say, random forest as a machine learning model, the base package of R, right, does not support it. Rather, you will have to download a library which supports it, download a package, right? A programmer must have coded out the whole R, the whole random forest program, a machine learning technique that had made it available for all of you. Okay, so you can install that package and that package will come and sit here, right? How do you install a package? You could just go to install, okay, search for the package that you're trying to create. Sorry, package that you're trying to install. Okay, a pack, by the way, I might refer to these two names, right? Packages and libraries. They're both the same thing. Okay, anything that you've installed from outside, right, and using it within RStudio is essentially a library or a package. Okay, so let's say if I want to download a package, right, install a package which is custom made for visualizations. Its name is ggplot2. Okay, ggplot2. I could just search for it, okay, and click on install. And as I do it, the installation of the package will start. Okay, as soon as it gets installed, okay, it will start showing up in the list of packages which are already installed for me, right? So this list of package basically means some of the packages that come installed, pre-installed for you as soon as you download RStudio or R. Okay, there could be many other packages that you choose to import, that you choose to install, right, to build your programs. Okay, so like the one that I did just now, right? So I installed this package called ggplot2. It did not exist here, but now when I search for it, because it's been installed now, I'll be able to see it. Okay, so you can install packages, you can update packages, right? You can keep referring to your packages from here. Okay, so packages are important. And then the last tab which is important for all of us here is the help window. Okay, help window is very, very important for all of us. The reason for that is because we are starting out learning about R or RStudio. Okay, so it's very, very likely that we will be stuck with things. We will not know the syntaxes of several functions. Okay, we might know what the name of the function is, but we will not know what the syntax of that function is. So what do we do in that case? Of course, the first option could be Googling for it. Okay, and Google will give you pretty reliable searches, right, reliable outputs. But what you could also do is you can search for them in the help window, right? Let's say if I want to search for a function, let's say I want to do I want to perform a mean, right? I have a list of values. I want to perform a mean. I don't know whether the function mean exists, right? And if it does, what is the syntax for it? How do I use it in RStudio? I could just write mean here, right? And then the help windows will start showing me the function which is used to calculate the mean, right? So it says mean function basically is used to generate arithmetic mean. Okay, it also shows me what is the syntax of it, right, and what are the different arguments that the function is expecting out of you. It will also show you a few examples, right, of how you can use this function, this function is essentially, right? Let's say there's another function that I want to refer to. I don't know what the syntax of that function is, right? Let's say summary. I click on it and it shows me the syntax which is used for generating a summary of an object, right? It will also, I mean, this is a very useful resource, guys, right? Because it gives you information in the sense that what are the different ways in which you can use this function, right? And then what are the different arguments that you could be using, and how these arguments, like which ones out of these arguments are compulsory, which ones are not compulsory, which ones are optional, right? And how do you use them is something which you can easily refer to with this. Okay, you will also have examples to refer to, right? And for this reason, I tell everyone, right? I mean, I think this is a question that a lot of people ask me, is that whether we are required to learn, whether we are required to by heart syntaxes and functions, right? And my answer to everyone is no, right? We should never spend our energy in by hearting, right? I mean, in learning. When I say learning, I mean just learning or remembering the syntax of a function, right? That's probably the last thing that you'd want to remember. The reason for it is because it's very, very easily available to you, right? You just saw how easily I can refer to the syntax of a function, right? The only thing which is important for me to remember to some extent is the purpose or the meaning of a function, right? Why would I need to use a particular function? Let's say if I want to accomplish a task, I should know what function would accomplish it, right? But how it accomplishes that, or what is the syntax of that function, you don't need to remember that. You could always come to summary. Sorry, you could always come to help and then get the syntax here, right? Over time, of course, you will start remembering a few syntaxes, right? But that will not be on purpose, right? That's essentially out of habit that you will start remembering a few syntaxes. But I would never expect you, I would never recommend you to spend energy, to spend time on just remembering syntaxes, okay? Because that's the last thing which you would want to spend your time on, right? Because all of that is already available to you, right? It's very, very easily, it's very, very frequently available either on the help window or even on the web, right? If you Google for a function, the syntax of the function, it's probably the first search output that you would get. All right. So never spend time in remembering syntaxes, rather just try and understand how a particular function would work, right? And where you could possibly use it. Okay, so that's about it, right? In terms of the whole interface, these 4 tabs, right? What is the purpose of each of them? Okay, that's the whole interface of RStudio, right? That's the purpose of each of these panes, right? Now we would start going deep into understanding how programming works, right? How would you perform certain operations, certain manipulations in RStudio? Okay, so the first thing that you all of us need to know, right? Whenever we are doing programming, right? Any kind of programming, be it in R, Python, anywhere, right? The first thing that we need to know is what is a variable. Okay, variable is probably one of the most, like, one of the those concepts which you would learn at the very first step of any programming language, right? So, and I'm sure a lot of you would know what a variable is. Okay, so variable is nothing but it's a temporary storage space, right, where it can keep changing values. Okay, whenever you have to create something, right, whenever you have to store something, okay, store any value or store any fact or store any information in R or any programming language, you generally decide to do that, okay, by creating something which is called as a variable, right? A variable is that temporary storage space in any programming language, right, whose value can be changed, right, based on your convenience. For example, okay, for example, I want to create an object, I want to create a variable where I store the price of apple. Okay, I want to store the price of apple. Now I know that the price of apple keeps changing, right? Let's say today it's 100 rupees per kg, tomorrow it could be 150 rupees, or tomorrow it could be 90 rupees per kg. Okay, so what I would do is I would create a variable, right? In R, I would create a temporary storage space, right, whose value can keep changing over time, right? It can be 100 today, it could be 150 tomorrow, it could be 300 tomorrow, right, or day after tomorrow. So anything on which, right, you would want to sort of keep changing, that's essentially a variable, right? Variable is important because you would essentially manipulate information across variables, right? You would store a lot of information in variables, you would manipulate large pieces of information, right, using these smaller objects called variables. Okay, when it comes to programming, is what is a data type? Okay, as the name suggests, that data type is nothing but the nature of that variable. Okay, nature of that variable. What do I mean by the nature of that variable? The nature of that variable would mean whether that variable is a number, right, or if that variable is a character, which means it's an alphabet. Okay, or is it a word, a sentence, or is it something which is a binary value, a 1-0 sort of a thing, or a true false sort of a thing. Okay, or whether it's a complex number, right, or it's a set of values. Okay, so data type in R essentially is something which is used to denote the nature of the variable, right? What kind of variable are you creating? Is it a numeric variable, right? So there are 4 major data types. Okay, there are 4 major data types in R. These are the most popular ones, by the way, right? There are more data types as well, right? These are the 4 most popular data types. The first one is numeric, right? Any number, let's say if you're creating a variable called price of apple, then you would have to store that variable as a numeric variable, right? Because it's storing a number. The price of apple is going to be a number, right? It will be 100, 100, 200, 300, whatever. It's a numerical value, right? So any variable which has number stored in it, it's called a numeric variable, right? And the data type which is assigned to it is numeric. Okay. What is the next data type that you can possibly encounter? It would be character, okay, or string. Okay. Let's say if I want to store the name of every individual who's attending this course right now. Okay, names generally are character values, right? Let's say if I pick a name, let's say Lakshay or Sonak or Shulab, whoever, right? It's essentially a character, right? It's, or let's say it's a combination of two words, right? Sonak Banerjee, right? Sonak space Banerjee is a combination of two words, right? So anything like that, right, which is either one alphabet or a combination of multiple alphabets and special characters like spaces, stars, parentheses, etc., are known as character variables. Okay, if I have to store someone's name, okay, then I will store it in a variable which is whose data type is a character data type. Okay, so that's the second data type which is important. The third kind of data type is called the logical data type. Okay, what is a logical data type? A logical data type is usually stored for variables which have binary outcomes. Okay, let's say if I want to store information like whether, let's say if I was taking attendance for this course, okay, every session I'm taking attendance, I'm going to check whether a person is present today or not, right? Let's say the field is called present, right? And I would mark true or false in that, right? I will probably go and check with every participant, hundreds of people who are here. I will check with them whether they're present, right? If they say yes, I will mark true. If I don't hear a response, I will mark false for them.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, a variable which is generally used to store information which is binary, true or false, yes or no, 1 or 0, right? The data type that you assign to it is logical data type. Okay, the third kind of data type. And then the fourth data type is essentially complex data type. When you're storing a complex number, right, in the form of where you have a principal component and imaginary component, right? 2 plus 3 iota, 30 plus 2 iota, 30 minus 2 iota. Such numbers you would store as a data type which is called complex. Okay, that's what data type is. Okay, so you have four primary data types: numeric, character, logical, and complex, right? And you have several other advanced data types as well, right, which we would discover probably at a later time. At this moment, it's important for us to realize that there are 4 main data types that we will use while we are programming. Okay, then what is important for us to know? It's important for us to know what are the different operators that are available in R. Okay, what is an operator? An operator is nothing but it's essentially a function, a pre-coded function, right? A function which is already available that helps us performing certain manipulations on top of data and variables. Certain operations which are common, right? Operations which have a specific output expected out of them. Such operations, such functions are called operators. Okay, if I want to do a particular operation in R, right, what I would do is I would make use of an operator, right, that already exists, right? Rather than creating a new operator, I would use some of the existing operators. Okay, what are some of these operators or how they work? Okay, like we will also do this in a hands-on manner. But before that, it's important for us to know that there are 4 primary types of operators. Okay, 4 major operators that we use in R. The first kind is called assignment operator. Okay, as the name suggests, assignment operator is generally used for assigning a value to a variable. Okay, if you want to assign something to a variable or to an object, you would use something which is called the assignment operator, right? Generally, across a lot of programming languages, equal to is used as an assignment operator, right? If you say x is equal to 10, it means you're assigning 10 as a value to x. Okay, but does that does that hold true in R or not, right? Whether equal to is a valid assignment operator in R, we will discover that. The next kind of operator is called arithmetic operator. Arithmetic operators, as the name suggests, are operators which are generally used for arithmetic operations, right? So if you want to add values, if you want to subtract values, if you want to multiply, divide, square root, exponent, power, etc. If you want to do arithmetic operations on top of variables, on top of values, right, then you can make use of something which is called arithmetic operators, right? There are several arithmetic operators as well, right? Then you have something which is called relational operators. Okay, relational operators, as the name suggests, is used to identify relationship between different objects, right? If one value is greater than another value or not, you will make use of, you will be able to identify that by using a operator which is called the relational operator, right? Understanding whether a particular value is equal to another value or not, right? You will do that by making use of something which is called the relational operator. Okay, and the last kind of operator is called the logical operator. Okay, a logical operator, an and operator or an or operator, which is used for combining multiple operations, right, or combining multiple criteria. Let's say if you want to check, right, if a particular operation, if let's say a set of, let's say if you want to check two different conditions, right, if the value of x is greater than y and the value of y is x is also greater than z, right, and based on that you want to perform another operation, you can do that by using something called as a logical operator. Okay, logical operator is nothing but an and, like a and or operation, right, wherein you can combine multiple statements or you can combine multiple expressions together to create a composite expression. Okay, so these are the four kinds of operators, right, that exist in R. We are going to briefly touch upon each of them, right? We'll see how you would use all of these operators, how you would execute things using these operators. Okay, open up your RStudio and practice this along with me. Okay, the first kind of operator that we will learn about is called an assignment operator. Okay, assignment operator. Assignment operator, as I mentioned before, is basically an operator which is used to assign a value to an object, to a variable. Okay, generally the operator that you use to assign a value to a variable, it's basically the leftward assignment operator. Okay, this assignment operator, right, which is nothing but the less than sign. Okay, the less than sign followed by a hyphen. Okay, this is basically a leftward assignment operator. Okay, you will use this assignment operator for assigning values to a given variable, to a given object, right, or to create a new variable you will use a leftward assignment operator. Now there are a couple of other assignment operators also available for you, right? There's a rightward assignment operator and there's also an equal to assignment operator, right, which you could use interchangeably, right? But the most preferred one, right, or the most popular one is the leftward assignment operator, right? So you should know that there are two other ways in which you can assign values to a variable, right, either through this or through this, right? This is an equal to operator, this is a leftward assignment operator, but the most important one, or at least 80 to 90% of the statisticians or data scientists use this, right? This is the most commonly used assignment operator. Okay, so I'm just going to zoom in and show you how you can use a leftward assignment operator for performing an operation. Okay, cool. So the first thing, by the way, if you want to comment out anything in your script window, right, if you write something but you don't want it to be part of your execution, you can just comment it by using a hashtag, right? So whatever starts with a hashtag, right, it just gets commented out, right? Even if you select a bunch of code and you run it, it just means that anything that has started with hashtag will be excluded from your operation. Okay, I will show you later how you could comment multiple lines of code. Okay, but for now just use a hashtag. Okay, so I'm going to show you how you can create variables, right, using a leftward assignment operator. Let's say, first of all, I'm going to clear my environment, right, because it has a bunch of values. How can you create your environment? You can just click on this broom. Okay, this broom that you see on your environment and click yes. Okay, this will clear your environment. Okay, so what I'm going to do is I'm just going to create a variable x, right, any random variable, and I'm going to store its value as, let's say, 100. Okay, so how would you do this? You would just write the name of the variable. Okay, and this is something that you could choose, right? This is just the name of the variable, so you can choose what name you want to give to the variable that you're creating. You can call it my first variable, you can call it x, you can call it I don't care, whatever, right? It's your choice. Just use whatever name you want. Okay, make sure it doesn't start with a number, okay, or it doesn't start with a special character. It has to start with a alphabet. Okay, let's say x, or I could just write my first variable. okay, in R. Okay, also in the name of the variable you cannot have spaces or any special characters, right? You cannot have spaces in between. You have to have you can have underscore, right? But you cannot have space, or you cannot have a star or a parenthesis, etc. Okay, let's say I'm creating this variable called my first variable underscore R, my underscore first underscore var underscore R, right? And then I'm using a leftward assignment operator, okay, to assign a value, let's say 100 to it. Okay, so this is how you assign a value to a variable. Also, you could say this is how you create a variable. Okay, so when you run this, right, you could just press select this and then press run. Okay, you would know that this code has run if it shows up in your console. Okay, and then as soon as that happens, you would see that in your environment there's something called my first underscore var underscore r gets created and gets shown. This means that you have successfully created a variable. Equal to, I can talk a little bit about equal to, why equal to is not used popularly, right? The reason why equal to is not used very popularly is because equal to is also a relational operator, right? So when you want to check whether a value is equal to another value or not, right, that's where you make use of another operator which has a similar notation as this, right? So sometimes when you have both relational operator and an assignment operator present in the same query, in the same code, it might just end up confusing you, and it might also end up confusing RStudio because of the similar notations, right? Of course, the assignment operator is just single equal to, and the relational operator is double equal to. But it's a common mistake to forget that assignment, that the relational operator has double equal to's or not a single equal to, right? And for those reasons, it's avoided, right? Generally, the best practice is to avoid an equal to operator, rather use something which is called the leftward assignment operator. Okay, so this is how you create a variable, right? You can also use a rightward assignment, and this is how you would do it, right? If you want to write the name of the variable, you want to write the value first, 10, okay, and then you write the rightward assignment and then write the name of the variable. Let's say y is that variable, and then run this. It works the same way, right? It just creates a variable y and it stores its value as 10, but the way you write it is very different from how you would write a leftward assignment, a statement using a leftward assignment. In terms of execution, in terms of efficiency, there's not much of a difference. Okay, same thing with equal to as well, right? You could just write z is equal to 10, right? And it will also create a variable for you. Okay, so as I said, you can use either of these notations. The most popular one is this, right? In all of my codes, in most of my codes, I just use the leftward assignment operator, right? So let's say if you end up using something else, right, and if you were to use my codes later on, then it might just confuse you a little bit. It might just be a weird experience for you. So if you want, if you like, try and align your codes with what I write here, right, which is the leftward assignment operator. No, again, no push on that, right? Up to you. But yeah. Okay, the other thing, by the way, is that R is extremely case sensitive. Okay, what do I mean by case sensitive? It means that it is able to distinguish between lowercase or uppercase. If you write something in capital letters and then you write something in small letters, okay, R will treat them as two different values. Okay, and I'll show it to you, right? For example, I created this variable called my first var underscore R, right? Okay, let's say I create another variable which has similar notation, absolutely similar notation, but instead of a small m, I just write a capital M, right? So this one has small m, this one has capital M, and the one which has capital M, I'm storing its value as 500. Okay, when I run this, you would see that there are two different variables that get created. Okay, there are two different variables that get created, right? There's the first one which has a small m, the second one which has capital M. Okay, and now let's say if you made this mistake, right, that in one place you wrote a small character, in another place you wrote a capital character, right? It will mean that it will induce some kind of an error in your programming, right? Because you were expecting some other output, right, to be coming because you had used a similar notation somewhere else. So be very careful with this. Okay, be very careful with syntaxes, with cases specifically. Okay, so yeah, that's that. Also, guys, you do not need to declare a variable before creating it, right? So in a lot of programming languages, what you're required to do is you have to first declare that this variable my first var underscore r is essentially a numeric variable, right? You will have to write dim xyz as numeric or as integer, and then you have to assign the value. But that's not required in R, right? R is intuitive enough to guess based on the value that you supply to it. It will automatically assign the data type numeric to it. Okay, so you do not need to declare a variable first and then create it. Rather, you can just create it, and as soon as you create it, it will automatically declare its data type as well. Okay, and it is possible that, let's say, you want to create a variable in a different data type, but R intuitively creates it in a completely different data type. Then you also have the choice to overwrite it. You have functions on which you can basis when you can overwrite the data type of a variable. Okay, but intuitively R will create its own data types, right? It'll assign the data type by itself without you having to declare it, which is, I feel, a big advantage, right? It's essentially less effort for you, it's less work for you. Okay, so this is how you assign values. Okay, assign values, and you can assign several types of values, right? Uh, so for example, if you want to find out what is the data type of this variable, you can use this function called class. Okay, class of my first var of underscore r. It gives you numeric, right? It's essentially storing this variable as a numeric variable, which means without you having to tell R that it's a numeric data type, it is intuitively storing this variable as a numeric variable. Okay, but if you write something like this, right? If you write P is equal to double quotes, by the way, any string or any character values that you write, they have to be enclosed within either a single quote or a double quote, right? Either a single quote or a double quote. Let's say if you run this, right? P has the value male stored in it. Okay, when you write class of P, right, if you want to check what is the data type of P, right, it will tell you that the data type of P is character. So without you having, again, right, without you having to declare that P is a character variable, right, R has done it for you, right? R has intuitively decided that it's a character variable, and you can just directly create your variable. Okay, you can create also variables which have, let's say, spaces, etc. in them. All right, so this is how you create variables, right, using a leftward assignment operator or a rightward or a equal to assignment operator as well. Okay, the next thing that we'll discuss is the arithmetic operators. Okay, arithmetic operators are fairly straightforward, right? You know, there would be a plus operator, there will be a subtraction operator, there will be a multiplication object operator, right? So I will very quickly show you how each of these would work, right? But we will not spend a lot of time in it, right? Because it's very easy for you to understand, it's very easy for you to follow. So what I'm doing for this purpose, I'm just creating two variables here. Okay, the first variable I'm creating its value I'm going to store as 100. The second variable, its value I'm going to store as 200. Also you should know that it's very easy to update variables. Okay, let's say you've used a variable x, you've already created a variable x here, okay, whose value you stored as a character, right? Animal space group. Okay, but if you want to overwrite it, right, if you want to create a new variable x and use it for a different notation altogether, that's also something you could do. Okay, so let's say if I do this, right, if I just write x is equal to 100, okay, what R will do is it will overwrite x from being a character variable to now being a numeric variable, right? Because the latest operation that you've done tells RStudio that x is a numeric variable whose value is 100, right? So when I do this, when I run this x will get changed from animal group to 100, right? And its data type will also change. See, okay, so I'm going to create two variables, x and y. X is 100 and y is 200. Okay, let's say if you want to create another variable, right, another variable z, whose value is stored as the sum of x and y, you can do something like this, right? You could just do z is assigned as x plus y, right? And you do not need to give any spaces. I'm just giving it so that it looks tidy. Okay, but you can write it something like this as well, right? X without any spaces, assignment operator. So z is equal to x plus y. This also works, or even if with spaces it would work. Okay, so as soon as you run this, right, as soon as you execute this, what happens is there's a variable z that gets created. Okay, and it gets stored on in your environment, right? Let's say you did not want to store this value as another object, as another variable in R. Rather, you just wanted to output it. Okay, I just want to know what is the sum of x plus y, right? Then you can just write x plus y. Okay, run it. As soon as you run it, on your output you'll be able to see the value.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Okay, so whenever you assign something back to a variable, it doesn't show up in your console. It just shows the script has been executed and then the output is shown in your environment, right? But if you don't assign it to any variable, right, then on your console you'll be able to see the output as well. Okay, so when you do z is equal to x plus y, it doesn't show up as an output. Okay, it just shows in your environment, right? The value of z is stored as 300. But if you do x plus y without the assignment, then it gives you the output. Zookeeper, whatever name you want, you can use it. It's purely user defined. Okay, when you do this, it just stores the name of the variable as zoo underscore keeper. Okay, so whatever name you choose, anything that's on the left of the assignment operator is something which is user defined, right? You have full liberty to choose the name that you want to assign, give to it. Okay, so like you have addition, you also have subtraction, right? You can do y minus x. You can do multiplication, which is y star of x. Okay, you can do division, right? That says z divided by x. Okay, you can do exponent. Okay, you can do exponent. You can do 5 raised to the power 3, 5 raised to the, or let's say x raised to the power 3. Exponent is nothing but power of, right? So when you want to do square, cube, 10 to the power 100, etc., you can make use of this, right? X to the power 3 is this, right? X is 100. X to the power 3 would be nothing but 10 raised to the power 6, right? That's what you get here. Okay, so you can do exponent, right? And these are the primary operations that you would do, right? Using arithmetic operators. Okay, so these are some of the arithmetic operators that you could use. You can do plus, minus, division, subtraction, multiplication, exponent, anything that you like. Okay, the last kind of operators that we will study about are called relational operators. Relational operators, as I said, are used to define relationship between a set of values. Okay, so relational operators are nothing but operators which are used to depict relationship, right, between two or more than two variables, right? Let's say there are 5 or 6 different types of relational operators. There's less than relational operator, which is given by this. Okay, so let's say if you want to find out if there are two variables, okay, x is already there, x is 244144045, whatever, and then you have y. Let's say its value is 1234. Okay, I have to run this. Yeah, y is this, right? Then if I want to check if the value of x is less than y or not, right? If I want to check the relationship, right, then I could just do x is less than y, and when I run this, it will give me an output false because the value of x is not less than y, rather it could be greater than or equal to y. Okay, so relational operators are used to check relationship between two variables, right? If a particular operation, if a particular relationship is true, the output will be true. If it is false, then it will be false. Okay, yeah, so let's say you can check if something is less than another variable. If you can check if a variable is greater than another variable, right? This is for less than, this is for greater than. Then you have something called greater than or equal to as well, right? You can do greater than or equal to. Okay, or you could do less than or equal to. Okay, then there's also something called equal to operator, right, to check whether something is equal to another value or not. Okay, and then finally you also have not equal to, right? So this is not equal to. These relational operators are generally used as part of a expression that you want to check, right? So based on a particular let's say based on a particular criteria, if you want to decide whether you want to perform another operation or not, right, that's where you would use this, something like in an if else loop, right? If you would say if x is greater than y, then you would do y, then you would do something, otherwise you will do something else. Okay, that's where you would use these relational operators. But these are all the relational operators that you could potentially use, right? So let's say if I say 100 is equal to 100 and 1, okay, what I'm doing here is I'm checking whether the statement is holding true or not, right? If the value 100 is equal to 101, the output that it should throw me is false because this relationship doesn't hold true. Rather, if I were to say if 100 is equal to 100, it will give me a true, right? Let's say if I were to check whether a value is not equal to another value, right? Generally, this is done with variables, right? I mean, you would know 100 is not equal to 100. That's something which is known to everyone. But if you want to check between two variables, right, x and y, right, that's where you could use this, right? You could say x not equal to y, right? This is not equal to y. When I run this, it will give me a true because the values x and y are not same. Okay. So this is how you can use relational operators, right? There are different kinds of relational operators you could use, right? You could check if a particular value x is greater than or equal to y, right? This should hold true because x is a very big number, y is just 1, 2, 3, 4. Right? So depending on whether your expression is true or not, you will get either a true or false as an output. Right? We will use relational operators quite frequently when we are working with if-else loops, right? So when we are doing conditional statements, that's where relational operators are going to be very useful for all of us, right? But these are all the relational operators you could use, right? There's less than, there's greater than, there's greater than or equal to, there's less than or equal to, there's equal to, and then there's equal to, and then there's not equal to. Okay, so that all of you have access to this, right? You don't have to remember it. Okay. So far, what we have studied about, what we have discussed is what is a variable, what is a data type, how do you manipulate some of these variables by using either an assignment operator or a relational operator or a arithmetic operator, right? But how do you work with larger data sets, right? How do you work with large values, sequence of values, etc., right? Is something that we would learn by exploring something which is called objects, data objects in R. Okay. What are objects, right? Objects are nothing but these are essentially elements, right? Or you can call them data objects, right? Which can store, right? Which you would use to store and modify large pieces of information, right? Information like serial of numbers, names of participants, a whole data set, right? With multiple columns and multiple rows. You cannot do that by just creating a variable, right? Variable will generally store one value. It can store, let's say, a sequence of values, but it will not store an entire data set, right? So what is that data object, right? What are those elements of objects that you could use in R to work with larger pieces of information, right? Larger data sets, larger values. That the element, right, or the parameter that you use in R to manipulate large volume of information is called an object, right? And then there are four big type of objects, right? Four major kind of objects in R. Okay. And these objects are basically created in a way, right, that the purpose and the usage of each of these of each of these objects is very different from each other. Okay. There are two primary parameters based on which these different objects are created in R. The first one is dimensionality of the data. Okay, the data that you're trying to store in an object, right? Whether that data is a unidimensional information, right, or whether it's a multidimensional of information. Depending on that, you can use a variety of objects in R. Okay, what do I mean by unidimensional data versus a multidimensional data? Unidimensional data is something like let's say a sequence of names, right? Let's say if I want to store the names of all the individuals, right, of all the participants who've come to this session today. Okay, I can store that in an object, right? But this information, I can store that in an object which is capable of storing unidimensional or one dimensional information, right? This information is one dimensional, right? Because it has only one column, right? You can store names of people in a column in an Excel file as well, right? You will not need more than one column for doing this, correct? But let's say if you along with the names of participants, you also want to store multiple other pieces of information like their age, their address, right, their qualification, etc. It would mean that you will have to now increase the dimensionality of that data, right? You will have to add columns to you would have to add more columns to it, right? You will not have just one column, rather you will have multiple rows and multiple columns now. So your data will inherently become a two-dimensional data set, right, which has a row and a column. Row and column are two dimensions of data, right? Similarly, you can have multidimensional, right? You can have more than two dimensions as well, but mostly when we're working with structured data, we will talk about one-dimensional and two-dimensional data objects. Okay. So depending on whether your data is one-dimensional or two-dimensional, right, you would have a choice of using several objects. Okay. The second parameter which is used, right, to determine, right, the kind of object that you need to use is whether the information that you're storing is homogeneous, right? Or whether it's heterogeneous. Okay, what do I mean by homogeneous and heterogeneous? Homogeneous means that all the information, all the various values that you want to store in an object, whether all of them have the same data type, right? Or if they have different data types. Okay, if they have the same data type, right? If you're storing, let's say, scores of students, right, in different subjects, right? What are you essentially storing? You're just essentially storing numeric values, right? It could be multidimensional, it could be one-dimensional, but you're storing just numeric information, right? There's no other kind of information that you're storing here. So it then means that you're trying to store homogeneous information, right? Which has only one data type, which has only one kind of values. Okay.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
But sometimes you might have to store more than one kind of values, right? You might have to store numeric values, you might have to store character values, you might have to store logical values, you might have to store complex values, all in the same data object, right? When you have more than one kind of data type, or one kind of if you have more than one data type, right, in your data, then that data set becomes a heterogeneous data. Okay, so based on these two parameters, right, the dimensionality of the data, right, whether the data is one dimensional or multidimensional, and whether the data is homogeneous, which means only one homogeneous and one dimensional. Okay, homogeneous and one dimensional. Okay, this is the kind of information that you can store in a vector. Now, to give you an example, let's say if you want to store the cast, right, the cast of a film, right, all the people who were part of a film, right, their names, then you can store it in a vector. Okay, let's say if you wanted to store the age of 100 people, just the age of 100 people who are part of this course, right, then you can store it in a vector. Okay, if you wanted to store the profession of 100 people, you can store that in a vector, right? As long as all the information that you have is unidimensional, it means it can be stored in just one column of a Excel file. Okay, and it's homogeneous in the way, in the sense that all the values have the same data type, you can store that information in a vector. Okay, so generally vectors are used to store like the kind of things I just mentioned, right? Names of people, names of different names of participants in a course, for example, right? Their age, right? Separately. You can store age in one vector, and then you can store name in another vector, you can store the gender in another vector, right? But in one kind of vector, you can only store homogeneous and one dimensional information. Okay, that's the example of a vector. What if you want to store one dimensional information, right? One dimensional information, but that information can be heterogeneous. Okay, that information could be heterogeneous in the sense that it is slightly unstructured information. Okay, let's say I am watching a movie, right? I'm watching a movie. Okay, a movie. Okay, and in the movie there are different subtitle, like different in the credit scene, right? When you end the movie, there is a credit scene that comes which tells you the name of the person. Let's say name is XYZ. Okay, comma the role, right? Whether that person is a director, right? Let's say director. Okay, the name of another person ABC, right? Let's say what is it? What producer, actor, etc. Right? And also let's say it also features their age. Hypothetically, right? It doesn't, but let's say it features this age, right? Separated by comma. Okay, if you want to store this kind of information, right, which is heterogeneous because it has alphabets, it has character values, it also has numeric values, right? But it is not differentiated across different columns, right? All of this is in the same row of data, right? In the same column, all of this is mentioned. right? It is unstructured in a way, right? If you have information like this, the object that you will use to store this kind of information is basically a list, right? List is an object where you generally store one dimensional information, which means you don't have data segregated across multiple columns, right? And also heterogeneous information, right? Which means information which ranges across multiple data types, right? Here you have two data types, you have character and you have numeric. Okay, so you can store that kind of an information in an object called list. Got it? List is generally used to store unstructured information, okay, where you do not have a way to identify this, like this part of the this part of your data is should be part of first column versus what should be part of second column versus what should be part of third column, right? It's all in the same column, right? It's all sort of jumbled up to just fit in the same row, in the same column. That kind of data is generally stored in an object called list. Okay, list and vectors are both one-dimensional objects, right? Which means they can only store they cannot store multi-dimensional object, but they can only store one-dimensional information. Okay. Okay, now we move on to multi-dimensional objects, right? Multi-dimensional objects. There are two types of two multi-dimensional objects as well. There's a matrix. Okay, matrix is an object which can store multi-dimensional data. It means data which is, let's say, spread across rows and columns. Okay, rows and columns, but the data types, right, of all the columns will be same, right? You will not have heterogeneous, you will have homogeneous information, right? Information which which can all be fitted in the same data type. The object that you will use to store that kind of information will be a matrix. Okay, so multi-dimensional information which can have both rows and columns, right? Two-dimensional information. But if the information is all homogeneous, right, then you will store it in a matrix. Okay, but let's say you have multiple rows and multiple columns of data, right, and all the columns, right, have different data types. Okay, then which means you're storing multi-dimensional information, you're storing two-dimensional information, but that information is also heterogeneous, right? You have more than one data type in it. Then the object that you're going to use, right, to store this information is a data frame. Okay, so matrix is used to store multi-dimensional information which is homogeneous, and data frame is used to store multi-dimensional information which is heterogeneous. So I'll just give you a very simple example of a matrix and a data frame. Okay, and there could be many examples, right? It's a fairly simple concept. There could be many examples, but just to give you a couple of simple examples, let's say, right, let's say you have you have a data set which stores marks of students, right? Marks of students in 4 subjects, right? Maths, science, arts, and English. Okay. Okay. Let's say if this is the kind of data that you're storing, if this is the kind of data that you're storing, right? Just randomly generating data. Okay. Then the object that you're going to use, right? The object that you're going to use to store this information, okay, is going to be a matrix, right? Because all the variables, right? Does everyone agree that this is a multidimensional object? It is a multidimensional object because it has rows, right? You have 1, 2, 3, 4, 5, 6, 7, 8, 6 rows, and you have 4 columns, right? When you have more than one row and more than one column, it becomes a multidimensional object, right? So it's a multidimensional object, and the information that you have, right? All the values that you see in this object, they are all of the same data type. It's all numeric information, correct? So this is the kind of information that you can store in a matrix. Okay, in a matrix. Okay, But let's say along with this, right, along with this information, you also have the name of the student, right? Let's say Prateek, Saurav, Sheesh, whatever, right? Some random names. Then you'll have to store this information in a object called data frame, right? Because you have, this is a character data type variable, and all these are numeric variables, right? And along with this, you can also store more information in a data frame, right? You can also store their address, for example, right? You can store, let's say, their whether they're finally promoted or not, right? Promoted, right? So this will be true, false, true, 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 false, etc. Right? Address could be anything, right? C, X, Y, Z, whatever, right? Something of this sort. All right. So if this is the kind of data that you have, okay, where you have multiple rows and multiple columns, which means it is heterogeneous data. Sorry, it means it's multi-dimensional data, two-dimensional data, but you have more than one type of data type, right? This is character data type. Okay. This is again character, correct? Address is character. This is logical data type, right? And all of this is numeric, right? So when you have more than one kind of data, one kind of data type in your data set, then the data that you will, the object that you will use to store this kind of information is going to be a data frame. Okay, so data frame is essentially the most practical object, I would say, in R, because specifically for data science, because when we're working on a data science problem, when you're building a machine learning model, we would generally create a data set which has more than one data type, and it will have several data types available in the same data set, and it will always be a multi-dimensional object, right? You will always have a few rows and a few columns, right? Several rows and several columns, in fact. Okay, so data set or data frame is probably the most popular, right, or most suited data object, right, when it comes to working on a data science problem, right? What does heterogeneous mean? Heterogeneous basically means if there's more than one data type, right, available in your data, right? If you have columns, right, which all have different data types, then it's called heterogeneous data. If all the data is of the same type, right, of the same data type, it's called homogeneous data type. Okay, so these are the four objects that we're going to use, right? And we're going to manipulate them to see how you perform operations in R. Okay. So yeah, now what we could start doing is we could start exploring each of these objects, right, one by one, and see how do you create them, how do you manipulate them, how do you extract, extend, and do multiple operations on them. Okay. So again, open up your R Studios. Okay, we'll now start exploring these different data objects. Okay, open up your R Studio, right, and okay. So the first thing that we're going to do, okay, within data objects is that we are going to start by learning about the most simplest kind of data object that exists in R, which is nothing but vector. Okay, we will start with the simplest data object, right, and see how do we create it, how do we extrapolate it, how do we manipulate it, right, in R Studio. Okay, so just to repeat, what is a vector? Vector is nothing but it's a sequence of data elements, right, a collection of data elements, all of them having the same data type, right? So a vector can have only one kind of data type, hence you can also assign a data type to the entire vector as well, right? If all the values which are stored in it are numeric, the vector is also a numeric vector. If all the values stored in it are character, then the vector is a character vector. If all the values stored in a vector are logical, then it's a logical vector. Okay, but you cannot have a data type for a data frame, right? Because a data frame could be a combination of a numeric vector or a character vector or a logical vector. Correct? Cool. So let's try and see how do you create vectors, right? The function that you use to create a vector is the small c. Okay. Vector is basically created by using this function called c. Okay, c, and within parentheses you have to supply different values. Okay, so how do you create a vector using this function c? This function c basically stands for concatenate or combine, right? What you're trying to do is you're trying to combine multiple values together to create one data object, right? That's what you're trying to do. So that's why the function is named as small c. Okay, please don't get confused with as I said, right, it's a case sensitive. R is a case sensitive language, right? So make sure you're using a small c, right, a lowercase c and not a capital or an uppercase C here, right? Otherwise your query would fail. Okay, so first of all, I'm going to show you how do you create a simple vector, right? Who's storing that stores values of numeric, like basically storing numeric values between 1 to 5. Correct? So how you can do it is, how you can create this vector is, you have to first specify the name of the vector. Okay, let me first clean my environment, right? You can just press on this broom and clear it, and so I can clear my console. But yeah, you have to specify the name of the vector, right? Use the leftward assignment operator, and then the function C, the function combine, and then within parentheses all the values that you want to store in that vector. Okay, this is how you can create a vector, right? And this simple underscore vector that I have named, right, you can give any name to it, right? It has to be, it's a user defined value, so you can name it whatever you like. Just make sure it doesn't have any special characters except underscore. All right, so I've created a vector, I've run this, right, and it gives me this vector gets created, right, and starts showing up on my environment. Okay, how do I know whether this vector is actually it's storing this, like it's the object that I've created, is it a vector or not, right? Check if the object is a vector. Okay, you can do that by referring to this function called is.vector. Okay, is.vector. If you do is.vector, okay, is.vector, it will give you the, it will tell you whether this object is a vector or not, right? So when you do is.vector, it gives you a true, which means that the object that you've enclosed within parentheses is actually a vector object. It's not a different object. Okay, also depending on what values you store in a vector, the vector will automatically become either a numeric vector or a character vector or any other kind of a vector, right? So if you, because I've created a numeric vector, right, if I do a type of, or if I do a class of simple vector, if I do class of simple vector, okay, then it gives me numeric. I can also make use of another function called type of. Okay, type, so basically class gives you the primary data type, okay, of a object. Simple or and type of is another function which you could use, which gives you the sub classification of the primary data type. Okay, so this double that you see here, double is nothing but it's essentially a sub classification of the numeric vector, right? You can have an integer, you can have a double, you can have a float, right? If you have decimal values, right, if you're trying to store decimal values, you will generally store it in a numeric object, whose data type is double. Okay, so class will basically tell you the primary classification of the data, right, and type of will give you the sub classification of the data type. Okay, so the class tells you that it's a numeric vector, and then type of gives you double, which is also only possible for a numeric vector itself. Okay, okay, so this simple vector that I created, I can also output it, by the way, right? I could just do simple, okay, underscore vector, run this. Okay, just run this, and it gives me the output, right? It shows me that the values 1, 2, 3, 4, 5 is stored in the simple vector. All right, now the vector that I've created, right, it has 5 unique values in it, so 5 distinct values, but each of these values don't have any names assigned to them. Correct, they don't have any names assigned to them. Okay, what if I want to specify a particular dimension name, okay, for each of the values that are there in my object, data object? Okay, that's also something I could do. Okay, how do I do that is what I'm going to show you now. Let's say hypothetically I have a pack of 52 cards. Okay, 52 cards. Okay, I randomly draw 4 cards out of it. Okay, I randomly pick 4 cards out of it. Okay, let's say the first card, okay, I'll name that vector, okay, as random picks. Okay, this is how I would write it. Okay, let's say the first card that I drew, okay, first card, I'm going to name it as first card, right? I would first write the name, okay, of the dimension of that element and make it equal to, let's say, 10. If it is a 10, right? First card is a 10. Okay. Then I would call another, I'll create another one, which is called like the second card, the second draw. Okay, its value is, let's say, 8, right? Third card, let's say the value is 6, right? And then the fourth card, whose value is, let's say, 9. Okay. In this way, what you're doing is that you're not just creating a simple vector, right? A vector which has a few numeric values. Rather, you're creating a named vector. Each value in this vector also has a corresponding name designed to it, name designated to it. Okay. So when you run this, right, you create a named numeric vector, right, which has 4 unique values, right? And if you output it, right, it gives you that the first card is 10, the second card is 8, the third card is 6, and the fourth card is 9. So essentially ensuring that each value, okay, also has a header, also has a name associated with it. Okay, sometimes it might be important for you to do this because you might want to extract information out from a vector using its name. Okay, so that's where this named denotation might be useful. Okay, so there are different ways in which you can create a vector, right? Of course, you can create, this is one way to create a vector. If you want to have values between a series of numbers, let's say 10 to 20, you could just do num2 is C of 10 to 20, right? You can give unique names, as you can give unique values 10, 11, 12, 13, 14, 15, right? Anyway, you can create a vector, right? You can also create a character vector. Let's say if I want to store, where if I have, let's say, 3-4 different terms, right? Let's say the first term is A, second is B, third is C, then I have apple, then I have fifth is I love data science, right? Let's say if I have a bunch of values which I want to combine together to form a vector, okay, I could just do char underscore vector, right? Char underscore vector C, and then all the different names, all the different alphabets. All the alphabets have to be in double quotes, of course, right? You separate them with comma, right? And then the vector gets created, right? If I output it, this is how my vector looks like, right? The first value is A, the second value is B, the third value is C, fourth is apple, and the fifth one is I love data science. Okay, and then you can also check the class of it. When you do class, it gives you a character vector. Okay, so this is how you can create your own vector, right? Generally, generally you don't create vectors in data science, right? How you do is you import data directly, right? You import, let's say you have a file, you import it directly, and then that file gets like, from that file you can create vectors, you can create data frames, etc. Correct? So that's how you typically create vectors. You don't really do it like the way I'm showing you, but in case you wanted to, in case you had that choice, in case you had that use case, right, this is how you could do it. Okay. What are the different functions that you could use, right, to work with vectors? The first one, of course, is if you want to identify whether the object that you created is a vector or not, you could use is.vector. Okay, is.vector. Okay, let's say if I do is.vector of char underscore vector, okay, it gives me true. It means that my vector is actually, the object that I created is actually a vector. Then what I could do is I can also do a length, right? If I have a series of values, I want to find out what is the total number of values, total number of unique values present in that vector. I could just do a length of char underscore vector. It gives me the number of unique values in a vector. Okay, these are the two functions that you could explore, right, when you're working with vectors. The more important thing to work with, to do with vectors, is that if you want to extract values out, right, if you have created a vector and you want to extract certain piece of information out, how could you do that, right? That's a more important or a more interesting thing to do. This is how you do it, right? Let's say you created a vector called char underscore vector, right? And if you want to extract, let's say, the third element out from that vector, okay, or if you want to extract any element out of that vector, this is how you could do it, right? You can write the name of the vector, you can use square brackets, right? And within square brackets, you could mention the index of the value that you want to extract. Okay, index in the sense that the position at the value that you want to extract. If you want to extract the first element, you can write 1 within parentheses. If you want to extract the second element, you can write 2. If you want to extract third, fourth, fifth, etc., depending on what you want to extract, you can just write it there, right? Let's say if I want to extract the fourth value, okay, which is, or let's say fifth value, which is I love data science, this is how I could do it, right? Char vector square bracket 5 gives me I love data science. Okay, this is how you extract an element out from a vector, right? By putting the index, right, By the way, the index in R starts with 1. Okay, in Python, the index essentially starts from 0. Okay, and you also have negative indices in Python. But in R, the index will of a variable or of a vector will always start from 1. Okay, and you do not have any negative indexes. Okay, you will only have positive indices in R. What if you want to extract, let's say, a series of values, right? Let's say if you want to extract the first 3 values out. Okay, this is how you could do it, right? 1 to 3. Okay, var vector doesn't exist because I haven't created it. So char underscore vector 1 to 3, right? These are the 3 values, the first 3 values. Okay, so depending on what you want to extract, let's say if you want to extract randomly the first, third, and fifth value, okay, which is not a series, right? This is how you'll have to do it, right? So within a char vector, you'll have to use the function c, right? You'll have to write the indices, the positions of the values that you want to extract. Let's say you want to extract 1, you want to extract 3, and you want to extract 5. This is how you'll have to write it. And when you run this, the first value is the second value is, as in the third value is C, the third index is C, and the fifth index is I love data science. Okay. Okay. So that's about vector. There are a couple of other things that I want to tell you about vector, but before that, there's another very important thing that I want to show you, right? And it's important for all of you to know, and it's interesting as well, right? Is what, like, how do you import data in R, right? Importing data in R is also a fairly interesting and a useful exercise to do. Okay. What do I mean by importing data in R? I mean, let's say if you have a CSV file, if you have a flat file in R, okay, if you have a file in R, right? How do you import that in an R to create, let's say, a data frame or a data set, right? How do you do that? Okay. So there are 2-3 steps that you need to follow. The first step, of course, yeah, of X. When you do this, length of X is nothing but it's the total number of values that you have in the vector. Right? And when you enclose this within X, within parentheses, it will extract the last value automatically out. Okay, this is how you can extract the last index out, right? Length of X will tell you the total number of values in that vector, and that is the last index as well, right? The last position. So this is how you could do it. But yeah, how do you import data in R, right? There are a couple of steps that you need to follow. The first step, right, is, of course, you should have a flat file. You should have a CSV file. What I'm showing you here is how do you import a CSV file in R, a comma separated value file. Okay, I'm sure all of you have a comma separated value file in R. Sorry, not in R, but in your local machines, right? The first thing that you have to do, right, whenever you're trying to import data, is that you have to set a working directory, right? You have to set a working directory, and that working directory is nothing but it's the folder of the file that you want to import. Let's say customer.churn.csv is a file which is stored in my documents folder, right? Then my working directory should also be the documents folder, right? The folder from which I want to extract this file and import it, that should be my working directory. How do I set my working directory? This is how I do it. I go to session, right? Go to session, go to set working directory, okay? Go to choose directory, okay? And then search the location, right? Search the folder and basically choose the folder where this file is stored, okay? Where this file is stored. Let's say for me, the file is stored in a folder called documents. Within documents, let's say it's stored in the folder called personal documents. Okay, within that it's stored in data science documents. Here, let's say this is the folder in which I have this file called customerchurn.csv. Then I could just choose this folder and click open. Okay, what would happen is that R by default will basically refer to this folder to extract any file that you put to it, that you basically input to it, right? How do you set your working directory? I'm going to show it to you again. Just go to session, right? Session, go to set working directory, go to choose directory, and choose the folder in which the CSV file is stored, the CSV file that you want to import. Okay, and click on open, right? As soon as you click on open, the folder in which that file is open is present. That folder will become your working directory, which means now if you want to import the file, you could just run this function, right? You could just do customer underscore churn. Let's say that is the name that I want to give this file, or let's say if I want to call it raw data, okay, raw underscore data, whatever you want to call it, right? It's up to you. Use this function called read.csv. Read.csv is basically used for reading and importing comma separated value files in RStudio. Okay, so read.csv, and then within parentheses, the name of the file that you want to import. Okay, let's say the name of the file that I want to import is customer underscore churn.csv. Okay, when I run this code, what would happen is, okay, I should call it raw data, not raw date. When I run this, what happens is that there's an object called raw data that gets created, and it basically sits on my environment. Okay, and this raw data has 7,043 observations and 21 variables, right? And my file also has the same number of observations and same number of variables. Save this, right? Save as, save it in this folder, whatever folder, right? And then in file format, choose CSV file, CSV UTF-8. Okay, do this. In the file format, choose CSV UTF-8 comma delimited file and save it. Okay, this will automatically save the file as the CSV file, .csv file. Any file that you have open in Excel, you can save it as a CSV file. Okay, and then go to RStudio. Okay, first of all, set the working directory as the folder in which you have stored this file. Let's say the file that I stored is book under book1.csv, and it's in the dataset folder. So I could just do open, right? And then I could just do this, right? Raw underscore data 2, okay? And then read.csv is nothing but book1.csv. When I run this, a raw data 2 gets created for me, and these are the values that it has with it. Right? The set of values that I had created in my previous object, the same set of values. Sulabh, these files are in your LMS portal, right? The training support documents that you have on the LMS portal. One of those files is this customer churn.file. But in case you don't have it, that's okay, right? You can create your own CSV file by using Excel, right? Just go to Excel. I'm sure all of you will have Excel in your laptop. Just randomly populate a few rows of data and a few columns of data. Okay, save that file as a CSV file. Save as, okay, save as whatever name you want to give it, let's say test, right? And then make sure that the file format, right, this file format is CSV, right? And then save this. So this file will now be saved as a CSV file, and then you can directly import it in RStudio by using this function called read.csv. Okay, this is how you will do it. Okay, now I'm going to show you how to import a file into RStudio. Okay, I'm also zooming in a little bit so that all of you can see. Okay, I hope all of you can see my screen loud. So yeah, how do you import a CSV file? The first, right, whenever you're trying to import a file, right, the one thing that you should always do, it's a best practice, is that you should set your working directory. Okay, you should set your working directory. Now you might ask, what is a working directory? A working directory is essentially a folder, okay, in your local machine, in your laptop, okay, from where you are expecting to import most of the data that you would need for your project. Okay, let's say you're working on a project, right? You have 10 different files. You would mostly store those files in one folder, and you would import all of those files from that folder. Okay, so this working directory is essentially nothing but the location of that folder from which you are expecting to import most of your files. Okay, now you could also say that I have files across different folders. I cannot keep changing the working directory. That's a fair thing to do. I will also show you how do you work with that, right? That sort of a limitation. Okay, but before that, I think in most cases, majority of the files or majority of the data that you would need, right, in a project would be stored in one folder. So assuming that's the case, you would set your working directory as the folder where you are expecting to get data out from, data into RStudio from. Okay, so let's say, how do you set your working directory? Okay, what you do is you go to session here, go to set working directory. There's an option called set working directory. Within this option, go to choose directory. When you click on choose directory, okay, it will let you select one of the folders anywhere in your machine. Okay, anywhere in your local machine. Okay, you can set a folder as your working directory. Let's say in my documents, okay, I have a folder called, let's say XYZ, right? Let's say H20 whatever, right? Let's say WebEx. Okay, is a folder where I'm expecting most of my data to be there. So I could just click on this folder called WebEx and click on open. Okay, when I click on open, what would happen is this folder will become my working directory, and then whenever I ask R to import a file from my laptop, just by referring to the name of that file, it will automatically go to this WebEx folder and try to find that file in the WebEx folder. Okay, so that's the purpose of the working directory. Okay, I don't want to set this WebEx as my working directory, so I'll click on cancel here. But what you guys should do is locate the folder from where you want to import this customer_churn.csv file or any other CSV file that you have. Okay, and set that folder as your working directory. Okay, click on open if you want to set it as the working directory. Okay.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The next step that you'll do is this, right? So you would just name, you'll create a name, right, for the data set that you want to import. Okay, let's say I want to import this file called customer_churn.csv, but I want to name it as customer_churn. Like this is user defined, right? So you have the option to select whatever, to choose whatever name you want to give to this file. Okay, you can call it data set. Okay, you could call it my first import, whatever you want to call it, right? Up to you. Okay, it's a user defined thing. Make sure it doesn't have any special characters. That's all. So let's say I'm calling this my first import. Okay, the assignment operator. Then the function that you would use to import a CSV file is read.csv, and then within parenthesis, okay, write the name of the file that you want to import. Okay, the name of the file that you want to import. Okay, along with the extension. So customer_churn.csv in either single quotes or in double quotes. Okay, when you do this, when you run this, okay, I have run it, so it starts showing up in my console. Also, you see that there's an object called my first import that gets created in my environment. Okay, so this is how you would import a file in RStudio. Okay, that's the easiest way to import a file. Now, the second thing that you could do, right? Let's say you do not want to set a working directory. Okay, you don't want to do that. Okay, rather what you want to do is you want to provide the entire path of the file, okay, from where you want to import the data, right? And it's possible, right? Let's say you have 5 different data sets, right? And all of them are in different folders. So instead of, let's say, putting one folder as your working directory, right? What you could do is in each of those files, right, while mentioning the name of the file in your read.csv command, you can also give the entire path location, right, the file location, and that's what our friend here Souvik has done, right? So this is a command that Souvik has written, which is y is the name of the object that he's creating. Okay, read.csv, and within parenthesis, within double quotes, okay, this is the location of the file, right? So along with the path of the file, which is Intellipaat D drive, Intellipaat R program, and then within R program, I think this is the folder R program where his file is stored, and then the name of the file. Okay, this is also something you could do, right? If you do this, you do not really even need to mention your working directory. You do not really need to have the working directory same as the folder where the file is stored. It could be anywhere, right? So yeah, these are the two ways in which you can import your file. Once you've imported the file, right, how do you go about processing your file, right? I'll quickly do that, right? But this file that you've imported, because it's a large file, it has multiple rows and multiple columns, right? It gets imported as a data frame. Okay, so first of all, how do you go about viewing this file? Okay, what you could do is you could just use a function called view. Okay, and within view, write the name of the file, right? The name of the object that you've imported, right? My first import is the object. I could just do view of my first import. This view starts with capital V. Okay, click on it and it will start showing you, displaying you the content of this file. Okay, it will start displaying you the content of this file. your file has 7,043 observations, right? Which means 7,043 rows, okay, and 21 variables. Okay, there are 21 different columns in this file, okay, and 7,043 different observations in this file, 7,043 different rows in this file. Okay, I will briefly take you through the content in this file, and it's also important for you to know about this, right? Because we are going to use this data set several times, okay, for building different kinds of machine learning models. Okay, so it's important that we know what does this file essentially contain, right? What does this data set essentially contain? So I'll click, or you can also, by the way, to view your data, you can also click on this object on the environment. Click on this object, right, and it will activate the view command itself. Okay, let's say if I want to open this customer underscore churn, I could just click on it. As soon as I click on it, it opens up on my script window, my source window. Okay, so let me give you a brief overview of what this data set is all about, right? And then when we will explore this further after we've looked at a couple of other objects, right? Matrix, data frames, and vectors. But this object that you see, right, this data set that you see is essentially a data set which contains information, okay, information around about, okay, 7,043 customers to be precise, of a telecom provider. Okay, there's a telecom provider whose customer base, let's say, assume that their customer base consists of 7,043 customers, which means some of those customers have already left the telecom provider and they've moved on to, let's say, other providers. Okay, some of them are still part of their customer base, right? And we have information around the customers demographics, in the sense that what is the gender of the customer, whether the customer is a senior citizen, whether the customer is has dependents, etc., right? And then we also have information about the kind of services that they're using, the kind of transactions that they do, right? All of that we have this in this data, right? The objective finally for us, right, while we use this data, would be to build a prediction model, right? Build a prediction model using machine learning that can help us predict, right, who are the customers that are likely to churn in the future, right? Who are the customers, right? What are the attributes of customers that have high likelihood to churn, right? We are going to build a churn prediction model, right, using various algorithms, various techniques, right, using this data set as our reference data set. Okay, so I will take you through what are the different kinds of information that you have in this data set, right? You have this column called customer ID. Okay, the first column is customer ID. Customer ID is nothing but it's a unique identifier for each customer in this data set, right? So this each row of your data corresponds to one customer, right? And their customer ID is this. Okay, let's say first customer, their customer ID is 7590 VHVG, right? That's a unique identifier of a particular customer, right? For example, if I am a customer, right, let's say I'm an Airtel customer, I will have a unique customer ID for myself, right, which will not be repeated across any other customer that Airtel has. Okay, just as an example. Then you have gender of the customer. Okay, then you have this information which says whether the customer is a senior citizen or not. Okay, wherever you see a 0, it means that the customer is not a senior citizen. Whenever you see a 1, it means that the customer is a senior citizen. Okay, then you have a field called partner. It tells you whether the customer has any partners or not, right? Whether the customer has any significant others or not. Okay, whether the customer has any dependents or not, right? Well, it basically is an indication of the customer's household size, right? The number of people that live with him or her. Okay, then you have tenure of the customer, right? Now we are talking more about the history or the relationship of the customer, right, with this organization, with this telecom provider, right? So you have the tenure, okay, and this tenure is in months, right? So if this value is 1, it means that the customer has been part of this telecom provider's customer base, right? This has been using the services of this telecom provider for 1 month. Okay, for exactly 1 month. Okay, 34 would mean that this customer has been part of this telecom provider, right, services for last 34 months. Okay, 2 months, 45 months, etc., right? So this is all in months. Then you have information around the kind of services that this customer is using, right? Whether someone is using the phone service or not. No would mean that the person is not using their phone service. Yes means that they are using a phone service, right? If they're using a phone service, do they have multiple lines or just one line? Okay, no would mean no phone service, of course, means that the customer doesn't even have phone service. So there's no point of this variable for them, right? There's like they will not have multiple lines, of course, because they don't even have phone service. Okay, yes would mean that, and this is only for people who have a phone service. Yes means that these guys also have multiple lines of services. Okay, they have multiple lines basically. They're just not using one line. They're the multiple lines. Then you have information around the kind of internet service that they're using. Okay, so there are three different types of internet services. There's DSL, okay, which is a mid-priced internet service. There's fiber optic, okay, which is a superior service, right? Probably a high-speed internet service. And then you also have something called no, which means that the customer is not using any internet service from this telecom provider. Okay, so there are three types of customers: people who use DSL, people who use fiber optic, people who do not use internet at all. Okay, then you have other services like whether they're opted for online security, online backup, device protection, tech support, streaming movies, streaming TV, etc. Right? So basically telling you the kind of services that the customer is using. Okay. Then that's a little bit about the way the customer does transactions, right? For the services that they're using. So first of all, what is the contract type, right? Which means if it's a month-to-month contract, it means the customer has to renew his services every month, his or her services every month, right? So they either have a postpaid or a prepaid service, but they're renewing it every month. It expires every month. If someone has a 1-year contract, it means that they've paid for the services 1 year in advance, right? And they do not have to make any payment within that 1 year. Okay, then there could be 2 year, there could be 3 year as well. Okay, you have whether the customer has enrolled for paperless billing or not, the payment method of the customer, right? Then you have a very important attribute which is called the monthly charges, right? What is the monthly charge of a customer, right? What is the average charge that the customer is paying for the services that they're using? Okay, this is in dollars, $29.85 or $56.95, etc. Okay, the average monthly charges, right? What is the average charge that the customer pays at a monthly level? Their total charges, which means their accumulated charges over their whole tenure. What is the total charges? The total cost that the customer has paid throughout their entire tenure. That's what total charges is, right? And then finally you have this last variable which is called churn. Okay, churn basically means whether the customer has churned already, whether the customer has moved out already, okay, or the customer is still part of this telecom provider's customer base, right? Which means the customer is still using the telecom provider's services. Okay, you have a few customers who have wherever you see a no, it means that the customer is still retained. The customer is still using their services. Wherever you see a yes, it means that the customer has already churned. Okay, why do we need both churned as well as not churned customers? We need both kinds of customers in our database so that our machine learning model, right, can identify properties that differentiate between churned customers and non-churned customers, right? What are the characteristics of someone who's churned, who has already churned, right? And it can build a model that can use those properties, that can use those characteristics to identify customers who are likely to churn in future, right? And then of course you also want customers who have not churned, right, to find out how are these properties different from people who do not churn, right? People who have good likelihood to retain. Okay, so that's this file, that's this data set all about. We will use this data extensively, right, in all our in most of our problem statements, right? And we will also build a machine learning model, right, in at some point, right, once we have explored this data enough, right, we will build a machine learning model that can help us predict churn versus not churn. Okay, so that's the entire purpose of why I've spent some time explaining you about this data set. So I'm going to first of all create a vector called random underscore vec. Okay, random underscore vec. Okay, using this function called c, right, and then within parenthesis all the values that I want to store in the vector. Okay, whenever I want to impute missing values in a vector, I would use an NA. Right, this NA is basically a keyword, okay, which essentially imputes a missing value, right, a blank value in your object. Okay, so if you look at random underscore vec, right, if I just export it, right, if I output it, you would see that there are a few NAs, right? One, like the first position is NA, fifth position is NA, and the sixth position is NA, but other values are present. Okay, let's say what I intend to do, okay, is that I want to ensure that I convert all the missing values in this vector to 0. Okay, I want to replace all my missing values to zeros, right? That's an operation that I want to do, and you can decide, right? You can replace your missing values with anything, right? You can replace it with a constant value, you can replace it with the mean of all the values, whatever you decide to do, it's up to you. But in this case, I'm going to say that I want to impute my missing values with a constant value which is 0. Okay, that's what I want to do. How can I do that? Okay, there's a function in R, okay, which lets you identify missing values in your data object. That function is called is.na. Is.na is a function which will identify the positions in a vector, right, that have a missing value. Okay, so if I run is.na and within parenthesis random underscore vec, right, and run this, it will basically output true and false, right, as different values corresponding to different elements that I have in my vector. Wherever I see a true, it means that value is a missing value. Wherever I see a false, it means that value is not a missing value, rather it's a valid value. Okay, so you, for every element in my vector, right, because I have 6 different elements, na, 6, 7, 8, na and na, I also have 6 different outputs here, right? The first output is true, which means that the first element of my vector is a missing value, is an na value. The second element 6 is not a missing value, of course. The third value is also not a missing value, so it's a false here. The fourth value 8 is also not a missing value, so false again. The last 2 values are again na and na, hence you see a true and true here. Okay, so this is a way in which you can identify your missing value, right? Using is.na, you can identify which values in your vector are missing, and then you can decide to impute them, to replace them with a different value, right? How do you do that? You can do that by using a function called if else. Okay, there's a if else function which you can use in a vector. Okay, and within if else you can put a condition, right? And based on that condition you can impute values, right? You can replace values with any other value, any other constant value that you feel would be a right replacement of the missing value. Okay, and in this case what I want to do, I want to replace all my missing values with a 0. Okay, that's exactly what I want to do. So first of all, what is the syntax of if else? This is the syntax of if else, right? So you write if else, okay, the name of the function, within parenthesis, right, within the first argument that you'll have to give on your in the if else condition is the condition that you want to check, right? Is the condition what you want to check. For example, I want to check in this case whether my vector, whether the first element in my vector is a missing value or not. Okay, or let's say whether whatever value I input to this function, whether that value is a missing value or not, right? Okay, that's the condition that I want to check. Let's say I want to check if it's a missing value, right? Then separated by comma, the value that you want to input, okay, or let's say the value that you want to output, okay, if the condition is true, that's the second argument. Okay, that's the second thing that you put here. And then if the value is not, if the condition is not holding true, right, for certain values the condition will be false. Wherever it is false, I want to, what is the value that you want to put if your condition is false? That is the syntax of this if else statement. Okay, the first argument is the condition, the expression that you want to check, right, whether it's correct or not. If the expression is holding true, if your data meets the condition that you specified, then what is the value that you want to return? Okay, if your expression is false, okay, if your data is not holding true for the expression that you've given, then what is the value that you want to put next is the next argument. Okay, so first is condition, the second is argument, is the value corresponding to true, okay, corresponding to your condition being true, and the third argument is value corresponding to your condition being false. Okay, so how would I use this if else statement, right, in this context of na, is that I would say if else, okay, is dot na of my random vec, right, which means wherever this condition holds true, right, wherever this is true, wherever my random vector is a missing value, okay, whichever value of my random vector is a missing value, okay, whenever it is true, right, replace it with 0. Okay, if this condition is holding true, then replace it with 0. If this condition is not holding true, then retain the original value of random underscore vec. That's how I'm using my if else statement, right? So my condition is is dot na of random vec, which means I'm checking whether each element, I'm checking this at an element level, right? So first, for the first element, whether if that element is a missing value, right, then it means then the output of this statement will be a true, right? It will be true, right? That yes, this object, this value is a missing value, right? If it is true, then replace it with 0. Okay. If it is not true, then retain whatever was the value that he was present in it. Correct. So when I run this, what happens is, as an output, right, you'd see that wherever there was an NA in my random vector, random underscore vec, that NA has been replaced with a 0, right? Wherever it was not an NA, wherever I did not have a missing value, the original value of my vector has been retained, right? So 6, 7, 8, which were non-missing values, right? I see a 6, 7, and 8 there, but wherever I had an NA, that NA gets imputed with a 0. Okay, so this is how you can identify missing values in your vector, and then you can impute them with a 0. That's how you would impute missing values, right? That's how you would replace missing values with, let's say, a 0 or any other valid constant that you want to replace it with. That's how you impute missing values. We will talk about matrix now, right? Matrix, as you guys know, is a two-dimensional object, right? Which means it will have rows and columns, right? And you have to make sure that a matrix that we're creating, okay, essentially has homogeneous values, right? Values which all have the same data type. Okay. So how do you create a matrix? You use the function called matrix, right? And then within that, put a set of values. Let's say I want to put a vector. I want to convert a vector into a matrix. This is how I could do it. I use the function called matrix, right? Within that matrix, I input, let's say, values between 1 to 10. Okay. And then this is the first argument that I need to provide, right? Which is the data that needs to go into my matrix. Okay. The second argument that I need to provide to my function matrix is either the number of rows, okay, or the number of columns that I want to create in my matrix, right? Why is it an OR condition and not an AND condition? Because if R already knows that it wants to input 10 values, right, into my matrix, right, then if you provide the number of columns as 2, it will be automatically able to guess, right, that the number of columns, so the number of rows that you would have to create to input 10 values into a matrix with 2 columns will be equal to 5, right? Because 2 into 5 is going to give you 10. Okay, so you could either put number of columns or number of rows. Both of them work. So this is how you create a matrix, mat1. Okay, mat1, if I have to output it, okay, this is how it looks like. You see there are 5 rows, okay, and the values 1 to 10 are stored in this. Okay, that's how you create a matrix. You can also do it in this manner, right? You could say mat1, okay, matrix. Instead of putting the number of row but number of columns, you could just do n row is equal to true. So what this would do is, because you put the number of rows is equal to true 2, it will automatically create how many columns? It will create 5 columns, right? So you have to put either the number of rows or the number of columns as an input to your matrix command. Okay, let me run this and show you. Okay, and then again, if I output mat1, after running this command, right, where I've said n row is equal to true, if I output my matrix, it looks like this, right? So you have the same set of values 1 to 10, but in this case, because I've said n row is equal to 2, then the number of columns has changed from 2 to 5, right? So you have 5 columns and 2 rows now in your matrix. Okay, so this is how you create a matrix. Okay, this is how you create a matrix. Okay, and you should also realize, right, I'll probably go back to the same example, which is where we have put n call is equal to 2, right? And this is my mat_1. You would also realize that by default, right, when we input data into a matrix, right, it will fill up the matrix, right, in the order of columns, right? So it will first input the data in the first column, right? Once the entire column is filled, that's when it will go to the second column and start filling it, right? So the order in which the data gets induced into a matrix is essentially in a columnar manner, right? So first fill up the first column, then go up and then fill the from the first row itself, start filling up the second column. That's the default way in which you have to in which data will get inserted into a matrix, right? But if you want, you can change this manner. You can change the default order of insertion of data into a matrix, right? So you could say the default insertion of data is columnar, right? So the data first gets into first column, then the second column, and then the third column, etc. But let's say if I want to change it to a different order, right? So first the first row should get filled, then the second row, then the third row. If that is what I want to sort of change my order of filling data into a matrix, I could just include an additional argument here which says by row is equal to true. Okay, when I put by row is equal to true, right, and I create another matrix called mat2. Okay, mat2, the only thing that I'm changing here, right, as compared to the previous command that I did, is that I'm putting an additional argument here which says by row is equal to true. Okay, when I run this, mat2 gets created, right, and this is how my mat2 looks like. This is how my mat2 looks like, and you realize that the order in which the data has been inserted into this matrix is not columnar, rather it's row wise, right? So first the data has been inputted into the first row, then the second row, then the third row, then the fourth row, and then the fifth. This is how the data has been inserted, right? But the first example that we saw, the data got inserted into the matrix like this, correct?
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It first filled the columns, the first column, and then filled the second column. In this way, it first filled the first row, then the second row, then third row, then the fourth row. So by default, if you do not include by row is equal to true, which is by default, the data will get into the matrix in a columnar manner. But if you include by row is equal to true, the order in which the data gets inserted will change to a columnar manner. Okay. So to create a matrix, right, you have to just insert a set of data, right, a set of numbers, a set of characters, whatever, right, into as the data, right, and you have to specify the number of columns or the number of rows that you want to input into the matrix, and by default, and of course, it will intuitively guess the number of columns, right, that it needs to create. Okay, so now there are also several operations that we can do into a matrix. Okay, there are different kinds of operations that we can do into a matrix. We can essentially add matrix, right? So let's say if I want to add matrix 1 and matrix 2, I can only do operations across two different matrices if they have the same dimensions. Okay, what do I mean by same dimensions? I mean that the number of rows and the number of columns that the two matrices that I want to do operations, let's say arithmetic operation on, it should be equal. Okay, so this matrix, it's a 5x2 matrix because you have 5 rows and 2 columns, right? So if you want to add another matrix to this, right, then the other matrix that you're trying to add to it should also have the same dimension, which is 5x2. Okay, so this, my m1 and m2, my matrix 1 and matrix 2, they're both of the same dimensions, right? They have 5 rows and they have 2 columns, right? So what I can do is I can add them if I like to. Okay, so to add matrix, you can just do mat1 plus mat2. Okay, mat1 and mat2. And how would the addition happen? The addition basically happens on the same indices, on the same positions, right? Which means the first value of matrix 1, which means the value corresponding to the first row and the first column, will be added to the value corresponding to the first row and the first column of the second matrix, right? And that's what's happening, right? So 1 plus 1 is 2. Okay, 6, which is the first row and second column, okay, of the first matrix, gets added to 2, which is the first row and second column of matrix 2, and as an output you get 8. Okay, so the same indices, right, the same positions get added to each other. This will get added to this will get added to this will get added to this, right, and this will get added to this, to give you an output which is 20, right? The addition of 9 plus 5, which is fifth row and first column of mat1 and mat2, is 14. Right, the same format of arithmetic operation will also hold true with any other operation that you try to do, right? If you want to do multiplication, if you want to do subtraction, if you want to do division, etc., it will basically happen on the same indices. Okay, it will happen on the same positions, right, of the two matrix that you're trying to join. Okay, so this is how you create a matrix. You can also create a matrix which is, let's say, a character matrix, right? Let's say if I have a bunch of characters A, B, C, D, E, G, F, T, D, whatever, right, and I want to include this into a matrix, I could just do this, right, and it gets created, right? Instead of numerics, I have characters now. Okay, but I cannot do any arithmetic operation on this, right? If I want to add another character matrix to this, I cannot do that, right? Because additions between matrices, between characters is not possible. Okay, how do you know whether it's a character matrix or a numeric matrix or not? You can use this function called type of. It tells you the data type of the matrix. Okay, so when I run this type of matrix, it tells me that it's a character matrix. Okay, instead if I'd said type of mat1, which is a matrix, which is a numeric matrix, right, then I'll get a double or a numeric. Okay, so if you want to find out what is the data type of a matrix, you could just do a type of. Now what's important for us to understand, right, is, let's say if you have I mean, generally how would you work, right? You would essentially import a data set into R, right, store that as a matrix, and then you will do multiple operations on it, right? It's very seldomly you will create a matrix using this matrix function, right? But it's just for you to know, if you had that use case of creating a matrix, how would you do that, right, using the matrix function. So now what we would study, what we would discuss is, let's say if you have a matrix, if you have a large matrix, how would you extract information out of it? How do you subset it, right? How do you, let's say, anything that you want to do, right, extending that matrix, how do you do that? Okay, so first of all, I'm going to create a very big matrix called mat_big, right, which has values from 1 to 100. Okay, 100 different numbers, right, and it has 10 rows. Okay, if I try to input 100 values to 10 rows, what is the number of rows and number of columns that my matrix is going to have? It's going to be 10, right? So 10 cross 10 is going to be the dimension. So yeah, I do that. Okay, this is my mat big. Okay, it has 10 rows and 10 columns. Because I did not input by row is equal to true, right, the order in which the data got inserted is columnar, right? So this is how the data got inserted into my matrix, right? Basically the first column has values from 1 to 10, second column from 11 to 20, 21 to 30, etc., right? This is how the data has been inputted. Okay, if you want the exact opposite of this, right, then you could just do by row is equal to true, right? So it will basically do a transformation of this matrix. If I want to extract values out of this matrix, right, how do I do that? Many a times you would be required to extract values out, extract information out, right? It could be one number, it could be a set of values out. How do you do that? You could do that by referring to the row index and the column index of the matrix. Okay, what is the row? By the way, what do I mean by the row index and the row column index? It's nothing but the position of the matrix, right? Let's say this value, right, which is 1, the row index of this matrix is 1 because it's the first row, and the column index of this matrix is also 1 because it's the first column. Correct? This value 64 that you see here, right, is basically its position on its index. Its row index is 4 because it's part of the fourth row. Its column index is 7, right? So its index is it's going to be nothing but 6, 7. This is the position of this number, right? So using the row index and the column index of the matrix, right, of values, if you want, we can extract them out. Okay, let's say I want to extract the value corresponding to the second row and the fifth column. This is how I could do it, right? So whenever, by the way, I think people also get confused with parentheses, brackets a lot as well. You would use these parentheses, right? You would use these parentheses like the normal brackets when you want to enclose something in a function, right? Whenever you want to write a function, right? The function, the inputs, the arguments of the functions will usually be enclosed within this. So it's essentially used to enclose different arguments of a function. Okay, square brackets are typically used to extract values out, extract information out from an object can be done by using the square brackets. Okay, so let's say from mat_big, if I want to extract the value which is in the second row and the fifth column, this is how I could do it. I could just do mat_big 2,5. It will extract this value out from me, right? This value 2,5 is nothing but this value, right? 42, second row and fifth column. Okay, so this is how you can extract value just referring to the row index and the column index of it, right? Sometimes we might be required, let's say I want to subset my matrix, right, to only the first 5 rows. Let's say that's what I want. Okay, I want to extract the first 5 rows of my matrix. How can I do that? Which means I want to extract the first 5 rows, but I want to extract all the columns of my matrix. Okay, what I could do is I could just do this, right? mat_big, okay, square brackets. In the row index, I know that I want to extract the first 5 rows, correct? So I could do, 1:5, comma, if I want to retain all the columns, right? I don't want to do subsetting on the columns, right? I only want to do subsetting on the rows. So if I want to retain all the columns, I could just leave the column index blank. So if I do 1:5, comma, nothing, it means I want to extract all the columns out, but only for the first 5 rows, right? Wherever the row index is between 1 to 5, all the columns will get extracted from this. Okay, so this is to extract all columns for rows 1 to 5. Okay, when I run this, you'd see all 10 columns get extracted, but the subsetting has happened on rows, right? So I get the first 5 rows, and within the first 5 rows I get the first 5 columns, as in all the columns. Okay, if I want to subset further, right, let's say if I want to subset only the first 5 rows and the first 5 columns, okay, the first 5 rows and the first 5 columns, okay, extract first 5 1:5 columns and 1:5 rows. Okay, this is how I could do it. I could just do 1:5, comma 1:5. This will extract this much data for me, right? The first 5 rows and first 5 columns. Okay, so let's try and run this and see if it happens. It does happen, right? So I see the first 5 rows and the first 5 columns get extracted for me from a matrix. Okay, by the way, like unless you assign it to something, unless you assign it back to the same matrix, these subsetting that you're doing, right, it will not have any impact on your original object, right? The mat_big object that you have, it will continue to have the same number of rows and the same number of columns, unless you decide to do something of this sort, right? If you do this, right, mat_big assigned to this, right? If you do this, what would happen is that as a result of this operation, you would extract the first 5 rows and first 5 columns, and then you will assign it back to the same object, okay, which would overwrite your existing object, right? It will change your existing object and it will reduce that object to only a matrix of 5:5. All right, and let me show you that. Okay, of course I'll have to go back and create the matrix again, but let's say if that's what I want, if I want to update my existing matrix, right, with a new matrix with a subset of the same matrix, this is how I could do it. I could just do mat_big, right, of mat_big 1:5:1:5, and when I run mat_big now, it's a matrix with just 5 rows and 5 columns, correct? But I'm going to go back and create it again. So now my mat_big is still has 10 rows and 10 columns. Okay, when you do this, right, when you do not assign it to this, right, it will basically output you first 5 rows and first 5 columns, but your original object will not get subset, right? Your original object will still have 10 rows and 10 columns. Okay, so it's very important. If you want to update a matrix, you assign it back to the same object, or let's say if you want to create a new matrix out of it, you assign it to that new object. Okay, so yeah, that's how you extract values, right? Let's say if I want to extract first 5 rows and column 2 and 3, right? This is how I can do it. Okay, sometimes you might want to extract, let's say you might want to extract random rows, right? Let's say you want to extract first row, 10th row, and say 7th row, right? And let's say first column, 5th column, and 8th column. Okay, you might have that kind of a use case, right, where you want to extract random rows and random columns. This is how you'll have to do it, right? So the row index and the column index both, because it's a random order, you'll have to assign it in a C, right, in a combination function. So you'd say 1, 3, 5. This will extract first row, third row, and 5th row, and then within columns as well. Let's say if I want the second column, 5th column, and 10th column, then run this, right, and it will extract. It cannot extract this because the same, like those values don't exist in your data frame. But this is what I can do though. So let's say first row, third row, and 5th row. Okay, and let's say it can, but I use the syntax wrong. So yeah, let's say this is what I wanted, right? Instead of comma, I put something else. I had put a if I had put a colon, right, which is incorrect. So this is how you do it, right? It should be able to extract it. Yeah, this is how you'll do it. Okay, if you want to extract random rows and random columns. So whenever you want to extract the whole column, right, leave that column index blank. Okay, let's say if you want to extract first row, but you want to extract all the columns of it, you will leave the column index blank. The same thing applies for the row index as well, right? Let's say you want to extract all the rows, but only of the first 2 columns, right? Then this is how you'll have to write it, right? So extract all rows of first and second column. Got it? So this is how your extraction work, right? You can make use of the indexes, right, the positions of the values, to extract them out from a matrix. Let's say Nakwa, if I want to create a matrix, right? If I want to, I'll clear my console as well, right? So let's say this is my object, right? Mat underscore big, matrix 1 is 200. Okay, and row is equal to 10. What happens here is that the matrix that gets created, right, will by default be ordered in this manner, right? So the first column, right, the first 10 values will be inserted in the first column, right? The first row, second row, third row, fourth row, fifth row, etc. Right? Then it will go to the second column and input the values in this order, right? The second column will get filled second, then the third column, then the fourth column, then the fifth column, and this way. This is how your data will get ordered into a matrix, right? If you do not input by row is equal to true, right? So by default, the insertion of data into your matrix will happen in a columnar manner, right? So the first column gets filled first, then the second column, then the third column, then the fourth column. Okay, if you want to change this order of execution, right, which means if you want to, let's say, enter the data, okay, in a way that it first fills up the rows. Okay, it first fills up the first row, right? Which means instead of having 1, 11, 21, 31, 41, etc. in the first row, you want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first 10 values of your data to be in the first row, the second set of 10 values in the second row, third row, etc. Then you could just mention by row is equal to true. When you do by row is equal to true, the order in which the data gets inserted, I'm going to show it to you. Okay, mat big. Now the mat underscore big that I've created has by row is equal to true, right? And when I run this, you'd see that the data now has been inserted in this manner, right? So the first row has the first 10 values. The second row then has the second set of 10 values. The third row has the third set of 10 values, etc. Right? So this is how the insertion of your data, the ordering of it has changed. Right? By default, the data gets entered in the columnar manner, right? But if you want to change it, you can use by row is equal to true. Okay, there's another important thing which you should know about, right? Is that how do you extend a matrix, right? Let's say if you've created a matrix, right, which has 10 rows and 10 columns. how do you add, let's say, more rows and more columns to that matrix, right? Of course, that could be a valid use case, right? You want to add another column, or let's say if you want to add another row to your matrix, how do you do that? Very easy to do that. I'm going to show it to you right now. There are two functions in R, right, which will help you, which will let you extend your matrices, right, either vertically or horizontally. Okay, when I say improving, or let's say increasing the size of a matrix horizontally, okay, it means you're adding more columns, you're increasing the width of your matrix, right? Okay, if you want to increase the number of rows in your matrix, which means if you want to increase the vertical height of your matrix, right, then how do you do that? Okay, there are two functions called cbind and rbind. I'm going to show you how do you work with both of these. Okay, okay, let's say if I have this matrix called mat big, okay, mat underscore big, which has data, right, first 100 values, okay, in 10 rows and 10 columns. If I want to add another column to it, right, let's say I want to add values from 101 to 110 to the 11th column, I could just make use of a function called cbind. Okay, cbind, which basically binds another column to your matrix, right? I could just do cbind mat underscore big, which is the existing object, the object to which I want to bind more information. Okay.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
And I could do something of this sort. I could just do 1:1 is to 110 is what I want to add to my matrix. Okay, so when I run this, what would happen is the new output that I would get will have another column added to it, right? So this 11th column that gets added is nothing but these values 101 to 110 that I have added to the existing matrix through cbind. Okay, through cbind. This is how you can add more columns to your existing matrix. This is how you will extend your matrix in a columnar manner. Okay, cbind is the function that you would use. Now, what we've done here is that we've created a new matrix. Like we've just shown this in the output. Unless you assign it back to the same object, right, mat underscore big, this will not have any change in your existing object, right? So if you want to change your mat underscore big and you want to add the 11th column, then you will have to assign it back to mat underscore big, right? Only then the original object will get updated, right? So if you see the mat underscore big that I have currently, right, it is still a matrix of 10:10, right? So this is the number of rows and this is the number of columns. Okay, it's a 10 cross 10 matrix, and I can confirm that for you. Okay, if I just do dimensions, I think dim is a function. Dimensions is a function. Let's try. So if I do dim of mat underscore big, which is, it gives me the dimensions of my matrix, 10:10, it's what it is, because I haven't yet executed this, right? I haven't assigned this back to the same object. Okay, but when I do this, let's say if I assign it back, right, to mat underscore big, the dimension of my matrix would change now, right? Now I have 11 columns, right, and 10 rows, so it becomes a 10:11 matrix. Okay, so whenever you want to bind a data, say bind additional columns to your existing object, and you want to impact your original object, right, you want to update your original object, then you'll have to assign it back to the same object. That's one of the things that you should remember. Okay, the same way you can also add another row to your object. Okay, let's say if you want to add another row, okay, you can make use of this function called rbind. Okay, rbind. Okay, and you could just insert values, let's say between, I want to insert values, let's say between 120 to 130. Okay, I'll have to insert 11 values now because there are 11 columns in this data. You know, there are 10 rows and 11 columns. So if I want to add another row to it, I will have to insert 11 different values into it. Correct? So 120 to 130 is basically 11 values, 120, 121, 22, 30, etc. So 11 different values. Okay, and when I run this, now I have 11 rows. I have this new row added to my existing matrix, and then I have an 11th column as well. Okay. Now, because I haven't assigned this back to my original object, right, which is mat_big, this has not impacted my original object yet. Okay. So my original object, right, which is mat_big, still is an object of dimension 10:11, right? But if I assign it back to mat_big, right, if I do this here, right, then you would see that the dimension of my object would change. Right? It will become 11 cross 11 now. Got it? So whenever you want to update your existing object, right, you should assign it back to the same object, right? And then of course, if you want to add more columns, you can use cbind, and if you want to add more rows, you can do a rbind. Okay, this is how you extend your existing matrix. Okay, you can also do multiple operations on a matrix, right? Let's say if you want to do a mean, median, mode, all of that you can do. You can do a mean. Okay, if I want to get the mean of the entire matrix, this is how I can do it. I could do. Okay, so this tells me that the mean of all the values which are there in my matrix is 61.81. Okay, if I want to, let's say, do the max, if I want to get the max value out, okay, this is how I can run this max. I can also do this on a custom row or a custom column, right, or a group of, let's say, on a subsetted matrix, right? Let's say I want to do this only on the first 5 rows, okay, and the first 5 columns. Then this is how I would do it, right? I would subset the matrix first using the row indexes and the column indexes, and then I would do the max of this. So the max of the first 5 rows and the first 5 columns is 45. Okay, so you can of course subset your data using the row index and column index, right? And then apply any operation, any mathematical operation that you want to do it. Okay, so this is how you work with matrix, right? What we've seen so far is how do you create a matrix using the matrix function. How do you extract values out from a matrix, right? If you want to, right, using the row index and the column index. How do you extend your matrix, right, by using cbind and rbind? How do you essentially let's say do arithmetic operations on your matrix? And then if you want to add or subtract matrices, right, from each other, then you can also do that, but you have to make sure that the dimensions of the two matrices that on which you want to do the operation, on which you want to do any arithmetic operation, they're all of the same size, right? They have the same dimensions. That's one of the things to remember. Okay, so that's about matrix. So we're going to now start exploring about data frames. So yeah, talking about data frames is of course an object which lets you store data in the form of observations and variables. Okay, yeah, each row of your data in a data frame corresponds to one observation, and each column in your data frame corresponds to one variable. Okay, one attribute, one variable of your data set, right? And that's how this data set is also stored, right? One observation, right, is this, right? This one customer is your one observation, right? And for this customer, this column is an attribute, right? So for this customer, for example, we know that she's a female. That's her attribute, right? She isn't a senior citizen. That's her attribute. Okay. So data frame is that object that lets you work with data sets, right? When you use the read.csv command, okay, when you use the read.csv command, it lets you import data as a data frame. Okay, so this customer_churn object that we created, okay, earlier today, it's essentially a data frame that we imported. Okay, and you can check that, okay, by just doing this, right? Just use a function called str, okay, str, and within parentheses just mention the name of the object that you created, right, which is customer_churn in this case. If I do str of customer_churn, okay, str is basically nothing but a short form of structure. It basically tells me, this command tells me that this is a data. First of all, it tells me that it's a data frame. Okay, the object that you created as data frame. It has 7,043 observations. Okay, 7,043 rows and 21 variables, and these are all the variables which are present in my data frame. Okay, and it also tells you the data type of each of the variables, right? So customer ID is character, gender is character, senior citizen is integer, etc. Right? All of these. Let's say if you want to change any of these data types, for example, if I say that the senior citizen data type, okay, it should not be integer, rather it should be a logical data type, right? Because 1 and 0 is logical. Okay, so I want to change the data type. I have an opportunity to do that. I could just do this, right? I could just do customer_churn, okay, if you want to refer to one column of a data frame, you could just refer to it by referring to the dollar sign. So let's say I'm referring to the senior citizen column. Okay, and I'm saying that I want to change this column to a logical data type. So I would say as.logical of customer underscore churn, right? And then the senior citizen column, and then assign it back to the same column. Okay, when I assign it back to the same column, it means that this column senior citizens in my customer churn data set will get converted into a logical data type from its existing integer data type. Okay, so when I run this and I run the str function again, it will basically change this data type to a logical data type. Okay, change the senior citizen column to a logical data type. Okay, so this is when you import something as a particular data type, but if you realize that I want to change the data type to something else, right, you could use as.logical or as.numeric or as.character or as.complex, right? All of those functions exist. Right? There's something called as.numeric that exists, right? There's something called as.logical that exists. There's something called as.complex that exists. There's as.character as well. Okay, so once you import data, right, you also have the opportunity to edit it, right, to change the data type if you wanted to. Okay, so whenever we want to create a data frame, we would usually do that by importing a data set into our studio, right, like we did with the case of customer underscore churn, right, where we imported a CSV file and created a data frame. Okay, that's how you would do it. The read.csv command only lets you import a CSV file. Okay, but if you want to import other kind of files as well, there's a library that you'll have to use. Okay, so what do we do next, right? So we've imported a data set, right? We've created a data frame. Okay, but let's say you have a use case, right, wherein you want to create your own data frame as well in our studio. Okay, you want to know how can I create my own data frame as well, right? Let's say I have a set of values, I want to create a data frame out of it. How can I do that? It's very easy to do that, right? What you can create, like a data frame, if you guys realize, is nothing but it's a collection of vectors. Okay, it's a collection of vectors, because if you see this, right, if you see this object, it's nothing but this customer ID is one vector, right, because it has values all of the same data type, right? Gender is also a vector, senior citizen is also a vector. All the variables of your data frame are nothing but they're all independent vectors, right? When you combine all of those independent vectors, all of the same length, right, it basically becomes a data frame. Okay, so to create a data frames, you can also do the same thing, right? You can create vectors and you can combine them together to form a data frame, isn't it? So let's try and do that. Okay, so what am I doing here? I'm just creating three vectors here. Okay, three independent vectors. The first vector is called X, right? It has names of 5 different people: Anna, Harry, Michelle, Pete, and Frank. Okay, these are nothing but names of individuals. X is what I'm calling them. Actually, even before I'm doing that, I'm just going to quickly clear my environment and clear my console as well. Okay, so I'm creating X again. Okay, X is nothing but it has names of 5 people. Okay, in Y, I'm storing their age, right? So I have another vector where I have age of people, age of these individuals, right? 20, 25, 29, 31, 23 are ages of Anna, Harry, Michelle, Pete, and Frank respectively, right? So in the same order, their ages, right? And then I have another variable here, another vector. I'm creating another vector here called Z, which basically stores whether they are parents or not, which means whether they have kids or not.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so someone who has a kid, right, will have a value true here, and someone who doesn't have a kid will have a value false here. So for example, Anna, she doesn't have any kids, right? So it's a false. Harry doesn't have any kids, it's a false. Michelle has a kid, so it's a true. Pete has, let's say, kids, so it's a true, and Frank doesn't have any kids, so it's a false here, right? So I'm creating Z as well, which basically stores the information that whether these people are parents or not, or whether they have any kids or not. Okay. Now what I can do is I've created 3 independent vectors. I can combine these vectors together to create a data frame, right, of consisting of 3 columns. Okay. So this is how I could do it. I could just write df, which is the name of the data frame that I'm creating. Okay, the assignment operator. Then I use a function called data.frame. Okay, data.frame is a function that you could use to create your own data frame. Okay, by using vectors. So you'd say name, right, which is the name of the column that I'm referring to, right? So name is equal to X, age is equal to Y, and parents, or I could change this to, let's say, parents still, it's okay. Parents is equal to Z. Okay, when I do this, what would happen is these values X, Y, and Z, right? These vectors X, Y, and Z will get assigned to each column of my data frame, right? And their column names will be name, age, and parents. Okay, you can also, like, let's say if you want to retain the same column names, right, X, Y, and Z, you can also do that. You can just leave out this part, right? You could just do X, Y, Z. Okay, what would happen in that case though is that your data frame df will get created, okay, but the column names will be X, Y, and Z, which is not very intuitive, isn't it? It's not very intuitive. So what I should do is I should also, while I'm creating the data frame, I should also make sure that I'm assigning the column names, right? And that's essentially what I was trying to do here. I can do it again. Okay, so name is equal to X, age is equal to Y, and parents is equal to Z. When I do this, the data frame df that gets created also has name of the person, age of, it also has, along with values, it also has the column names, the column headers, right? And these headers are much more intuitive than X, Y, and Z. Okay, so this is how you can create a data frame.
Now let's go ahead and understand what are the different types of machine learning algorithms which are out there.
So in general, we have 3 types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Let's see them one by one. So starting with supervised learning. So supervised learning is the one in which we have a training data set, or you can say in which we have a labeled training data set, and the machine is trained on that particular label. For example, so there's a teacher or there's a supervisor who supervises the entire process and trains the machine according to the label. For example, you can see up here, here's a teacher on the screen who is teaching the machine by showing different images of the apple. So once the machine is trained, so in future, when we show a different image of an apple, the machine can easily identify that it's an apple with some accuracy. Okay, for example, the image shown up here is an apple with 97% accuracy. So this is supervised learning. So let's see some of the use cases of supervised learning. So first we have a spam classifier. So how do you think your mail is getting classified as whether it's a spam mail or not a spam mail? Well, the spam detection basically works on the basis of filter. These are settings that are constantly updated based on new technologies, new spam identification, and the feedback given by Gmail user about potential spammers. Spam filter uses either text filter or it eliminates the thread based on sender and their history, whether the sender was previously reported or not. Okay, so there are mainly 2 types of filters: text filters and client filter. Text filter work by using algorithm to detect which word and phrases are most often used in the spam email. Phrases like lottery or you won or free Bitcoin are often an immediate flag for removal by filters. Spammers have gotten wise to this and often use blunt misspellings or even substitute of characters like free dollar character in order to make it pass the filter. Fortunately, the modern spam filter can also make allowances for these type of misspellings, and if a word comes up, even with character substitution, the message will still be blocked. Next is the client filter. In addition to the simple text filter algorithm, the top spam filter uses client identity and history to block malicious or annoying spam email. Now, how does a spam filter work? Well, this is done by looking at all the messages of a certain user which he has sent out. If they send out huge amounts of email constantly, or if several of their messages have already been marked as spam through the text filter, in that case their email will be blocked entirely. So this brings us to the use of blacklist. Spam filters also include a blacklist. Blacklisting is simply the process of adding the known email addresses of a spammer to a list. This list prevents any inbound messages from the email address going forward. If you have marked something as spam, it will directly go in this blacklist. And it also helped Google to make a note of certain keywords found from that particular spam mail. So that's the outline of spam detection. The real-time process are a lot more complex and consume a lot of data. Okay. Next is fingerprint analysis. So for fingerprint analysis, what you do, you save your fingerprint in the machine as a record. So the machine checks the data and verifies whether this particular data belongs to you or not. Okay. So once the data is saved into the machine, so from next time, whenever you put your fingerprint on the machine, what the machine does is scan through all of its data. And if the data is matched, then in that case, your fingerprint is verified. This is another application of supervised learning. Next we have is unsupervised learning. Well, in case of unsupervised learning, there is no teacher and there is no label. What the machine does, the machine identifies clusters in it. It finds similar images and group them into a cluster. For example, over here, seeing some pattern in different images, the machine divides the entire image into 3 different clusters. Okay, cluster 1, cluster 2, cluster 3. But the machine doesn't know that cluster 1 is an apple, or cluster 2 is an orange, or cluster 3 is a banana. All it knows that cluster 1 consists of similar item, cluster 2 consists of other similar item which are not at all related to cluster 1. And similarly, cluster 3 consists of different items which are completely different from cluster 1 and cluster 2. And cluster 3 consists of other similar items which are completely different from the item of cluster 1 and cluster 2. Okay, so this is what unsupervised machine learning is. So one of the use case of unsupervised learning is voice-based personal assistant. So the device which you are seeing on your screen is Amazon Echo, and the brain or the voice of Echo is known as Amazon Alexa. The device has many smart built-in to do a number of tasks like playback music, make the light blink. It also recognizes the name Alexa. It's like when you say the word, it recognizes the word and start recording your voice. Amazon calls this word as a wake word. So it's like when you have finished speaking, it sends the recording over to the internet to Amazon. The service that processes this recording is called Alexa Voice Services, or AVS. It's run by Amazon, thus converts the recording into command that it interprets. It's more than a simple voice-to-text service. It is a fully programmable service that can work with other online services to do a large range of things for you. Once authorized by Amazon, anyone can use this service for free to build a homemade Echo. Amazon has also offered sample code for building an Echo using a Raspberry Pi, which is a simple $30 computer. It might sound extremely selfless of Amazon to provide the service for free, but as always, they have their reasons. Amazon want others to build their service into their product so that they can sell you this stuff. So every product that has Alexa built in is a device that can be used to buy stuff from Amazon. These commands that Alexa interprets can be very simple. It's like if you ask for a time, the AVS sends back an audio file to Alexa telling you the time, which the Echo plays back. They can also be more complex. If you ask Alexa to play a Pink Floyd, AVS will search the music service to have you set up for Pink Floyd and then send a command back to the Echo that sets it playing the requested music. Alexa can also work with other technologies in your home. It's like you can even set up your Philips Hue smart lights to be controlled with Alexa. You can ask Alexa to turn on the living room lights and the Alexa will send a command to the Echo that sends a command to these light bulbs to turn on. It can also work with various online services. You can link Alexa to Uber and you can request Uber by simply asking Alexa. You can link it to Domino's and you can just order a pizza with your voice. So this approach means that Alexa can do a lot of things for you. And the list is just getting longer. Amazon is adding more features and skills to Alexa. And if you are smart enough, you can build up on their own. So it means that you can use Alexa to control things that are not even on the list. Okay, well, however, Alexa needs internet connectivity and AVS to work. If your internet connection is slow or it's not working, then Alexa won't be available and your Echo will be useless. So if Amazon decides to charge for a service or just close it down, then in that case, you'll be just left with a useless device. Well, Amazon is not the only one in town. We have Google, Apple, and Microsoft, which offers similar services that can perform tasks by voice command in the form of OK Google, Siri, and Cortana. They use similar approach, voice commands that are processed in a cloud service. But most of them are not as flexible or as integrated with other service as Alexa is. So whichever of these services end up being the one we all use, hopefully they will be as polite as Alexa. I'll just give you an example. When I asked her how she works, she replied, "Lots of people had worked hard to teach me, and I'm still learning more. Wouldn't it be nice if all of our appliances were that modest and polite?" Right? So let's move ahead. So another use case of unsupervised learning is Netflix recommendation. So more than 80% of the TV shows that you guys watch on Netflix are discovered through the platform's recommendation system. That means the majority of what you decide to watch on Netflix is the result of decisions made by a mysterious black box of an algorithm. Let me just give you a brief of how it works. Well, Netflix uses machine learning algorithm to recommend you the list of movies and find shows that you might not have initially chosen. To do this, what it does, it looks through a thread within the content rather than relying on board genres to make a prediction. So this explains how 1 in 8 people who watch Netflix Marvel shows are completely new to comic book based stuff on Netflix. Let me tell you about a guy named Todd Yellen. He's the Netflix Vice President of Product Innovation. He has explained the working of Netflix as a three-legged stool. The three legs of this stool are Netflix members, the tagger who understands everything about the content, and our machine learning algorithm that takes all of the data and puts them together. So Netflix has more than 100 million worldwide users. If we count the multiple user profile for each subscriber, it comes to around 250 million active profiles. Now Netflix uses different kind of data from these profiles, like it keeps a track of what you guys are watching from your profile, what do you watch after completing your current video, and even what you have watched earlier. It also keeps a track of what you have watched a year ago or what you're currently watching and at what time of the day. Well, this data is the first leg of the metamorphical stool. Now what they do, they combine this information with more data to understand the content of the show that you are watching. The data is generated from dozens of in-house and freelance staff who watch every minute or every show on Netflix and tag it. Now all these tags and the user behavior data are taken and is fed to a very sophisticated machine learning algorithm that figures out what's most important and what should it weigh like. Or how much should it matter if a consumer has watched something yesterday? Should that count twice as much or 10 times as much compared to what they have watched a whole year ago? How about a month ago? Or how about if they watched 10 minutes of the content and abandoned it, or they binged through it in 2 nights? So how do we weigh all that? Well, that's where machine learning comes in. What those three things create for us is taste communities around the world. It's about people who watch same kinds of thing that you watch. Viewers are fit into thousands of multiple taste groups, and it's these that affect what recommendation pop up on the top of your screen. The tags that are used for machine learning algorithm are the same across the globe. However, a small subset of tags are used in more outward facing way, feeding directly into the user interface and differing depending on a country, language and cultural context, as the tags have to be localized in a way that make more sense. For example, if you know English and you're watching Hollywood movies or movies in English, then in that case, Netflix won't recommend you German movies or Chinese movies or Japanese movie. Alright. The data that Netflix feed into its algorithm can be broken down into two types, implicit and explicit. Explicit is, for example, you gives a thumbs up to the series The Friends, so the Netflix get it, okay. And implicit data is mostly the behavioral data. It's like you didn't explicitly tell Netflix that you like Black Mirror, but you just binged on it and watched it in 2 nights. So the Netflix understands that behaviorally. So the majority of the data is implicit. So this was about how Netflix is using machine learning to recommend you the movies. Fine. So next we have is the reinforcement learning. Well, in reinforcement learning, what we have is the agent and the environment. The agent selects some action using some policies. So there is no teacher in this case for training the machine. If the machine makes a right decision, the machine gets a positive point. If it makes a wrong decision, it gets a negative point for it. So repeating the process again and again and again, the machine learns it. So this process is of reinforcement learning. So let's take the example of a self-driving car over here. So initially, when the car was trained, so the car didn't know what way to choose. Okay. So what it did, it made an action, but the action it performed was wrong. So it got a penalty of minus 50 points for that. So from the next time, car realized that what it did earlier was wrong, and it updates its policy and then iterates the process. Okay, so this is reinforcement learning. So let me just explain you reinforcement learning with the concept of how Pavlov trained his dog using reinforcement learning. So there's a famous example of how Pavlov trained his dog using reinforcement learning. So it's like initially Pavlov gave food to the dog. So in response to the food, the dog started salivating. Okay. This was before conditioning. Then in the next phase, what he did, he just rang a bell, for which the dog did not respond anything. Okay. Then the third phase, what he did, he rang the bell and then gave him the food. So seeing the food, the dog started salivating again. Then after that, he repeated this third step again and again and again until the dog learned it. Then after conditioning, whenever Pavlo used to ring the bell, the dog started salivating. He understood that whenever the bell is going to ring, his master is going to give him the food. So this is how Pavlo trained his dog using reinforcement learning. Okay. One of the application or the use case of reinforcement learning is self-driving car. A recent study has shown that over 90% of road accidents are caused by human error. To err is human, but behind the wheel, mistakes are often more catastrophic. Accidents have led to a massive number of unnecessary deaths, lives that could have been saved otherwise through self-driving. So this is where self-driving cars comes into picture. The autonomous car or the self-driving cars are much safer than human-driven car. They are unaffected by factors like driver fatigue, emotions or illness. This makes them very safe. Self-driving cars are always active and attentive, observing the environments and scanning multiple directions. It would be difficult to make a move that car has not anticipated. So how does a self-driving car work? Well, self-driving cars mainly rely on three technologies: IoT sensors, IoT connectivity, and software algorithm. There are many types of sensor available for a self-driving car. For example, sensor for blind spot monitoring, forward collision warning, radar, camera, lidar, and ultrasonic. So all of these IoT sensors work together to make navigation of a self-driving car. Next is the IoT connectivity. Self-driving cars uses cloud computing to act upon traffic data, weather, maps, adjacent cars, and surface conditioning among others. This helps them to monitor their surroundings better and make informed decisions. And next is the software algorithm. All the data the car collects need to be analyzed to determine the best course of action. This is the main function of the control algorithm and software, and this is where reinforcement learning comes into picture. This is the most complex part of the self-driving car since it has to make decision flawless. A flaw like in case of Uber's self-driving car can be fatal. Okay? In today's world, the most famous self-driving car are those from Tesla and Google. Tesla cars work by analyzing the environment using a software system known as Autopilot. Autopilot uses high-tech cameras to view and collect data from the world, same as what we do with our eyes. It's called as computer vision or sophisticated image recognition. It then interprets this information and makes the best decisions based on it. So this was one of the use case of reinforcement learning.
Linear regression. You all must be remembering the linear equation that we have, right? So what was that linear equation that we used to have in our school days? It was something like this, right? Y equals mx, sorry. So the form was y equals mx plus c, right? So the form was y equals mx plus c, right? This was the form of the equation that we used to be getting in our getting for a linear line, right? So we had this kind of line from that equation, right? It might be, it depends on the value of m and c. I am taking c somewhere is there, so this kind of lines we will be getting. And here, let's say this point is x1 y1, so for this one is x1, so this point up here in the line will be x1 y1, right? This point up here will be x1 y1. So for the value of x1 we have this value of y1. So in here, if you see this variable, this was used to be called dependent variable, right? Dependent variable. Why dependent? Because it always changes with the value of x, but x doesn't have any limit. So this is called independent variable, right? This is called independent variable. So x is independent, y is dependent, right? So that kind of equations we used to have. Okay, and this aim here, right? This aim used to be called slope of the line, right? This was used to be called slope of the line. This c was some constant which can be zero also, right? C is some constant which can be zero. So that's what we had in our linear line equations. Now the thing is, how do we use this for our class, like for this linear regression models to be built? Okay, So the entire thing is based on this concept only, y equals mx plus c. It is as simple as that. So we will have some kind of a equation which will be in the form of y equals mx plus c. We will predict the values of the data points that is being sent to our data set when it is deployed, and then we will get the values of y. Okay, so that's what is the whole concept of machine learning, linear regression. So linear regression is a technique to find relationship between two or more variables. Yes, right. So if we have more than two variables, then how the equation will look like? It will be, let's say y depends on more than one, right? So it will be mx plus ny, sorry, nz, something like that. And so mx plus na plus let's say pc plus d, kind of this kind of equations, right? So here it will have three variables, three independent variables, x, a, and c, right? Three variables we will be having in that case, right? Three variables we'll be having in that case. So that's where this machine learning comes into picture, and that's how this machine learning thing works. Okay, that's how the machine learning works. Now let's see how we are going to use it for our model. So that's why, so this is called linear because it is based on the equation of a linear line. Okay, it is based on the equation of a straight line actually. Okay, so as I told, change in dependent variable is associated with the change in one or more independent variables, right? So that's the basic concept of the equations. Okay, next is this picture. This is called Rex Thor, the dog bearer. Okay, so if you see the right hand side, guys who are aware with Avengers, they must be recognizing the right hand side guy is some kind of a Thor. It's look like Thor. He carries a dog, right? Instead of carrying a hammer, he carries or a stormbreaker. He is carrying a dog, right? So he is named as Rex Thor, the dog bearer. So there is in the, we know, right, there are seven stars in the planet which has some kind of a shape. So it is one of them. Okay, this is a star pattern actually. So why we are taking this here is, this is the data point, right? In the left hand side, this is the data point, and this is how the thing looks like. So if you draw this line, then this is, I mean, you see like there is a lot of difference between lines, right? So that's how it looks, and there is a concept of r square. R square means mean squared error. Okay, that is also known as goodness of fit. Okay, that we will be covering in the next sessions. So you will see when r square gets minimum, that means the model has huge error. So here see the r square value is pretty small, right? It is 0.06. That means this line up here doesn't at all represent this model. Okay, so that's how this linear regression works, and with the help of this goodness of fit r square value, we can somewhat check the model's performance also. So that is a statistical test. At the end of the class, I will be telling you that, like the theory behind it, how those are calculated, and those part. Okay, so that is what is about linear regression. It's that much easy only. Okay, it's nothing more complex, more, not much of a complexity is there in the in this linear regression. So it's far too easy. So next, there are a few examples of linear regressions. Okay, so where, yeah, I told, right, Ravi. So r square I will be coming later. It is a mean squared error. So it is a goodness of fit test. That is a r squared test, you can tell. So I will be coming to that in the last part. Okay, I will tell you the theory and everything also. No need to worry. Okay. So this is the regression is a technique that displays the relationship between y and x, as you already know. So if temperature drops down, the guys will start putting more jackets, more jackets to avoid the cold, right? To keep them warm. So that's a straightforward relation between two variables. This is an example of linear regression. Okay, temperature versus number of cones sold at the ice cream store. If it's gets hot at outside, then the number of ice cream sold will be more, right? Inches of rain versus new cars sold. So that means in the rainy season, guys would like to avoid going out without their car, right? So that's how. Daily snowfall versus number of skiers. So if snowfall is higher, number of visitors at the skiing park will be increased, right? So that's how this works. Now this is the base of it. So if you think there is a relationship between two things, regression would help confirm it. That means if at all there is a relationship between those lines, let's say I will draw you a plot first. Okay, so let's say here is a plot I am drawing. Come on, why it is too large? I want something smaller. So if you see there is so some data points, let's say this one, say this one, say this one, this one. So see here is a perfect relation, right? But again, this is not a linear relation, right? So if you draw it otherwise, if we say there is kind of a this line goes in, so this is the best linear regression line that can be fit in, then also this doesn't seem to be a good relation between them, right? So linear regression will help you to understand if there is any relationship between two variables or not. Okay, so that's how linear regression works. So you will build a model. If the model performs poorly and no ways you can fine tune the model, that means there is not much of a linear relation between them, right? If there is a linear relation, then it will look good, right? So the goodness of it would look good. So here is an classic example. So if you see, the values here are categorical, right? Why categorical? Because y only has two values, y0, y1, right? Only two values. So in this two values, if you see, they are categorical values, and it comes under a lambda shift function, right? I mean, sorry, sigmoid function, this kind of right, as kind of a function. So this is called sigmoid function, right? So that's how this thing goes in. Okay, so here if you draw the linear regression line, it will fail miserably. Okay, because if you calculate the r square fit for this, it will be too low number, because it is not at all a good fit, right? So this one is an example of linear regression, this one is for logistic regression. So to see how this linear regression helps here, if you draw this line, if you build this model using this line, then only it will be cleared.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
That there is no linear relationship between these two data points. Okay, these two data points. Okay, so that's how it goes. Okay, so next we will be going to a few scenarios when we can use linear regression, and when do we go for logistic regression. Okay, these are a few types or a few factors which will help us deciding that. Okay, so see here, first of all, it will be continuous. For linear regression, the variables has to be continuous. That means it shouldn't be categorical or skewed at any 2 points, right? So it will solve regression issues. That means it should be a good fit. Okay, good fit to a point to some data points. Okay, and it should be somewhat it should be represented by a straight line curve. Okay, so in this case is match, so then it will be a perfect fit for linear regression. So it has to be continuous variables. That means the spread of the data, it shouldn't be skewed. So it should be somewhere, it should be spread out evenly among this in the xy plane. Actually, it should have a straight line kind of a relation between them, and it should solve regression issues. Regression issues means where we have a lot of data, we churn those data to find out some basic data, basic inference. Actually, when I say this, both of these are supervised learning algorithms, so don't confuse that. So here what we'll have, we will be for both the cases, for both the cases we will be having this values, right? Like we will be having training values, right? But here we will have some output, that will be spread throughout the I mean that will be somewhat significant, not some classification things like 0 and 1, the gender split, male or female. It is a classification issue, a spam or not classification issue, predicting housing price, linear regression. Okay, this kind of things comes under linear regression. So if you see if you build a model of housing price predictor, there has to be some kind of a relation between all the variables, right? But for classification, it has to meet some criteria. There won't be any relation between those criteria individually, but there should be there should be a skewed value, and the variables will be categorical. Okay, when I say variables, so can anyone tell what is a variable? When we are telling variable, which one we are telling, like what we are actually trying to tell here when we are telling continuous variables and categorical variables? What are those? So if you get a data set, let's say there are 10 rows, with 15 columns. So which one are we are telling about target variables? Okay, those parameters which impact the outcome, like dependent variables. So let's say if we have 10 rows and 15 columns, then 14 columns in that will be independent variables. Those are X values, they can go anywhere. Okay, the variables, the target variables will be the dependent variables, right? When we say continuous and categorical, that is the dependent variables, that is the Y values, that is the outcome values, right? Because independent variables can be anywhere, right? It can be anywhere in the plane, correct? So that's why when we consider fitting a model, we shouldn't be looking at the feature first. We should look at what kind of output we are expecting. So is the output is somewhat categorical or regression? What is it? The outputs will be in continuous variables. Let's say housing price. If you have 10 lakhs rows of data, so you are most probably will be having all the numbers between 20 lakhs to 1 crore, right? Depending on the scenario. So that's a continuous space, correct? But categorical things, when we are deciding on mail classifier, spam classifier, right? Spam or not, it's two values, 1 0 or 1, right? So categorical things, right? So that's how we decide on this linear regression and logistic regression. Okay, so it's Y here, it's Nancy, it's Y here. So when I tell the outcome, that is a Y, right? That independent variable. For X, those will be independent ones, they can go anywhere. Those will be the features of your data set on which you will build the models. When you say Y equals mx plus c, this X will be independent one, it can go anywhere, right? So you really can't judge from that, right? Because for a categorical, I mean, if you think for a spam classifier, what all things can be there, what all things, okay, let's forget it. Okay, think about Titanic survival data set. So let's say you have the data set of surviving from Titanic mishap, and you have all rows in there, right? So the values will be like sex, age, which parts they were in, right? So those things will be there, right?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So let's say we have a housing price data set. Okay, so in the housing price, what kind of columns you will have? Let's say area. So let's say we have a point called area. Okay, we have something called garden space. Okay, we have number of flats, amenities. These all can be realistic features. These all can be realistic features of your housing price predicted data set, right? So with the help of this, we will predict a housing price, correct? Let's say we have a survival data set. Let's say cancer data set. Okay, so for predicting cancers, we have a data set like that. For that, we will have internal or external. Let's say some kind of some things like that. Come on, again it went to scratch mode. Internal or external, right? Then we will have a size, we will have malignant or benign, etc. Okay, so what it will predict, yes or no. So you have a gland growth, is it a cancer or is it not? So yes, no. These variable types are called categorical ones. Okay, this kind of variables. So let's say if you are trying to buy a house somewhere in Mumbai, this value will range from 1 crore to 5 crore, and you are most likely to get this area because of this different size, different types of area values. You will get almost all the values between this range. Let's say 1 crore to 2 crore. Let's not go to 5. Let's go to 2. Okay, so you will get all kind of values. So this is the things. Okay, so that's how you need to predict which one to use, right? So usually fixed number or possible. No, Saran, actually categoricals will be skewed. Okay, so it can be more than one also. Let's say we have, when we are thinking about this kind of categorical problem, it can be yes, no, it can be yes, no, or moderate, like that. So it can be anything, it will be fixed. Okay, as you rightly told, it will be fixed. But for continuous, it will vary, it will be in a range. Okay, so that's how we decide if the data set that we are having is categorical or continuous. Okay, so based on that we decide, is it a regression problem or is it a classification problem, and based on that we are going to choose our models. If it's a regression, then we are going to go with this linear regression. Otherwise, we are going to go with logistic regression, naive Bayes, or XYZ, XYZ, XYZ. Okay, that's how. So that's the line equation. These are the some variables. These are called observables. This red points. This line is called line of linear regression. That means this is the outcome of your model. These points will be observations, right? And this will be regression line. And how do we decide if the regression line is a good fit or not? We use least square method. Okay, least square method that we'll discuss. Okay, so how do we do that? It's time to discuss that. I will show you with the graph. So let's say we have this kind of a line. Okay, let's say we have a point here. This is x1 y1. Okay, we have a point here. This is x2 y2. Okay, we have a point here. This is x3 y3. Okay, let's keep it to 3 lines. Okay, and somewhere down here, based on this line outcome, okay, this one is regression line. This will have separate kind of xy value. So for this one it will be somewhere here, for this one it will be here, and for this one it will be here. So these are like, here is the y value, here y value for this will be somewhere here, for this value will be somewhere here. So mean of them will be this one. Okay, let me change the color. Okay, mean of them will be this 3, so somewhere around here. This is the mean. Okay, this is the mean of y. Okay, which will denote as y bar. Okay, we will denote as y bar. Okay, now see the basic concept. How do we calculate? Okay, the basic concept of how do we calculate this. Okay, how do we calculate the r square? So these points, if you see, these blue lines are called error from line. Okay, error from regression line. Okay, if I write the equation, that is, we are going to, so as you know, the point distance, how it looks like, x minus x1, y minus y1, right? So that is basically this. So here x1 will be common in both, so it will be the value outcome of this AC line, that is squared error SE for line SE. I am scrolling it a bit up. So we will, what we have, SE of line will be y1 minus y squared plus y2 minus y squared plus y3 minus y squared up to n. This is the standard line error, because this is, if we consider this as y1 and all these values are x's, right? So when I write x, when I write y, that means y actual. Okay, when this y3 means y predicted. Okay, so sorry, I just reverse it. Okay, this is y actual, this is y predicted. So when I say y1, y2, y3, these are these points, right? So these are the original points that we have. So it will be y actual. Y means y predicted, that is outcome from this line. Okay, so y actual, y predicted, like that. Okay, for x1, for x2, for x3. Okay, this is what is denote squared error from the line of linear regression. Okay, this is what is denoted by this. Now I will change the pen color. So if we see squared error from y bar, that is y mean, that is from this red line. I was using a red, let's go back. So this is the point, this is the red line, So this one is the squared error from line. So here is the point. So this one will be the squared error from the mean of the data set. Okay, this is the squared error from the mean of the data set. So what we will have y1 minus y bar square plus y2 minus y bar square plus dot dot up to n. Right, now understand one thing, this value over here is how likely, what is the error between the linear regression line and the data points, right? This value up here is to find out the central tendency of the errors, right? So if you find out mean of these values, this y predicted values, and if you find out the difference between the actual points and the y predicted mean values, that means this is the variance. Okay, this is the distance and this is the variance. Okay, this part is the variance from all y values, this is the distance from each and individual y values. Now in order to get the r square estimate, that is the good fit line, or if it's a good fit or not, what we do, we calculate this value, that is se line divided by se y bar. Okay, we have this kind of a value. So what this denotes, how unlikely the line matches the actual values. Okay, this is what we denote by this part, right? Now if you want to know how good is the model, what we do, we subtract it from 1. This becomes our goodness of fit. For statisticians named it as r squared, or it is also known as least, this is also known as least squared error method. Okay, so this up here denotes goodness of fit, that means how good our model is. Now see what happens to this. Okay, after this I will pause for questions. So the value that we have, right, so the value that we have is somewhere like 1 minus SC line, so 1 minus SE line divided by SE y bar. So if AC line is pretty smaller, right, what does that mean? The line is a really good fit. So this is small divided by SC y bar. This will also get very small, right? If the difference between the each and individual data point is small, this will also get somewhat small. A small number by some number will yield you a small, even a smaller number, right? So that will approx reach to 1. Okay, but if for this equation, the the SE line gets higher and we have a CY bar which will get even higher, which will get somewhere around this, right? So, but it shouldn't be, as this is the higher but less than AC line, so we will have a high value up here. In the AC line we will have a high value. Okay, so this so how it works, this AC y bar, let's say for this equation, if we go back, if the points are even more down, right, so from, if the point is somewhere here, so somewhere here, all the values will be bigger, right? Based on this AC bar and the AC line, all the values will be bigger. So when we divide two big values, it will almost come to 1 and r square value will approx to 0. Okay, so that's what means when r square is small, bad fit. Okay, when r square is large, good fit. Okay, that's why this value r square is named as goodness of fit. Okay, so that's what is about this goodness of fit equation. Okay, these things I already told, this XY things. Now here is an example for you guys. Okay, so we have a few data points. We have plotted all this in the plot. Okay, we have plotted all these data points in here. Okay, now we will see using linear regression how do we calculate this. Okay, so x bar, y bar is there. That is the mean of x and mean of y. Mean of x is 3, mean of y is 3.6. Now this is the line. This is the line, and this is the mean point is described with this red point, and this line, right? This green line is for the I mean the mean line. Okay, this is the mean line that we have. That is the y bar that we have. This is the mx plus c line that we have drawn till now. As we know from maths, this is the equation for m, that is the slope. That's how we calculate. So once we calculate m, you will see the value here. I am just scrolling through. Okay, these are some calculations, so I am not wasting time. So that's how we find out the value of m. Okay, so what does that mean? Let me show a few use cases. So if this is the line, now we need to find out value of m. M is x minus x bar into y minus y bar divided by x minus x square, x minus x bar square. Okay, now if we go in, so x minus x bar, when we calculate, that is the difference of the data points from its x mean. Okay, x mean. So these are the data point differences. We calculate this here, we put into the equation. Then we go for difference of y, that is y bar, because we need to calculate y minus y bar here, right? So this will be the differences. So this one will be the difference, this one will be the difference, like that we will calculate. Okay, so that's how we will have y minus y bar. We already have x minus x bar, we will square it out here. Then we will find out m by summarizing all this. We will sum all these things up, and we will divide it by sum of this thing, and we will get the output. Okay, we will get the output. So here m value goes to 0.1. Okay, now y will be 3.6, m will be 0.1, x will be, let's say for 3 we are calculating. Okay, for 3, x equals 3 we are calculating, because as we see, for x equals 3, the mean is 3 and 3.6, right? So for x equals 3, the mean, we are calculating based on the means here. Now we will get the c value here, that is 3.3. Okay, so our straight line equations now becomes y equals 0.1x plus 3.3. Okay, so that's how we do calculate our linear equations, logistic regression session. Okay, so one thing to understand, first thing is regarding machine learning, right? So broadly there are two types, like supervised learning and unsupervised learning, right? So for supervised learning, we will always have a definite objective. It can be something, a continuous set of variables, or can be categorical variables. Okay, and for like unsupervised learning algorithms, we will always be having a indefinite output, let's say cluster of points kind of things. Okay, that will be for supervised algorithm, whatever data we use, it will consist of a level. It can be a continuous set of variables, or it can be categorical, that doesn't matter. Okay, so it will always be, the data will be definitive. It will give you some kind of a output. Now if so why do we need this kind of a different set of algorithms, right? When we are dealing with linear regression, why don't we have, or why do we have this logistic regression, which is a classification algorithm? So the thing that you need to understand, for linear regression, if the data is continuous and spread across a good amount of range, then only the line can help you in predicting the values, right? But instead, if it's a categorical problem, like where the data is skewed in two ends, or two three ends, like let's say values of 0 and 1 are the best scenarios that we have. So typical examples of logistic regression would include, typical examples would include, like tumor prediction, is it a malignant or benign one? Okay, it would be spam classifier, it will be fraudulent transaction detection. All those kind of things will come under logistic regression. So as you can understand from the name itself, here the data will be too skewed, right? It will either have a yes or no value, or you can say it like 0 and 1. So if you have, let's say, 10,000 data points skewed between 0 and 1, there cannot be anything which sits in mid of it, right? It cannot sit between 0 and 1, right? So it should be at the two fag ends. So if you draw a line from two ends, what would do, that would be horrendous for a linear regression model to fit in, right? So why so? Unweighted decision tree is something else and the logistic regression is something else. So it's those two are the different things. So don't just confuse the algorithms, okay? So when I am going with one algorithm, stick to that. If there are any relations between them, I will also cover that, which is sadly there are nothing. Anyways, so to continue with it, for this kind of logistic regression problems, the data will be skewed between 2 points, right? So if we draw a line between point 1 to point 2, if it's a straight line, then also it won't fit the data. When I am telling this, what do I mean? I will shortly show you that. Okay, so what do I mean with that? The data will be skewed and the line can't fit it, right? So let me open this. Okay, when I say that the it cannot fit the data, right? We saw for linear regression how the models worked, right, and how the data points look like. But let's say what we are talking about today is it will be some kind of a graph like this. If you plot the observations, right, then I mean when you plot the outputs in a graph. In yesterday also we did the same thing and we saw there was a continuous set of variables, but here what it will do, yeah, so it will be, let's say these are some data points which will be near 0, right? These will be some data points. So the output of this will always stack to 0 and output of all this will be stacked to 1s. Like that, this kind of a set will be there. So if you draw a straight line, it would only fit 1. It can fit max of 2 values. It can fit max of 3 values, like that, right? So in that case, what would happen? The model will fail radically because the error percentage will be huge, right? And it won't be fitting a good model. So that's why we won't be able to use linear set of regression, linear set of models to fit in this kind of a requirement. Instead, we would need this kind of a curve, right? See, now this fits in perfectly, right? This fits in perfectly in the under training example. So this curve is again called, sigmoid function, right? This x-shaped curve, S-shaped curve. So what is the features of it? It is an asymptotic curve, right? When do we say asymptotic? That means it will never reach 1, it will never reach 0. Okay, so what it will do at positive infinity, it will asymptote to 1. At negative infinity, it will asymptote to 0. Okay, so it will never match the lines, but it will be asymptotic. So in this kind of shapes, we can have some kind of a good fit for this kind of classification problem. Yesterday's thing was based on a straight line equation, right? It was a y equals mx plus c. This kind of a straight line equation was yesterday's topic of discussion. But today's topic of discussion will be this kind of a asymptotic curve. Okay. So before going to this, I will be covering one more. Okay, I will come to that later. So this curve equation is this 1 by 1 plus e to the power minus x. So this curve, as you see, it will asymptote at the positive and negative infinities, right? So if you see e to the power minus x, then if you set the value of x as minus infinity, what would happen? A very large number will come at the denominator part, which will force this value to go to 0, but it won't be 0. But as you know, infinity is a big number, so infinity plus everything will be infinity itself, right? So it will be very near equals 0. But if it is positive infinity, then e to the power minus negative infinity will be too small to be considered as 0, right? So this value will asymptote to 1. So that's how the sigmoid function works. And we will establish our logistic regression functions and everything based on this function itself. Okay, this function itself. So now what I will do, I will go to the PPT and will cover the things that are there. Okay, then I will again come back to the curves and all. So this is how the basic concepts of logistic regression stands. So this is how this sigmoid function comes into picture instead of a linear regression line. Okay, so I explained the basics of it. Now let's see with an example. Okay, So someone is asking you to, hey, see, I want to buy a property which will have a bigger garden area for some amount of money. Okay, so what we will do, we will do a simple linear regression, right? So what we will do, we will have the dependent variable as property size. So we will have an independent variable of money. So it's obvious, right? If you want bigger garden area, that means your property size has to be bigger, right? So you need to spend more money than before, right? So again, it has many other many other criteria, but let's have this fixed. Okay, let's say the locality is fixed, the area is fixed, that the village or the town or the city is fixed where they're trying to find the house. So if you consider there are only two external variables, that is money and dependent property size and money, then in that case what we will have is we will have a linear equation between these two, right? So their linear regression will perfectly fit in. Yes, Giri, so that's what I told. So property size, so that's how it is. So next point will be, so bigger garden area means there will be smaller house area. So we are I mean, what we are doing here, we could have taken a multivariate solution here, but we are going for a small part. So we are breaking it into chunks. Okay, so when we are searching for bigger garden area, what does that mean? That means the house area will be smaller, right? So in a property, if a house is there, let's say we want to buy 1,000 square feet of 2,000 square feet of property. In that garden area we want of 900 square feet, so the house area will be shrunk to 1,100, right? So that's how. So here also a linear equation exists between them. Why? Because if you make the garden area large, the house area will come down, right? So house area and garden area size will also have a linear kind of equation. This can be solved using linear regression. So this kind of problems can be solved using linear regression, because this is not categorical. The data will be continuous. So the value, the size values or the price values, when you plot it, it will be, so it will be uh, linearly dependent between them, and as it is a continuous value, so linear line will fit it. There might be errors, there might be estimation errors and all, that's fine, but it will fit a linear model, so we can predict those kind of things using linear regression. So what we can say from this, like if the guy who is asking you for buying a house, if he spends X amount of a money, he can buy Y area of a house. Okay, Y property area he can buy. So this one you can comment from linear regression. But let's say the guy wants to ask you, so the property will have a good neighborhood, will the location be noiseless suburb or a busy bustling city? So how the properties, what is the location of the property, that kind of preferences someone wants to ask you, then you will be in a soup. So see this problem statement, will the property have a good neighborhood or not? What the values it will have, it will have a categorical value 0 1, right? So again, if you plot here, if you plot those 0 1 things here, like I saw, like I described in the plot before, it will be skewed in 2 points. So if I draw a linear line, it will feel radically, right? You can't predict it. So if I go back to my plot, let's say we are trying to deal categorical problems using a linear regression model. So I will draw it again. Okay, so let's say these are a few values. Okay, these are zeros, these are one. So I have a data set where this neighborhood is also given, and neighborhood is given as like good neighborhood or bad neighborhood. So this is good, this is bad, this is bad. Now let's say I draw this line. Okay, so now let's say some property is bad. So but what it will do, let's say we want to know if the property has this kind of a value, then what is it? So it will predict the values in here, the y value will predict in here. So will be this one will be your value. So what can you comment on this? So the value coming will be around 0.3 or something. So there will be a lot of error, but it should have been coming as 0. It will get worse till you once you move to the top of the line. So it depends on the line that you draw actually. So come on, why it is not going? Yeah, so let's say some point here for x here, the value will be coming up here, right? So this will again go to a good property, but there it should have been a bad property. So this kind of problems won't be, you won't be able to solve using linear regression models. Okay, This kind of problems you won't be able to solve using linear regression model. So in this case, you need that funky S-shaped curve, the sigmoid function curve that we shown here. Okay.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So that's the whole idea. So this kind of a classification problem, linear regression won't be able to answer. So you would need to apply logistic regression models to this, and this will help you in answering classification problems. So this is the never-ending loop that it will go on. Okay. So will the property have a good neighborhood? Will it rain tomorrow or not? Is the mail spam or not? This kind of small questions, this kind of small classification questions, it can answer. Okay. So let's go ahead with this PPT. Okay. So see, machine learning, supervised, unsupervised. Supervised is again divided into two broader categories: regression, classification. Regression we already covered, linear regression. Today we are going to cover logistic regression. That's another classification problem. There are many others. We will come to those one by one, but these are some major chunks. Okay, so a statistical classification model, as you already know, this machine learning, heart of machine learning is stats. Next is deal with categorical dependent variables. Explain this. Could be binary or dichotomous, so that means it should be having two values, not more than two. It could be multinomial. Yes, obviously it can have only one feature of x, it can have multiple features x, right? So yesterday we saw how it does for univariate and multivariate machine learning linear regression models, right? Same thing applies for logistic regression models also. So x can be only one feature or x can be a set of features. So that's where that way it can be either multinomial or it can be univariate. Okay, it can take both continuous and discrete input data. Yes, because this kind of a S-shaped curve can also fit continuous data also, but again in that case it will have a lot of errors, right? So continuous variable, if you plot using a S-shaped curve, it will be giving you some model, but the error will too high to explain. Okay, so that's why we don't really specify it. So we only consider of this categorical data. Okay, for continuous variable also you can plot this, but it won't be helpful because it will be having some problems, right? Because it won't be able to take care of continuous variables. Okay, so that's why we have linear regression models. Yes, sure. So for multinomial, it is like, let's say we are trying to find what should we find? Spam classifier. Let's go ahead with the example that we have. Okay, so for spam classifier, if we think there is only one feature to be, that is count of spam words, right? If we think this is our only feature, so what do we mean by spam words? It will be misspelled words, right? It should have like this. It should have sell, buy, money, transfer, bank details. This kind of words are very commonly noticed in spam classifier, right? So if we want to build a spam classifier using only count of spam words thing, right? Only count of spam words thing, then it will be univariate. Now, if you have noticed spam emails, it has one more feature also. Like for spam emails, the sender address will be fishy. The sender address will be fishy. What do we mean by fishy? The domain name will have some absurd kind of a values. It might not be a permanent domain, right? So if we take that also in account for building a spam classifier, it becomes multinomial. Why multinomial? Because okay, so why multinomial? Because we know we denote feature vector by x, right? So if x contains only one value of x1, then this is univariate. Okay, because the number of independent variables in here is only one independent, right? So whatever has to change will change with the value of x1 only. But if x contains more than one, that is x1, x2, xn, so it might happen that among these n features, all n features are useful. It can happen, or it can happen some, let's say 10 features are useful. Okay, others might be junks, but it has 10 features, so 10 independent variables, right? So as we have 10 independent variables, what it does, it will have like 10 layers of x versus, so it will have a 10 independent variables. So the y value that we are going to predict will have multiple features in it, right? Will have multiple features in it. So we need to fit in more than one feature vector in our machine learning equation. So if I go back to this equation, like we see here, this is the equation for linear regression, right? So if we have something like this, 1 plus e to the power minus, I will come to the derivative, I mean machine learning form later. Like this, if we have, then it becomes a multivariate problem. This is a univariate problem. Okay, so that is how it depends, because here it output of the model will depend on more than one independent variables. So that's why this is called multinomial. Okay, so that's what the idea is. That's what is about multinomial and univariate things. So here also we can predict, here also we can have this kind of we can use clustering algorithm to predict the data. Okay, we can use this kind of algorithm to predict the data. Okay, so for clustering, what happens, as a point came in, I will show you. For clustering, divide data in unique sets, right? So that is what is called clustering. So the sets can be 0 1 also, the set can be cat, dog, fish also, right? So the both type of problems can be solved using clustering, but for classification it won't fit this purpose, right? That is the whole base of our statistics. So for clustering we will have a different set of algorithms. There if you see, there no kind of a machine learning model will be there. There will be a generic set of steps that we need to follow. Stats will be there, but it will be in the minimalistic part. Okay, so that's how it works. Okay, let's go ahead. So this is a tool for applied statistics for discrete data analysis. You already discussed. Gives outcome in terms of probability, right? That's what it does, right? So what the model will do, the model will give you a probabilistic output. Like let's say for this email to be spam, the chances are 70%. We will convert that to 1. We will see this. So this is again based on probabilistic models only. Okay, so this logistic regression will be, the probability will play a big role here, because see, one thing you need to understand, when we are going for logistic regression problems, yes, this the equation that I have shown, this will be the curve equation that we have. That's true, that's not a problem. But the thing is, when you are predicting the output, so what this value will predict, this 1 by 1 plus e to the power minus x, it will never predict 0 or 1. Perfect 0 1 1 it would never predict, right? Because it is an asymptotic function. So at and infinite values you won't be giving to the function, then the function will stack, the function will be looped in for forever, right? So it will output some values from 0 to 1. So that will be the probability of that problem. Let's say the email probability of probability of email being spam, right? So this kind of outputs it will give. So when it gives greater than equals 0.5, we can consider this to be 1. Less than 0.5, we can consider it to be 0. That's how the math tells us. So this is again, this kind of things will predict the probability of the event being happening. So probability theory also will play a big role here. Okay, so that's how this works.
So let's get started to your Hello World machine learning project in Python. So this would be a step-by-step tutorial. So let's get started with your Hello World machine learning project in Python. Okay, so this is my Jupyter notebook. So the very first thing that I'll be doing up here is importing all the required libraries. So I'm importing pandas, and from pandas I'm importing scatter matrix. Next I'll be importing matplotlib as PLT. Then we are importing model selection from sklearn, classification report from sklearn.metrics, confusion matrix from sklearn.matrix, accuracy score again from sklearn. These are various machine learning models: KNN classifier, linear discriminant analysis, Gaussian naive Bayes, and support vector machine. Okay, so we are importing all these models from our scikit-learn library. Okay, so let's execute it. Our next step is to load the dataset. So the very first parameter that I'm passing up here is the URL of my dataset. Okay, or the path of my dataset basically. So there's my data set, just to show you. So this link consists of my dataset. Okay. Next, I'm defining an array as names. This consists of the name of the attribute, sepal length, sepal width, petal length, petal width, and class. Okay. And next, I'll be defining a variable as dataset. And next, I'm defining a variable dataset. So dataset equal pandas.readcsv URL comma names equal names. So what it is basically doing, it is fetching the data from here, from this link, URL from this URL, and it is giving the name of the attribute as all these: sepal length, sepal width, petal width, and class. Okay, so this will basically load your data set. Fine, let's execute it. So our data set is loaded. Now let's summarize the data set. Now let's check how many rows and columns do our data set have. So let's execute this and check the shape of our dataset. So our dataset consists of 5 different columns and 150 rows. Okay. Next, if you want to check the sample dataset, then you have a head function over here. So this will give you first 20 result of your dataset. Okay, 0 to 90. Fine. Next is the dataset.describe function. So this will give you the various description from your dataset, like count, mean, standard deviation, minimum, percentage, 25 percentile, 50 percentile, 75 percentile, and max. So count is basically the total count of sepal length, sepal width, petal length, and petal width. Okay. Similarly, mean of all, similarly standard deviation, and so on. Okay. Next, what if I want to check how many different classes are there, or how many values contains in each class? So we'll group by the class and we'll find the size of each class. Okay. Let's execute it. So we got the output up here as iris setosa 50, iris versicolor 50, iris virginica also 50. So this means that we have 3 different classes: iris setosa, versicolor, and virginica. All 3 of them consist of 50 values. Okay, fine. So next is data visualization. So now that we have some basic idea about our data, let's create some visualization out of it. So we are going to look at 2 different types of plot. The first would be a univariate plot, that is to understand about each attribute, and next would be the multivariate plot to understand the relationship between the attributes. Okay, so first let's plot a univariate plot, that is plot of each individual variable. Okay, so this is the univariate box and whiskers plot. So let's consider just sepal length. So the bottom part of here, this represents the minimum value, and this is the maximum value. Okay, and this green bar over here, it represents the mean value. So if you see the mean of sepal length, it's around 5.84. It's also representing the same. So it's 5.84. Okay. These circles above and below the minimum point are nothing but the outliers. Okay. Yeah, one more thing, the minimum and the maximum value, right? So minimum is 4.3 for sepal length and maximum is 7.9. Okay, so the minimum value you got up here is 4.3. Okay, so this is my 4.3 minimum value, and here we have the maximum value as 7.9. Okay, and these are the outliers, these circles. Similarly for sepal width, my minimum value was sepal width was 2.0 and maximum 4.4. So minimum from here is 2.0, this value, it's an outlier, and the maximum value is 4.4, this value 4.4, it's also an outlier. And the mean value of sepal width is 3.05. So we got mean somewhere around here. Okay. So in order to understand our data in a better way, we created a univariate box and whiskers plot. Okay. This gives us a much clearer idea about the distribution of the input attributes. Okay. Well, if you want, you can even create a histogram of each input variable to get an idea of the distribution. Okay, so let's execute it. So there's my histogram. So in sepal length and sepal width, I can find the Gaussian distribution up here. Okay, so this is a useful to note as we can use algorithms that can exploit this assumption. Okay, next we have is the multivariate plot. Well, multivariate plot is used to check the interaction between the variables. Okay, so let's just execute it and see what's the output. So here's a scatter plot of all pairs of attribute. So this can be helpful to spot structured relationship between input variables. Okay, so as you can see, we have diagonal grouping of some pair of attributes. So this suggests a high correlation and a predictable relationship. Okay, so from here you can say that sepal length is more dependent on sepal width as compared to petal length and petal width. Similarly, same thing over here, right? So petal length is more dependent on sepal width as compared to sepal length and petal width. Okay, and the petal width, it's more dependent on sepal length as compared to sepal width and petal length. Okay, so these are the things that we can conclude after visualizing our data. Okay, now it's time to create some model and estimate their accuracy on unseen data. Okay, so here we'll follow step-by-step procedure. Okay, first we'll separate out a validation dataset, that is divide our dataset into train and test part. Then we'll use a tenfold cross-validation technique that will randomly distribute our data into 10 different datasets. Okay, so that we can perform training and testing on each part. Then we can finally combine the result of all of them to get a better accuracy. Okay, then we are gonna build 5 to 6 different models to predict species from flower measurement. Okay, and then finally we'll select our best model. So our first step is creating a validation dataset, that is dividing our dataset into train and test. So here what we are doing, dividing our dataset into train and test. Fine. Array equal dataset dot values. So it consists of all the values inside your dataset. Here you're defining x equal array starting. So here you're taking a portion of the array, okay, and you're placing it in x. So what is that? So your row up here is nothing. So it will start from the very first row and the column 0 to 4. So it will take up to fourth column. So 4 column from the first row, that is x is storing all the name of the attribute. Fine. Similarly, we are defining a variable y. So y will consist of the fourth column. Next, I'm defining a variable y, array of starting from first row and fifth column. Okay, as 0, 1, 2, 3, 4. So here number 4 represents my fifth column. Okay. Next, I'm defining a validation size as 0.20. So here validation size means it will split my data as 80% in one part and 20% in other. Okay. So next we are defining a seed value. So this seed value is used to initialize a randomization. Saving or setting it to same number each time guarantees that every time you execute the algorithm, it will come up with the same result. Okay. Next we are defining scoring as accuracy. And here we are defining x train, x validation, y train and y validation. So here we are defining x train, x validation, y train and y validation. So x train would be my training data from this part and x validation is the testing data from same. Okay, so according to my above code, my 80% of the data will lie in the training part and the rest 20% would be treated as a validation data or the test data. As I have already mentioned, the validation size is 0.20 or 20%. So this means that 20% of my data is test data. Fine. Similarly, we'll define y train and y validation. That is 80% of the training data from this array and rest 20% of the testing data from same array. Okay, so here we are basically splitting our data set. Okay, on the base of x, y, test size equal validation size that we have already specified as 0.20 and my random state equals c and my random state is c. So every time I execute it, the algorithm will come up with the same result. Fine. So now that we have created a split among our dataset and we have divided our dataset into train and test, so our next step would be to build our model. Okay, so this is how we are building our model. Okay, so from the scikit-learn library, we are calling logistic regression, we are calling linear discriminant analysis, KNN, decision tree, Gaussian Bayes and SVM or support vector machine. Okay, here what we are doing, we are creating 10 folds. Okay, so 10 folds, let me just go step by step. So here we are defining a variable as k-fold. So k-fold equal model underscore selection. K-fold, how many split we want to perform is 10 split and random state again c, that is 7. So every time it will perform the same random split. Okay, so this is how my data would be splitted into 10 different parts. Okay, now once the data is split into 10 parts, then we'll define a variable as cv underscore results. Okay,
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.
so cv underscore results equal model selection dot cross validation score. Inside that we are passing our model, what model we are choosing. We are passing the x train data, the y train data, cv equal k-fold, whatever the value of k-fold is there, and then finally scoring, which we have initialized up here as accuracy. Okay, then what we are doing, we are appending our result. So our cv result would be appended to results, that is to this list. So next we have is result dot append cv underscore result. So this list would be updated with the cv underscore result value, and here we are appending the name, and finally we are printing our desired result. So one by one this will go in a loop. Okay, so every time this loop execute, you will get the accuracy of one of the model. Okay, so here right now our model consists of all these values, okay, as we are appending it. That is, we are adding all these values one by one to our model. It consists of logistic regression, decision tree, Gaussian naive Bayes, and support vector machine. All of them are in our model, okay. And finally, it is printing the message. Let's check the output. So we got the output as this. So here the accuracy of a logistic regression is 0.96, that of linear discriminant analysis is 0.97, KNN 0.98, decision tree 0.96, naive Bayes 0.97, support vector machine as 0.99. So from this we can say that support vector machine is having the highest accuracy. Okay. So now our next step would be to compare the algorithm and select the best model. So just by looking at this output, we can say that support vector machine is having the highest accuracy. But let's compare all these algorithms and see which one fit the best. So for that, I'll be plotting a box and whiskers plot for the accuracy versus the name of the algorithm. Okay. So there's my algorithm comparison. Here I have the name of my algorithm and this is the accuracy for them. The green point which you can see up here is nothing but the mean values or this value. Okay. For linear regression, I had 0.96. For linear discriminant analysis, I had 0.97 and so on. So from this graph, what I can say is KNN, naive Bayes and support vector machine. These are having the highest accuracy, okay, as there is no minimum and maximum value, only they are having a maximum value and few outliers, these outliers, okay. So in case if you are removing these outliers, like this one, these two and this, so by removing them, KNN will give you the 100% accuracy result. By removing these two outliers, naive Bayes would give you the highest accuracy result or 100% accurate result. So even in case of SVM, if you remove this outlier, you will get a model with 100% accuracy. Okay. Now next is making the prediction. Well, just accuracy shouldn't be your metric to decide that this is your best model. Okay. So for selecting a model, you have several other features which you should decide apart from accuracy. Okay. So your accuracy will not always be the metric to select the best model from. Okay. So let's move ahead and see how to make the prediction. So we have already calculated the accuracy, right? So now from this graph, we know that support vector machine is giving the highest accurate result even with the outlier. If this outlier is removed, then it's the best one. Okay. Now let's make some prediction on it. Okay. So let's execute this. So here we are printing the accuracy score, we are printing the confusion matrix and the classification report for Y validation and prediction, that is testing and predicted value. So here we are printing the accuracy score for the tested value and the predicted value. We are printing a confusion matrix for the tested value and the predicted value, and finally a classification report, same for the tested value and predicted value. So if you check the score for tested value and predicted value, like accuracy score while using SVM or support vector machine is 0.93. So there's my confusion matrix up here. And finally, we have a precision, recall, F1 measure and support data for all these three classes: iris setosa, iris versicolor and iris virginica. So let me just explain you what is precision, what is recall, what is F1 score and support. So this precision, it tells how accurate or precise is your model. That is, out of those predicted positive, how many of them are actual positive. So this is precision. Okay. Next is recall. It calculates how many of the actual positives our model has captured through labeling it as positive. Okay. Next is F1 score. It is used when you want to seek a balance between precision and recall because of a large number of actual negative values. Okay. And finally, we have support, which is the number of sample of the true response that lies in that particular class. Okay. So while predicting with SVM, we had 7 true responses in case of iris setosa, 12 in case of iris versicolor and 11 in case of iris virginica. Okay. Similarly, I made prediction using SVM model. If you make prediction using KNN, you'll get a different result up here. In this case, we got the accuracy as 0.9 and the precision score, recall score, F1 score and support score all are different. Okay. So here in case of KNN algorithm, you can see that we have the accuracy as 0.9 or 90%. The confusion matrix provides an indication of the 3 errors that we made. Finally, the classification report provides a breakdown of the class by precision, recall, F1 score and support. Okay. So we use Python to create few machine learning model and select the best model out of them. So our best fit model is SVM, as it is giving the highest accuracy and high values of precision and recall. Okay.
So in this session, we'll take a look at what machine learning is and how you can use scikit-learn, which is one of the most popular libraries in Python for machine learning models, to use scikit-learn package to build models that could classify the data that we send to it. So now let's take a look at what is classification, because that is the kind of model that we'll be building. I'd like to help you understand what classification is. For those of you who are unaware, classification is a machine learning technique that comes under the supervised learning technique. In supervised learning technique, um, you can build regression models as well as classification models, and we'll be taking a look at classification. I'll also explain what regression is. So let's take a look at what is classification. So in machine learning, classification is simply an activity that consists of putting things into the categories based on the similarities or common criteria. If I give you a lot of people who have applied for the loan, who have applied, if you're working in a banking industry, you need to help understand them what are the kinds of transactions that could lead to fraudulent transactions, and to do that you can take in some data about the transaction, the date, the time, the username, the user's credit score, so on and so forth, and using that you can figure out whether or not this transaction is fraudulent or not. So that is the classification problem. When you already have some categories defined and you want to place the incoming data into one of the categories, so there are a fixed set of outputs that your input can map into. So for instance, our digit recognition is a classic example of classification, in which what we do is we take in an image, we analyze it, and we figure out whether or not it contains which number does it contain from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, any one of those. So there are 10 possible classes that our input could go into, and that's what we do in classification. So that's what classification is. Another problem could be regression. Regression is basically when you're trying to predict a continuous value. So think of it this way: when you're trying to predict a continuous value would be, you're trying to predict the temperature, you're trying to predict the housing price based on the features that you have, you're trying to predict the stock market price. These are continuous values because it could be a number in fraction, it could be a whole number, it could be a lot of things. There's no particular categories that you can put this into. So
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
that's regression, and we're learning classification here. So that's the difference between those. So let's take a look at common classification problems. The first is character recognition. So if I give you if you've used anything like Google Lens, you probably know what character recognition is, in which it takes a look at an image and figures out what are the things that are written in that image. So it could be that it figures out what's written on a board, it could be figure out what's written on a piece of paper, so on and so forth. That's character recognition. Then comes face detection. So if you are unaware of what face detection is, if you ever used a mobile phone with a camera, you put someone's face in that camera and it creates a bounding box around it to help you help it focus on the person's face, and that's what face detection is. Face detection and face recognition are two different things. Face recognition is understanding who that person is. So in face recognition, what we do is, good example of it is that is the feature that Facebook has deployed, in which you upload an image and it understands whose face is in these images, and then gives you the person's name around the bounding box and tags them automatically. So that's face recognition. This is face detection. Then comes fraud detection. So if you work in the banking industry, fraud detection is something that is used. Fraud detection is something in which machine learning is used quite a lot. It takes a look at a lot of transaction, users' credit scores, so on and so forth, and understands what are the different transactions that could be considered fraudulent. Finally, we have intrusion detection. This is used in cybersecurity. What they do is they take a look at a lot of logs that it has and takes a look at the activity that was performed by particular IP addresses or a range of IP addresses in those logs, and understands what are the IP addresses that have tried to intrude in our system. And if it looks like a person, if it's classified as a person who's trying to intrude in our system, we blacklist their IP addresses, we report them to the authorities. That's the kind of thing that we do. Yeah, so someone has asked, how do we use machine learning in this aspect? Are we using Jupyter in the aforementioned uses of machine learning? So Jupyter Notebook is a software that we'll be using, but machine learning statements don't really care about how you're creating those. Jupyter Notebook is really useful because it allows us to bundle up code with explanations and the output of the code all in one place. So that's why we use that. But if you were to use plain Python scripts, that would work fine as well. All right, so now we'll move on to the next section, in which we'll take a look at some popular classification algorithms. First one is logistic regression. So in logistic regression, we learn from the data, and with that we use a log loss function, and we try and make a prediction about the probability of some particular data point being in one of the following categories that we have. So for instance, in our digit recognition example, what we do is we have 10 different categories, and what logistic regression would do is it would take a look at all the data points that we have given it, and figures out a probability that each data point belongs to one of the following categories. So for instance, if I give it an image that contains 7, it will pick a probability of, let's say, around 0.05 that it's 1, 0.4 it's 2, 0.3 it's 3, and it goes along so much. And finally, when we go to 7, it has given the probability of 0.9, which is the highest, which means that logistic regression algorithms give us a bunch of probabilities, and the one with the highest probability is the one that we should choose. So that's the basics of it, and that's how it makes the prediction. Okay, so now let's take a look at the other one, which is decision tree. In decision tree, it's very easy to conceptualize. What it does is that it takes a look at the data that we have, figures out columns and values in those columns, and tries to split the data on that. So if I give you, let's say I give you the temperature. I want to figure out whether or not tomorrow it's going to rain or not. So it's going to be classified as either rainy or sunny. In that scenario, we give it the data, it takes a look at the data and figures out what are the different what are the different columns that we have, or the features that we have, and using those features, how can we split the data so that we can make the decisions better. So for instance, if it takes a look at the temperature previous days, and then figures out whether, okay, so in the previous days the temperature was 37 degrees. So on 37 degrees, whether if it's higher than 37 degrees, then it takes a look at other features, and if it's lower than 37 degrees, it takes a look at some other features. And doing that, after looking at all the features and coming up with these rules, it figures out, okay, the final answer that I can give you is yes, it's going to rain, or yes, it's going to be sunny. So then we go to random forest, and the random forest uses multiple decision trees to increase the accuracy of the decision. And after getting the results from all the decision trees, the result that has the highest frequency in the decisions that it is gotten from the decision tree is the one that's chosen. So if we get 5 decision trees, and all out of 5 of those, 3 of them predict that the number inside an image is 7, and others predict the number inside an image is 1, 7 is the output that's given to us. And then comes naive Bayes, or naive Bayes, however you pronounce it. It's the kind of algorithm that is used by using a probabilistic model. Inside naive Bayes, what we do is we take a look at the probability of something being mapping to a particular class. It comes up with probabilistic heuristics, and then tries to figure out how to use those probabilistic measures to use it. Now, in case you didn't understand a lot of these algorithms, it's fine. These algorithms do take a lot of time to digest, to understand, to implement. And as you can see that it could take you a lot of time to understand these algorithms, as well as to write these algorithms. It could be very difficult for you. So keeping that in mind, we use scikit-learn because it contains all these algorithms pre-written for you. So you could just take the data, use these algorithms that have already been built for you, and then figure out what's the accuracy and how well it predicts your data. So now we finally come to scikit-learn. So what is scikit-learn? Scikit-learn is a free open source machine learning library that contains generic implementation of common machine learning algorithms. So as we've already discussed, there are a lot of algorithms that you can use in order to build a machine learning model, but writing those algorithms from scratch on yourself by yourself is going to be really difficult. So using instead of that, what we do is we use scikit-learn. Scikit-learn allows us to allows us to import the algorithms ourselves after understanding the data, and we can just use those algorithms that have already been pre-written for us to implement our model instead of us having to implement the algorithms ourselves. Since they are common algorithms, they have been implemented by people already. Okay, so now the thing that we have to understand is that it contains a lot of functions to perform commonly used operations. So it doesn't just contain the machine learning algorithms that we want to use. It also contains a few functions that we use a lot. So for instance, if we have some data set and we want to split it into a 70-30 ratio, it has a function for that. If you want to figure out if you want to validate our data set against different distributions of data, it has a function for that. If you want to generate a confusion matrix, it has a function for that as well. So there are a lot of things that it covers. It doesn't cover everything, but it has a lot of functionality out of the box that we can use. All right. So with that, I have another question for you guys. Hopefully, if I show it to you on the polls, you'll be able to see it. Okay. So now I think you can see the question. For those of you who are unaware, the question is, can you build a machine learning model by only using scikit-learn and no other library? So if you are not using any other library other than scikit-learn, can you build a machine learning model? When I say no other library, I mean you are not able to use Python as well you are not able to write, you are not using any other thing other than scikit-learn. So for all the tasks involving machine learning and everything, can you use scikit-learn only? So the answer that options that we have is yes and no. So I'll wait for the answers, and once I've gotten all the answers, I will tell you the correct answer. So I encourage everyone who's participating in the all right, majority of you have answered, and the options that were available were yes and no. I'd like to tell you the correct answer, which is for the question that can you build a machine learning model with only using scikit-learn and no other library. The correct answer is yes, you can. The people who have answered no, I'm assuming that you guys were thinking that because we have to use Numpy or pandas or other libraries like that, we could probably not be able to build a model without using those libraries. The thing is, you can build a model without using those libraries, but you would have to do a lot of coding yourself. You would have to import the data, parse it, split it, and then use it inside the library of scikit-learn. But only using scikit-learn, you can build a machine learning model. It's just going to be really difficult, and without using scikit-learn on any library, it's going to be even more difficult. So the correct answer is yes. For those of you who have answered yes, you were correct. For those of you who answered no, you were incorrect. But depending on how your thought process went, you were really close. All right. So now let's move ahead. I've closed the poll, and now let's take a look at why should you use scikit-learn. First of all, it's very easy to use. Scikit-learn is extremely easy to learn and use, and it makes the task of implementing mathematical algorithms really easy because it contains all the implementation with it. We just have to understand how to use the classes and the functions available in the library. It's very well documented. It's got an extensive documentation that contains information about how to use every available feature in the scikit-learn library. And using that, we can take a look at that. Then it's been created by experts. So scikit-learn is a library that has been created by expert data scientists who have been inside the data science business for a long time. They have written these algorithms themselves, and these people have been writing algorithms that are relating to data science from their hand for a long time. So they know how to make a generic implementation that many people can use. And finally, it's very well tested. It's been used by several developers across the world who contribute patches and bug fixes. Scikit-learn is an open source library, so if you want to take a look at the code underneath the hood, you can just go to GitHub, search for scikit-learn or sklearn, and you can get the library code yourself. If you find some problem or want to help scikit-learn grow and add some features to it, you can use GitHub to add some features in the code that the scikit-learn has, and then suggest a revision to the developers and maintainers. Because it's open source, many people have already found a lot of bugs and submitted a lot of bugs. So that means it's battle tested as well, and it has seen a lot of issues already. Now let's take a look at steps in building a classifier. This is an important concept, right? So now let's take a look at steps in building a classifier. So there are 5 steps in building a classifier, but there are several steps in building a classifier. 5 to be exact, but depending on how you're training a model, it could be more and could be less. Usually these are the 5 generic steps that are used. The first thing is we import the libraries. So if you're using sklearn, numpy, pandas, you import it. Many people import it throughout their code. So as soon as they need something, only then they'll import it. I like to import everything at the top of my file so that everyone who's using my application knows, or looking at the code that I've written, knows what are the libraries that my code depends on. So you can firstly import all the libraries needed to train and build the model that you need. And these libraries can perform tasks ranging from numerical manipulations, such as NumPy, and testing the accuracy that we'll be using scikit-learn for. All right. And then what we do is we import the data set. So data set is the data that we will be training our model on. It's important to understand what data set we'll be using and how we'll be using it. So that's how we firstly need to import the data set, or we can, after importing the data set, we view the data set, we load it, we manipulate it so that it's clean and it's in a state that we can use it to train our model and do the following steps. And after that, we can use it in machine learning models. After that, what we do is split the data. So when we get the data set, its X and Y variables are right with each other. So the thing that we are using to make the prediction and the prediction itself are right inside the data. First, we split that. And then we split our data into a training and testing set. Training set is used to train the model, testing set is used to test the model, and using that we understand what is how the model has learned and what is the accuracy that it's giving us. Then comes training the model, which is the task of the scikit-learn library. It creates an algorithm and allows us to feed it data so that it can learn from the data. And after learning from the data, it can do the classification or regression tasks that are needed. Finally, we test the model. We give it the data that we had set aside for testing. After giving it the data, we ask it to make the classifications, and depending on how many were correctly classified, we give it a percentage from 0 to 100. Higher percentage means our model is more accurate, lower percentages mean it's less accurate. What is the max percentage of a model accuracy? The max percentage is 100%, but no model can be expected to have 100% accuracy. If your model, when training or testing, it gives 100% accuracy, it could be that your training set is too small. That is, it either contains only 10, 20, 40, or 100 values, or it could be that your training set is overfitted, which is the variance issue that we have talked about recently. So you need to train your model again, and if it sees some data that it hasn't already seen, it will give poor results. Someone has asked is some more detail on splitting the data set and why and how. So splitting the data set is basically the task when we get the data and we want to set aside some data that our model can be trained on, and the remaining data is used to test whether or not our model is giving us correct accuracy. So as in supervised learning, we already have the data and the output that it should map to. Once we feed in the data and we take a look at the predicted output and the correct output, the percentage of outputs that match are the ones that are correctly classified, and the ones that are correctly classified are the outputs that lead to higher percentage of accuracy. So someone has asked to explain some example on training the model. Training the model basically means just taking the algorithm from the scikit-learn library, feeding in the data, which is the x and y variables that we have created for training. Then that data, that algorithm learns from the data, and after that we can make predictions using it. We'll take a look at that in the demo. All right. Hopefully you can see the question. The question, yeah. So the question is, which set is used to validate the performance of the trained model? So once the model has been trained, which set is used to check whether or not our model's accuracy is good? So I'll wait for a few moments and you guys can answer in the poll and submit your answers. Whether it's training set or testing set. Training set is the first option. Testing set is the second option. All right. In the meantime, people have asked a few questions. I'd like to answer those. Someone has asked, what is the ratio to split the training and testing set? So for training and testing, you can split the data into, depending on how large your data set is. If it's really large, like you have millions or billions of rows, then you can just take 1% or 10% of your data. If it's a small data set, then 70-30 is a good ratio to split your data on. It's testing set, which is the correct answer. The training set is used to train the model. The testing set is used to figure out whether or not the answer is whether or not the model is performing well, which is why we use it. And let's have our hands-on. We'll have a demo here. So I already have prepared a Jupyter notebook for you guys in which we perform all the 5 steps. So let me just first explain what we're doing. We're using the iris dataset that contains information about flowers. It contains information about the sepal length of a flower, sepal width of the flower, petal length of the flower, and petal width of the flower. Using these 4 features, we're trying to predict the kind of flower that it contains, or kind of the iris flower that it's containing. There are 4 kinds of flowers that our dataset has. 3 kinds of flowers that it has: Virginica, Setosa, and these are the different kinds. So what you do is, firstly we import all the libraries. As you can see, the libraries were easily imported, so it works fine. And from sklearn, I'm importing the load iris function that will get us the dataset. It's a very common dataset, and so that you can follow along with me and you don't have to wait to load the data from some remote data source, you can just use this code that I'm showing you on my screen right now. And then we are using the train test split function, which we'll use to split our data set into the specified ratio. Someone has asked, can we try it on Google Colab? Yes, you can try it on Google Colab. That's a very good use case for Google Colab actually. So if you want to use Google Colabs, or if you want to use your local notebooks, you can use those as well. Okay. With that, we have train test split, which is the function that is used to split the data. We'll be using the logistic regression model, which we can import from sklearn.linear model. And finally, we will be taking a look at the accuracy score as well. And scikit-learn already gives us a function that does it for us. I'll be more than happy to answer you on the questions that you ask about the code that you're watching. If you want to follow along, you can type in the code in your Jupyter notebooks if you have it. If you don't have Jupyter notebook, then it's going to be difficult for you. You can use Google Colabs. That's a really good option for you to try if you want to follow along. So now let's take a look at it. So someone has asked that they need to import the data set. Should they need to import it with its name? So we are using the load iris function, and using that you can just import it. You don't need to specify any name. If you have a CSV file on your local system, importing that, you would need pandas library and need to know the file and the example. Okay. So now we load the data set. But now let's take a look at what the shape of the data set is. As you can see, it's a dictionary. Dictionary is a key value pair. It's a common Python data structure. It contains a key of data that contains all the data. And it's 5.1, 3.5, 1.4, 0.2. These are individual rows in our data set. Now, we don't know what these values mean. So taking a look at the data, we have targets as well. Targets ranging from 0, 1, and 2. Now let's take a look at the target name. These are the different types of flowers that we'll be predicting. These are the categories that we'll be predicting. Setosa, versicolor, and virginica. So 0 means Setosa, 1 means versicolor, 2 means virginica. The reason why we have encoded them into numbers, it's because machine learning algorithms only understand numbers. They don't understand words or strings or letters or sentences. So we need to first convert those numbers into letters in classes into numbers, and then we can make the prediction. And now for our columns, we want to be able to understand what are the different columns that we have. And what we get here is we get the sepal length, sepal width, petal length, and petal width. So it's given us the example of what we have. So feature names are, the first column has sepal length, second column has sepal width, third column has petal length, fourth column has petal width, and all of them are in centimeters. So that helps us understand the data. Now it's time to split the data. We'll split it in X and Y. We'll be using these features, and using those we'll be predicting these targets 0, 1 or 2, which map to setosa, vesicular or vaginica. So with that, after splitting the data, I try to split it into 70-30 ratio. So let me just explain what that means. Using the data set that we have, the data.data, the data key inside it contains all the data that we need. So let me just show you what the size of the data is. If I insert a row below and look at the length of X, we have 150 rows there. Now if I split it into a 70-30 ratio, right? And now if I insert a row and I print the length of X train, we have 105. So 70% of 150 is 105, and remaining 45 are for testing. So we will use 70% of our data for training, 30% for testing. And with that, we create a logistic regression model. This is a class in sklearn. It just takes in the logistic regression model and creates an object of it. We use the fit method to fit our data. Fit basically means train our data. We pass in the training X variable and training Y variable. So the 105 rows that we have created for testing, we pass it inside our training and testing set. If you're following along, if you want me to scroll up to help you look at the code, this is what the first line, first things we import is. Then we load the data set. You only need to write this code. This is just for explanation. This is markdown format, so you don't need to copy that. After we have trained our data, since our data set is small, it trains in a few milliseconds. Now we make the prediction. And after the predictions are made, we take a look at the accuracy, and accuracy is 88%, which is quite good. Because machine learning models use statistics, these accuracies could change. So if I train it again and then I check it again, it's giving me 100% accuracy because our data set is too small. And now it's giving me 91% accuracy. So it's giving us high accuracy, but the accuracy is variable. The reason why is because depending on how data is split. When we split the data using train test split, it splits it randomly. So it takes a look at 45 values randomly and splits it into another 45 and 105 random values from the entire data set, and then we can train the model. So someone has asked, is face recognition classification or face recognition is a supervised learning problem. It's a classification problem, but it takes a look at very different technologies that are not just part of classification. It takes a look at computer vision, handling the data. There are many other different kinds of things. Face detection is a classification algorithm. Face recognition is a system that uses classification algorithms along with other algorithms as well. Is computer vision an area of ML? Yes, it is.
So what is Numpy? Well, a Numpy is a most widely used Python library for linear algebra. It is used for performing mathematical and logical operations on multi-dimensional array. Numpy consists of various set of functions that can be used while performing your mathematical and logical operations. So this was about what exactly it is. Now the question arises, how to create a Numpy array? Well, we have shown some basic example up here, how to create a Numpy array. So we have created 1D array up here and 2D array. Let me show you this example in my Jupyter notebook. This would make things more easier for you to understand. So this is my Jupyter notebook. So the very first thing that I'll do up here is define my one-dimensional array. So how to define a 1D array? So for that, the very first thing that I have to do is import my Numpy library. So I'll be importing Numpy as NP. Why I'm using NP up here? So it's just because whenever I want to call some function of NumPy, I don't want to use NumPy every time. So apart from it, what I can do, I can just replace the word NumPy by NP. So once you have imported NumPy as NP, let's define an array as a equal np dot array. So here instead of writing numpy dot array, I can just go ahead and write np dot array. That's it. Okay. And inside the array we'll pass list of arrays. Okay, like 1, 2, 3. Okay, and print a. So this is how my 1D array looks like. Now let me show you how you can create a 2D array. So let's create a two-dimensional array. Again, let's import numpy as np. Let's define an array as v equal np dot array. Inside array, what do we pass? List of function, right? So let's pass 1, 2, 3, comma 4, 5, 6 and print b. I'm telling you this will generate an error. Just think why. It gave you an error of data type not understood, right? So why do you think you are getting up this error? Any guesses, anyone? Think. Remember what I said up here. What do you pass an array? List of array, right? So where is array up here? It's a list, but we have to pass a list of array, right? So you'll enclose everything in opening and closing square brackets. So this would resolve your error. Okay, so this is how you got the final output as 1, 2, 3, 4, 5, 6. So this is how you create your two-dimensional array using NumPy. Okay, how to initialize a NumPy array. Okay, so let's start. Well, there are several methods of initializing a NumPy array. Let's discuss them one by one. So first we have is initialize an array of x cross y dimension with all the values as 0. So let's check back in the Jupyter notebook. So what we need to do is initialize all the elements of x cross y array to 0. Okay, let's see how to do it. So here let's import the numpy. Import numpy as np. Now here I'll be using a function zeros. Well, this function is predefined in numpy. Well, this is used to initialize all the elements of an array to 0. Okay, so np.zeros, zeros. Inside this, it takes a list of list. So inside this, what I'll pass up here is the size of my array. Let's take the size of the array as 3 cross 4. Okay, that's it. You don't need to do anything else. Mention the size as 3 cross 4. Let's execute it. So here you got the output as 3 cross 4 matrix, 3 cross 4 matrix with all the elements initialized to 0. Okay, now let's move ahead and see our next example. Our next example says up here is arranging the numbers between x and y with an interval of z. So let's see how. So here what we have to do, arrange the numbers between x and y with an interval of z. Okay, so let's see how we're gonna do it. Again, import numpy as np, and the function we'll be using up here is arrange, arange. Okay, inside that we'll pass 3 parameters, First, the starting point, next, the ending point, and next, the interval. Suppose I want the interval of 2. So I'll write 2 up here. Okay. So here, arrange the number between x and y with the interval of z. So here, x is 1, y is 10, and z is 2. Fine. So let's execute it. So you got the output as 13579. So what is the output? So the output is all the numbers between 1 to 10 with an interval of 2. Okay. Now let's just change these number and see what difference does it make. We want to print all the even numbers between 10 and 20. So let's see how we can do it. So here we are printing even numbers between 10 and 20. Okay. Just to tell you, you don't need to import Numpy every time you're doing it. Okay. I'll just show up here. If you're not importing Numpy, it won't throw an error because Python is executing every statement line by line, right? So here Numpy is already executed, so I can use NP up here. I'll just write NP a range inside this. It should start from 10, right? And it should go till 20. And the difference should be 2 as we are considering the even numbers, right?
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So if you see the output, you'll get all the numbers between 10 and 20, but the number 20 would not be included up here. So it's like 10 till less than 20. Okay. So you got the output as 10, 12, 14, 16 and 18. Okay. Fine. Now let's get back to our PPT. So next we have is arranging z number between x and y. So now our x and y values are fixed, but what we have to do up here is arrange z numbers in between them. Okay. So here what we are going to do, arrange z numbers between x and y. Okay. Let's see how to do it. So for arranging z numbers up here, we have a function as line space. So you can call np.linespace. It's not line, okay? It's lin. Don't make this mistake. Fine. And after that, what you'll do, you'll specify the first number and the ending number. That is the value of x and y. And how many numbers you want between them. Suppose I want 10 numbers between 5 and 10. So let's see what is the output. So I got the output as array of 10 numbers between 5 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Let's take one more example of line space up here. Now again, let's print some even numbers, like even numbers between 0 to 10. Okay. So here I can write np.linespace. Inside this, the number should start from 0. It should go till 10. And how many numbers I want in between? It's 0, 2, 4, 6, 8 and 10. Right? So how many numbers? 6. Okay. So let's execute it. So we got the output up here as 0, 2, 4, 6, 8 and 10. Clear? So this was about the line space function and how you can arrange z numbers between two fixed values of x and y. Okay. Let's get back to our PPT. So we have already discussed these examples. Let's move ahead. Next example we have up here is filling same number in an array of dimension x cross y. So it's like I want an array in which all the elements are initialized with the same number. Let's see how we can do it. So what I want to do, filling same number in an array of dimension x cross y. Let's see. So again, I won't be importing Numpy up here. I'll just write np dot. So for filling the same number, we have a predefined function as full. It takes two parameters. First, the dimension of the array, and next, the element you want to fill in. So suppose my dimension of the array is 2 cross 3. Okay, and what value I want to fill in? Let's say I want to fill all the values with 6. So let's execute it. As you can see, we got the output as 2 cross 3 array with all the values initialized to 6. Okay, let's move ahead. Next we have is filling random numbers in an array of dimension x cross y.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So now, what if I want to initialize my array with some random numbers? So how can I do that? Well, for that, you have a random function in Numpy. Let's see how you can do it. Here we are filling some random number array of dimension x cross y. Okay, so let's see how we can do it. Okay, no point of importing numpy. So the numpy function I'll be using up here is random. I'll just write np.random, okay, dot random values in an array of dimension, suppose 2 cross 3. So it will create me a 2 cross 3 array with all the random values in it. Let's see the output. So as you can see, we have a 2 cross 3 dimensional array with all the different random values. Correct? Let's move ahead. So this was all about how you can initialize a NumPy array. Okay, NumPy array inspection, and we'll see how we can inspect various aspects of a NumPy array. Okay, so let's start it. So the very first thing we got up here is ndarray.shape. Well, this shape function is used to return a tuple consisting of array dimension. It can also be used to resize the array. Let's check the shape of our array. So what we have to do up here is inspecting the array. So in this, basically what we are doing is checking the size of the array. So let's define an array up here like a equal np.array. Let's define our array as 2, 3, 4, comma 4, 4, 6. Is it correct? Or am I missing something? Remember these square brackets at the beginning, right? So you have to add these square brackets if you want to avoid the errors, because you have to pass a array up here. Now I have defined my array. So now what I want to do, I want to check the size of my array. So I'll just write print a.shape, execute it. So you got the output up here as 2, 3. So it means it's an array of dimension 2 cross 3. Okay, so what if I just change my array? Okay, so let's just define an array like s equal np dot array. Let's define an array of different dimension like 1, 2, 3, 4. Another 2, 3, 4, 6. Let's define one more 6, 7, 8, and 9. So what do you think would be the dimension of this array? Guess the output. Any answer, anyone? We have 3 parameters up here. Let's just compare these two values. So here we had 2 set of arrays, right? And 3 elements in each array. So while printing the shape, we got the output as 2, 3, right? 2, 1, 2, 3. So what do you think here the output will be? Well, here we have 1, 2, 3, 4. 4 elements in each array. And how many arrays we have? 1, 2, 3. So what do you think the output will be? 3, 4, right? So we'll get the output as 3, 4. Just add these square bracket in the end. Okay, execute it. At a.shape, we have to print s.shape, right? So you got the output as 3, 4. Correct? Now what if I want to resize my array? So what you're going to do up here is resize the array, right? Okay, Let's see how can we do that. For that, let's just copy this array up here. Okay. Well, even if you don't specify it, that won't be an issue, but don't worry, I'll discuss it later. So for now, let's define the same array. And as we know, the shape of this array was this 2 cross 3, right? Now, what if I want the shape to be changed as 3 cross 2? So what I'll do up here is I'll just write a dot shape and I want to change it to 3 cross 2. Okay. Now let's just print the value of a. Let's execute it. Okay. So we got the value as 234446. 234446. Okay. So it just resized the array and changed the dimension. Okay. Let's see one more example. Let's change the dimension, like for here let's write 2446. Okay, now how many elements do we have? 1 2 3 4 5 6 7 8 elements we have. So now I want an array of dimension 8 cross 1. So since 8 elements are only there, so 8 cross 1. So now I'll get the output as 2 3 4 4 2 4 4 6. Okay. But yeah, you cannot just write random numbers up here. It's like if you'll write 8 comma 2, you might get an error in this case as no elements are there. So you got an error of cannot reshape array of size 8 into shape of 8 comma 2. Since the number of elements that you have is just 8. So maximum what you can have is 8 cross 1. Okay. So similarly, you can also get for 4 cross 2. It will be correct. Okay. So the trick up here is, let me tell you the trick, hashtag trick. The multiplication of these two numbers must be equal to the total number of elements. Okay, so x multiplied by y should be equal to total number of elements in the array. Okay, so 4 cross 2, 2 cross 4, or what else? That's it, right? The factors of 8 are 2, 4, 8, 1. We tried with all. Okay. Let's just change it to 8, comma 1. So there's the output. Got it? So this is how we are resizing our array. Fine. Next, what if I want to check the dimension of my array? How will I do that? So just now I checked the shape of my array. Now what if I want to print the dimension of my array? So how will I do that? So for that we have a ndim function. Alright, let's see how we are going to do it. So what task we have is return the dimension of the array. Okay, let's see how we'll proceed. So let's define an array as a equal np dot a range 24. So here what it did, it created me an array from 0 to 23. Okay, so now what I want to do, I want to check the dimension of this particular array. I'll just write print a dot ndim. So ndim is the function which will return me the dimension of this particular array. So what do you think the dimension of this array is? Any guess? It's 1, right? So the dimension of this particular array was 1. Now since that we have defined a single dimensional array, let's just reshape it. So here we are reshaping our array. So for reshaping, let's define another variable as b equal a dot reshape in the dimension of 2, 4 and 3. So here as a part of dimension, you can use any number whose product is 24. So for that one trick is there. Like what you can do is first calculate the factors of 24. What are those? 1, 2, 3, 4, 6, 12 and 24 itself, right? So here what all value it can take? So here you can select only number from 1, 2, 3, 4, 6, 12 and 24. So it's like if you are selecting 1, the another would be 1. If 2, then 2 cross 3 it's 6, 6 cross 4 it's 24, right? So here we took as 2, 4, 3, or you can even take 2, 3, 4, anything. If you are taking 6, then 6 multiplied by 2 is 12. And again multiplied by 2 is 24. So you can even reshape this array to a dimension of 6 cross 2 cross 2. Okay, let me just print the dimension of B and show you the output. So what is the dimension of B array? Let's see. Ndim, execute it. So here we got the output as 3. This is from the previous thing only, just remove it. So here the dimension of B is 3, 3-dimensional array, right? If you change it to like what? Let's change it to 12, comma 2. This will work, right? And the dimension of this array would be 2, right? It's a 2-dimensional array. Okay, got it? So basically in reshape up here, what we are specifying is the value of x, y and z coordinate. Okay, since we are not specifying any z coordinate, so it's a 2-dimensional variable and the value of x is 12 and the value of y is 2. So we need a 12 cross 2 matrix up here. Let's even print B. Let's see what we get. So you'll get the output something like this. So 12 in a column and 2 in a row. Okay, so now you know how to find out the dimension of any array and how you can reshape any array to your need, right? Let's move ahead. Now, what if I just want to return the number of elements in an array? How will I do that? So find the number of elements in an array. Let's see. We have already defined an array A up here, right? Here's array. Here's array. A equal np dot a range 24. So our array A consists of 24 numbers that we already know, right? Now, how do we find the number of elements in an array? So up here we have already defined an array as A equal np dot a range 24. Okay, so here we already know that number of elements in our array is 24 since we are only defining it, right? So what if you get a scenario in which you don't know how many elements are present in the array? So for that we'll be using size function up here, right? Let me just verify how size function work. So currently you know how many elements are there in A, right? It's 24, you have only defined it. So in order to find out the number of elements in an array, all you need to do is use a function size. So name of the array A dot size. That's it. Execute it. So we got the output as 24 and it's verified. So even you have initialized the array with 24 elements, right? And this function has verified this. What if I just change it? Let me just show you. Let's change it to 25. Let's remove this. Okay, let's print our size. Well, the output up here would be, any guess? 25, obviously, right? Okay, so this is how you count the number of elements in your array. Let me just take one more example. Let's define an array as A equal 1, 2, 3, 4, okay, comma 3, 4, 5, 6, comma 2, 3, 7, 9. Okay, so this is my new array. Let's name it as D. Okay, now let's print the size of D. How many elements are present in D? D dot size. So let's see what's the output. So we have to define a tuple up here. Okay, tuple object has no attribute size. Let's take one more example up here. So here let's define our array as D equal np dot array. Inside this, let's define few arrays like 1, 2, 3, 4, 5, 6 and 6, 7, 8. Okay, now let's just print D dot size. So this will return the number of elements present in D and the output is 9, 3, 3, 3. Okay, well, what if I just add one more element up here like 8, 9? So what should be the output? Should be, so once we added 9 up here, we got the output as 3. Well, I know you are wondering that we'd be getting the output as 10, right? So here we don't have an equal number of elements in the array, right? So in this case, if you print D dot size, what it will return? It will just, so in this case, if you print D dot size, what it will return? So it will just return how many number of rows are there in your array. Okay, so how this size is working, it's multiplying the number of rows to the column. Okay, so if I remove 9 from here, so what we have is 3 cross 3, 3 rows and 3 columns, right? So 3 cross 3 is 9. So that's how it's calculating the value 9 up here. If you change the value of 4 here, again 4, and again add some value as, let's say, 9. Okay. So in this case, what value you will get is 4 cross 3. 4 cross 3 is 12. So total number of elements in that array is 12. Okay. So this is how you count the number of elements in an array. Fine. Now let's just get back to our PPT and see what's left. We discussed this. Yeah, we already discussed how you can change the dimension of an array or resize it. Then another example, this also we discussed. Next, counting the number of elements in an array. We just did it. I'm assuming all these things are clear to you, right? In case you have any doubt, feel free to reach out to us and we'll make sure that the doubt is clear to you within 24 hours. Okay. So next we have is we want to find the data type of the array. So let's see how to do it. So here we have is find the data type of the array, right? So let's take an example up here. So let's define our array as a equal np dot arrange 24 numbers, and each of data type, for that I'll write d type. So what's the data type? Let's say all are of float. Okay, let's check print a dot d type. So it's a float, right? Now what if I just remove it? What if I just write np.arange 24 and print the data type for that? So here we'll get int 32 values. So in this case, if you print the values of a, you are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, right? And just if you change the data type using d type equal float, so all you'll be getting is 0 point something, 1 point something. So you got a float value up here. Okay. And even the data type which we are printing up here changed from int 32 to float 64. Correct? Okay. So this was all about NumPy array inspection, NumPy array mathematics. We'll see what are the various mathematical functions that we can perform using NumPy. Okay. So let's see. So first we have is addition using NumPy. So for performing some addition, we have a sum function up here. Let's see how does it work. NumPy array mathematics, and in this we are learning about addition. Okay, import NumPy as np. You can write any name apart from np. If you write NA, that is also fine. We are just following the convention and writing np up here. Okay, so now what if I want to find the sum of two numbers? So what I'll do, I'll call the sum function. So I can call np.sum. np.sum, inside that sum of two numbers. What are those two numbers? 10 and 20. It will just give me the result as 30. As simple as that. You can even use a variable, like using a variable. So let's define a comma b equal 10 comma 20 and np.sum. I want a sum of a plus b using a variable, that is sum of a plus b. Okay, so np.sum a comma b. Execute it. What error did we got? Access 20 out of bounds for array of dimension 0. So always remember, whenever you are writing some parameter inside the sum, make sure that you are placing them inside the square brackets. Okay, as the sum function only takes the array of values. Okay, so now if I execute it, the error would be resolved. Okay, so we got the value as 30. Now, what if I want to find the sum of a particular axis? Like I have a 2 cross 2 matrix, and inside that I want to find the sum of just my first axis or just my first column. Let's see how we can do it. So here, let's define np.sum. Inside that, let's pass some array like 1 comma 2 and another array like 5 comma 6. Okay. So now what if I want to print the sum of 5 plus 1 and 6 plus 2? So in that case, I'll just mention like axis equal 0. Okay. So you'll get the output as 6, 8. 5 plus 1, 6, and 6 plus 2, 8. Now, what if I want to print the value of 1 plus 2 and 5 plus 6? So in that case, np.sum array of 1, 2, same number. Nothing need to be changed, just the access value would change. Okay, 5, 6. Now, specify the access value as 1. This is the only change that you have to do. So here you'll get the output as 3 and 6 plus 5, 11. So you got the output as 3, 11. Correct? Now, what if I don't specify the access up here? So what values do you think I'll get? What if I remove this? Let's see. So I got the value as 14. How? So it summed up 1 plus 2 plus 5 plus 6. So it gave me the entire sum of all the elements of the array. That is 1 plus 2 plus 5 plus 6. That is 14. Okay. Similarly, like sum, we have other important function up here like subtract, divide, multiply, exponent, square root, sine function, cos function, log function, and many more. Let's see some of them. Now, let's copy up this title, Numpy array addition. Here what we are performing, let's change it to subtraction. Now to perform subtraction, we have a method as, so we have to call the function subtract. Let's see an example like np.subtract. What do you want to subtract? Like any value like 10, 20. So we'll get the output as minus 10. 10 minus 20. So you got the value as minus 10. Okay. Similarly, what if I want to find the multiplication of two numbers? I'll just write np.multiply 2, 3. Let's take two number multiplication of two number. So we'll get the output as 6. Let me just add one more heading up here. All other Numpy mathematics function. So inside this we saw for multiply. Now let's check out for division. So for dividing two numbers we have function as divide. So np.divide. Divide what? Let's divide 10 by 5. Here we are dividing two numbers. Okay, let's execute it. So we got the result as 2.0. Okay.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So here all the operation that we perform with sum can also be performed with subtract, multiply, divide, or anything. Okay, it's like here we use a variable. So here we are summing up two array with axis 0. Here we are summing up axis 1. So all those functions can even be done with np.subtract, np.multiply, or np.divide. Let me just show you with one example. Let's just copy it and let's paste it up here. So instead of sum, let's change it to divide and execute it. Invalid number of arguments. Now let me just show you how you can divide two arrays. So let's define two array up here like a equal np.array. It consists of 2, 4 and 6. Okay, and other array b equal np.array. Inside this I'll pass 1, 2, 3. Now let's divide array A with array B. So np.divide array A with array B. Let's see what result do we get. So we got the divided result of two different arrays. Fine. Similar operation we can perform with multiplication. So you got the value as 2, 8 and 6 3s are 80. Okay. So we also have other function as exponent, square root, sine, cos and log. So let's see them one by one. So all you have to do is change the function. So we have exponent function for calculating the exponents. So we have exp function for calculating the exponents, sqrt function for calculating the square root, sine function for finding out the sine value of an array. Similarly, cos function for finding out the cos value of the array, and similarly log function to find out the log value of the array. Let's see them one by one. Again, so there's our array, we have already defined it. So let's use all these functions one by one. Print np dot exponent of a. Okay, execute it. So this is the exponent of a, that is e to the power a. Okay, e to the power 2 is 7.38, e to the power 4 is 54.5, e to the power 6 is 403.42. Okay, let's just copy this function and let's find the square root of all the elements of a. So sqrt. So this is our square root. Let's add one more thing. This will make things more clear. Square root, and here it was exponent. Fine, copy this. Now we'll calculate the sign. Sign is np dot sign value of a. Again we have to check for cos, so cos is np dot cos, and finally log. So we have log as np dot log. Okay, execute it. So we got all the values of here. Exponent is this, square root is this, sine of 246 is this, cos of 246, log of 246. Okay, so these are some of the mathematical function that you can perform using Numpy. So let's move ahead. Let's go back to our PPT. So we already discussed this part, and we also learned about all these different types of other function that you can perform, and we also discussed about the error that you might get. So let's move ahead. So next we have is the array comparison. So in this we have element wise comparison and array wise comparison. Let's see them one by one. So here we have is array comparison. Okay, so let's define 2 or 3 arrays. Okay, so a equal like 1 2 4. Let's define b equal to 4 6, and let's define one more, c equal again 1 2 and 4, same as a. Okay, so now let's use Numpy to perform an element wise comparison of these arrays. So for this I'll write np dot equal, let's write a comma b. So it will compare 1 with 2, 2 with 4 and 4 with 6. So if these two elements are equal, it will return true. In other case, false. So for now, what output do you think we'll get? Well, for now all the output would be false, right? As 1 is not equal to 2, 2 is not equal to 4 and 4 is not equal to 6. But what if you change this b to c? So in this case, you'll get all the true values. Just for understanding, just change this 6 to 4. Now let's compare a with b. So in this case we have last as true, so these two are false and 1 is true, so 2 false and 1 true value. So 2 false and 1 true, correct? So this was about the element wise comparison. Okay, now next we'll see. Now next, let's perform a array-wise comparison. Okay, let's just copy them. Okay, now in this, I want to compare the entire array. If all the elements of array A equal to all the elements of array B, then only in that case we'll get the output as true. In all the other case, we'll get the output as false. Let me just show you with this example. So np dot array underscore equal. So this is the function that we are going to use for comparing two arrays. So like this, compare A and B. Even if one of the element is different, we'll get the output as false. So here we got the output as false. See, execute it, false. So here what we have, A 124 and B 144. So we had two elements equal in A and B, right? Just 2 and 4 were different. And even then we are getting false. What if I just change the value to C? So in this case, we'll get the output as true. Correct? So this was about array-wise comparison. So now that we have learned how to compare two arrays, both element-wise and array-wise. So let's move ahead and see what we have next. So we are done with this example. Next we have is the aggregate function. So under this, we'll see how to perform various statistical calculations on the array. Okay, let me show you with an example. Aggregate function. So here, let's again copy paste the value of a, b and c. So in aggregate function, what all things we can do? We can perform an array-wise sum, or we can find the minimum value of an array, or the mean of an array, the median or correlation coefficient of an array, or even the standard deviation of the array. Alright, let's print all of them one by one. So here I want to print my sum. So print np dot sum of array A. So it will give me the sum, right? 4 plus 2 plus 1, that is 9. Wait, just to clarify it, sum is this. Then let's print the minimum value from the array. So our minimum value is np dot min of A. Now let's print the mean value. So mean is np dot mean of A. It's as simple as that, right? Print median is np dot median of A. Then print correlation coefficient is np dot correlation coefficient of A. And finally the standard deviation. Standard deviation is what? It's np dot std of A. Okay, so let's execute it. So we got the value as sum 7, minimum value is 1 to 4, correct? Mean is 2.33, that is 4 plus 2 plus 1, that is 7 by 3, 2.33. Median is 2.0. Correlation coefficient, that is 1, and standard deviation is 1.24. Okay, so this was about the aggregate function. Let's come back. So next we have is Numpy broadcasting. So let's see what exactly is. For example, we have two array with different dimension, right? But make sure the number of rows or number of columns are same. Okay, so in this case what we have is same number of element in each array. Okay, so it's like when you add first array to the second array, what it does, it simply adds it. Like, so here you can see we got as 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2. But here again, 10 plus 0 is 10, 10 plus 1 is 11, 10 plus 2 is 12. So similarly, what it did, it broadcasted this value and add all these values to different rows of this array. Okay, so same value is being added to this row, this row, this row, and this row. Okay, so this is the concept of broadcasting, as this particular array is broadcasted and summed with all the element of this particular array. Let me just show you with an example. This is concept of broadcasting. Okay, let's import numpy as np. Let's define an array as np.array. Inside that, let's place few values 0, 0, 0, then 1, 2, 3, then 4, 5, 6. Let's take one more. Let's take it as 5, 6, 7. Okay. Now let's define another array b equal np.array. So in this, let's specify a number like 0, 1 and 2. So this is the number which will be added to 0, 0, 0, 1, 2, 3, 4, 5, 6 and 5, 6, 7. And this is the concept of broadcasting. Okay, let me just show you. Print first array. First array is what? A, right? Change the line. Then print the value of second array. And then print the value of first array plus second array. That is A plus B. Okay, execute it. So here we got the output as first array is this, second array is this, and first array plus second array, you can see that 0, 1, 2 is added to all these numbers. Fine. So this was the concept of broadcasting. Array manipulation in Python. So as a part of array manipulation, so we have concatenating two arrays together, stack array row wise vertically, stack array column wise horizontally, and combining column wise stacked array. Let's take an example in Jupyter Notebook and learn them one by one. So here we're going to start about array manipulation Python. Okay, so first of all, let's define two arrays. Let's take a equal np dot array. Inside this, let's say 1, 2, 3. Okay, so this is my array A, and B equal np dot array 4, 5 and 6. Okay, so first of all, we'll see how we can concatenate these two arrays. So first is concatenation of two arrays. So for this, we have a function concatenate under Numpy. So we'll just call it np dot concatenate. We'll just write A and B. That's it. So here you got the output as 1, 2, 3, 4, 5, 6 in all the element in a single array. So therefore what it did, it concatenated both the array A and B into one. Okay, so next we have is stack array row wise, that is vertically. So stack array row wise vertically. Okay, so again for this we have another function in Numpy as vstack. So just take two parameters, the name of two arrays A and B, execute it. So as you can see, my two arrays are stacked one above other vertically. Here one more thing I have to say, like if you want to stack array row wise but in a horizontal fashion, so it's again same as your concatenate function, but here we have another function as hstack, and even this takes two parameter A and B, and it's quite similar to the concatenate function. It will give you the same result. Okay, so this was about hstack. So till now we discussed about concatenating or stacking row wise, right? Now what if I have to combine column wise? So let's see here, combining column wise. So for this I have a Numpy function column underscore stack. So let's call it np dot column underscore stack. Inside this, let's pass our arrays A and B, executed. So here you can see that my array A and B are stacked in a columnar fashion. Okay, so this was about combining column wise stacked array. Okay, so let's get back to our PPT and see what is the next topic. So next topic in array manipulation in Python we have is splitting array. That is, what if we want to perform some horizontal split or vertical split in the array? Let's see how to do it. So for this, let's define an array. Let's take x equal np dot arrange 16 numbers and reshape this 1D array in the dimension of 4 cross 4. Okay, let's print x and see our array. So this is our 4 cross 4 array consisting of numbers between 0 to 16. Now what if I want to split my array horizontally from here, this point, such that my first array contains 0, 1, 4, 5, 8, 9, 12, 13 and my next array contains 2, 3, 6, 7, 10, 11 and 14, 15. Let's see how to do it. Well, for this we have another function as hsplit. Let me just show you. Print np dot hsplit. Inside this you have to pass your array and define from which position you want to split. I want to split it from second, like there's my 0th index, first index, my second index. Okay, so I want to perform a split from this point. Okay, so let's see the output. Let me make things more clear for you. Let's add a new line up here, horizontal split. After performing the split, so here you can see that I have two arrays. First array is this, consisting of 0, 1, 4, 5, 8, 9 and 12, 13, and my next splitted array consists of the rest half, that is 2, 3, 6, 7, 10, 11 and 14, 15. Okay, I can even perform some customized split over here. Let me show you some example, like print np.hsplit start from x and until np.array 3, 6. So let's see what's the output, but before this let's add some new line. Let's check the output. So here we got two arrays, right? First one is this 0, 1, 2, 4, 5, 6, 7, 8, 9, 12, 13, 14, and the next one is the last column. Okay, so here let's split it from this point such that 0, 1, 2, 4, 5, 6, 8, 9, 10 all are these in, so all of them are in one array and rest of them, that is 3, 7, 11, 15 is in different array. Okay, so let's do it. Np dot horizontal split and just write x comma np dot array. So here you will get the output as this. Okay, now from this example, what if I want these two columns together and this entire column has a separate array? So I want 3 arrays in total, so I just have to make a little change in it. Just write 2 comma 3, that's it. So it's like np.hsplit x comma np.array second and third column. So here I got the output as this. This is my first array, this is my second array, and this is my third array. Okay, so guys, this was all about splitting arrays and array manipulation in Python, indexing and slicing in Python, and we'll see how to select certain elements from the array. So let's start with what exactly is indexing and slicing. Well, indexing just refers to a position. For example, if you are storing some numbers or a string in an array, so each cell of an array has some index number associated to it. For example, the image shown on your screen represents an array in which each cell has a different character. So we have Monty Python stored in an array. So here index number of m is 0, 1 and so on till n is 11. So this is the index number when you are going from top to down. Okay, and suppose if you directly want to extract the last character from the string and you don't know what is the length of the string, so in that case you can use the negative index number. It starts from -1 at the end and goes till -12 at the beginning. Let me just show you an example and make things more clear to you. So this is our Jupyter notebook. So let's define an array a equal Monty Python. So each character is stored in a different cell. Okay, so now what if I want to extract Monty from here? So how will I do that? A of Monty, that m starts from cell number 0 and it will end till MONTY 0, 1, 2, 3, 4 and 5. So before the colon we write the part which is included, so m is included. So after the colon, that is cell with index number 5 is not included, so just before 5. So it's like 0 to 4. Let's see the output. So here we got the output as MONTY. Now what if I want to extract, let's say, these characters? Start from 0, 1, 2, right? Start from 2, ends at 3, 4, 5, 6, 7, 8 and 9. So I'll just write 0, 2. Start from 2 and end before 9. So this was my requirement and I got the output as NTY-PYT. So this was a very basic example of indexing and slicing in Python. Let's move ahead to learn more about it. So let's learn how to slice a 3x3 dimensional array with the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 stored in them. Okay, so let's learn how to extract or slice the array. So what if I want to extract the selected element? So here my selection is in first row, right? That is 0th index. So I can directly extract with a of 0. So if I write a of 0, this includes all the element from the first row. That is 1, 2, 3. But when I write :1, it means you don't have to include 1. That is whatever part comes after colon, we have to exclude that part. That is, we have to take number just before that. That is, if :1 is there, so we'll take till 0. And this will extract the first row from the array. The first one, it extracts all the elements from the first row. And next one, it extracts the first row from the entire array. Next, what if I want to select these elements? So here my selection is in the first row, right? That is 0th index. So if I write A of colon 1, now how to extract this selected element? Well, in this, I know that my selection lies in the first row, right? That is 0th index. Now, I'll write A colon 1. So what it will do, it will extract the entire first row, or extract till row equals 0. Only this row will be extracted. Next, I don't want to include the part of 0, 0. So I want my selection to start from column 1. Okay, so I'll write 1 colon up here. So after writing 1 colon, what it did, from the 0th row, it then selected the column index starting from 1 till last. And therefore we got a selected value. Let me show you this example in my Jupyter notebook. Let's define an array. Let's say a equal np.array. Inside this 1, 2, 3, 4, 5, 6 and 7, 8, 9. Okay, so let's extract the first array from here. Let's extract first array. So we saw a of 0. A of 0 gives us all the element from the first row. Next, if I write a of colon 1, so this will extract the first array. Fine. Next, what if I want to extract 2, 3 from here? Okay, first let me just show you the entire array.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So there's our array. Now I want to extract 2, 3 from here. So how I'll write A, first select the entire row. So 2, 3 lies in first row, right? So I have to select the entire row. Then it should end at 2, 3. Then my 2, 3 starts from column number 1. So I'll write 1 and 1 till last. Okay, execute it. So you'll get the output as 2, 3. Go back. Now if this is our requirement, so how to extract the selected element? So in this, my selection lies in first 2 rows, right? That is 0 and 1 index. So here, if I write a of colon 2, so this will extract both the row 0 and the row 1, okay? But now I want my column number to start from 1. So I'll just write colon 2 and start from 1 till end. Okay, let me show you this as an example. So there I wanted to extract 2, 3 and 5, 6, right? So let's see how can I do that. So a of 2, 3 and 5, 6. These numbers or the selection lies in first 2 row. So starting from 0 before 2, that is till 1. So select all the rows from 0 to 1. Then in the column part, the column starts from 1, right? 0, 1, 2. So it will start from here, right? So it should start from 1 and it can end till last. So let's execute it. So in this case, we'll get the output as 2, 3 and 5, 6. 2, 3, 5, 6. Clear? Let's move ahead. Again, same example. This one you can work it out on your own. Can you say what's the answer for this? Okay, let me give the solution of this. So a of 1 colon comma. So what does it mean? Start from row number 1. So there's our row number 1 till end. So include everything from here. Okay. So we have a of 1 colon comma. Okay. So what does it mean? So it means extracting starts from row number 1 till end. So this is my row number 1 till end. So this will include all of these values 4, 5, 6, 7, 8, 9. Okay. And it should continue till 1 colon, which means after extracting all the elements from row number 1 till the end, that is row 1 and row 2, when all these elements are included, from these elements I want to start from colon number 1, that is from here till the end. So the output what I'll be getting is 5, 6, 8, 9. Let me just show you. So I want to extract 5, 6, 8, 9, right? So a of here 5, 6, 8, 9. So these lies in first and second row, right? So row, it should start from 1 and till last. Okay. And my column 5, 6, 8, 9. Let's start from first column, right? 0, 1, 2. Even the column should start from first and till last. So here I'll be getting the output as 5, 6, 8, 9. So here are a few more examples that you can try. Now a question might arise in your mind, like what is so special about Numpy arrays? So why can't we use simple Python list for these scientific computation? So let's move ahead and see what are the benefit of using Numpy array over the list. So Numpy array consumes less memory when compared to a list, is also faster and more convenient as compared to a list. Okay, let me just take few examples in my Jupyter notebook and show you how exactly it consumes less memory, how it is faster than a list, and how it is more convenient than it. Okay, so let's just get back to our Jupyter notebook. Advantages of Numpy over a list. So first, let's compare Numpy and list on the basis of their memory size. numpy versus list. Parameter is memory size. So for this, let's import numpy as np and again import sys library. Now let's define a list. So let's say there's our list L equal range, range list has 1000 numbers in it. Okay, let's print the size of it. So print sys dot get size of any integer between 1 to 1000. For example, I can take 1 over here. Size of any integer multiplied by how many total integers are over there? 1000, right? Either you can write 1000 or you can write length of L. Okay, now I need to compare it with numpy array. So let's define a numpy array. So let's say our numpy array A equals np dot arrange 1000 numbers. Okay, again print a dot size multiplied by, you can directly write 1000 over here or you can use a dot item size. Okay, let's execute it. Let's modify our code a bit. Here size of a list and here size of an array. So we got the output as 28,000 as the size of the list and size of the array is 4,000. Okay, so from here I can say that storing a numpy array occupies less memory when compared to a list. Okay, so now that we have compared their memory size, now let's compare numpy and list on the basis of their speed. So numpy versus list on the base of their speed. For this we have to import another package, import time. We have already imported numpy as np up there. Now let's create a function. Here I'm defining function as using list. Let's define our starting time t1 equal time dot time. Okay, now let's define a list x as x equal range of 1000 numbers, and let's define another list y as range of 1000 numbers. Let's make them 10,000. Okay, this way we can check the speed of their processing in a better way. Okay, now let's add all the element of each list. So z equal x of I plus y of I for I ranges in length of x or length of y or maybe 1000. Okay, length of x or y, anything, or you can just write 1000 up here. Okay, so this is my z, and from this function what I want, return time dot time minus t1. Now here this t1 was the initial time, right? And now this time would be the process time, that is time after executing this statement, right? So if we subtract this time minus the initial time, we'll get the total time taken to process this particular line. Now let's define another function. So define using numpy. Same, define the starting time. Wait, let me just add some comments up here. Starting or the initial time is also the starting of the initial time. Next, let's define a numpy array. Now x equal np dot arrange 10,000 numbers. Okay, and b equal np dot 10,000 numbers. Now for the processing part, what I want to do, I want to take the sum of both a and b. Z equal just a plus b. It's as simple as that, and this is how it is more convenient than a list. More convenient than a list. Okay, now again what I want from here, return time dot time, that is time after things are processed, that is this particular statement is processed, minus the initial time, that is t1. Okay, now let's call these two functions and store their output in two variables. Let's say list time equal using underscore list and numpy time equal using numpy. Okay, and then finally let's print them. Print list underscore time, comma, numpy underscore time. And one more thing you can add up here is like in this example, numpy is string value of list time divided by numpy underscore time, that is the time taken to execute the numpy array, this many times faster than a list. Okay, fine, let's execute it. The name using underscore list, capital. So for this example, we got the processing time for list is 0.00199, while for numpy we got 0.00099. So in this example, numpy is 1.99 times or almost 2x time faster than a list. Okay, so this is how a numpy is faster than a list, and here I showed you how it is more convenient than a list. So I hope these things are clear to you. Coming back to our PPT, let's see what we have ahead. So we have already done this example, numpy versus list memory size. We also compared on the basis of their speed, and here I showed you how it is more convenient than a list.
What is Scipy? Well, Scipy is a free and open source Python library which is used for scientific and technical computing. Okay. It contains module for optimization, linear algebra, integration, interpolation, special functions, Fourier transformation, signal and image processing, and other scientific computations which are most common in science and engineering. This library is built upon NumPy to make the scientific calculation more efficient. But before we actually move ahead, there's few special characteristics of Scipy that you should be familiar with. So let's move ahead and discuss about some of the characteristics of Scipy. So first of all, it contains toolboxes dedicated to common issues in scientific computing. Secondly, Scipy offers different submodules for different applications. Third is, it operates very efficiently on NumPy. We can say NumPy and Scipy works hand in hand. Okay.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following is the most important language for data science? A. Java, B. Ruby, C. R programming, D. Python. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So fourth is, it adds significant power to the interactive Python session by providing the user with high-level commands and classes for manipulating and visualizing the data. Finally, Scipy routines are tested and optimized. Therefore, Scipy should be used whenever possible. Non-programmer scientists face difficulties while performing scientific calculations in large real-world data. So this issue can be resolved very efficiently with the help of short and simple codes offered by Scipy. So this was about some of the characteristics of Scipy. So till now we know what exactly is a Scipy and what are its various characteristics, right? So let's just move ahead and see what are the various sub-packages or sub-module that this library has to offer, okay? So these are the various sub-packages which are a part of Scipy. So first of all, we have something called scipy.clusters, which comes in handy while dealing with vector quantization or k-means clustering. Second, we have is scipy.stats, which is generally used for statistics. Then comes scipy.optimize, which is used for minimizing or maximizing objective functions. Another very important sub-package is scipy.integrate. This is useful while dealing with different integration routines. Then we have scipy.linalg, which is generally used to perform linear algebra routines. And finally, we have scipy.fftpack, which is used for fast Fourier transform. Okay, so these are the various sub-packages which are available under Scipy. Scipy.cluster. So in this session, we'll see why do we use scipy.cluster, what exactly is clustering, and how do we find clusters. Okay, so I hope the agenda is clear to you guys. So let's move ahead and see why do we use scipy.cluster. Well, this sub-package is very useful when we have to divide the dataset into cluster based on some attributes. So in the k-means function, we have to pass the data and the number of clusters that we need to divide them in as the parameter. Now a question might have popped into your head, right? Like what exactly is this clustering? So let's discuss that first. So let's say we have a data set that looks something like this, and you want to group them into two clusters, the green and the blue cluster. So from here you can say that clustering is the process of grouping similar items into one single group. For example, you can say that we have selected two clusters over here, right? So all the data points in green cluster are completely different from all the data points in the blue cluster, okay? But all the points within the green cluster are quite similar to each other, and same is the case with the blue cluster, okay? So summarizing it, you can say that clustering is a process in which the data points are clustered into groups. The data points within one cluster are quite similar to each other, but when you compare it to the data point in different cluster, it's completely different. There is no similarity between them, okay? So now the question arises, how to calculate this, or how can we create this cluster? Okay, so let's see how to create this cluster. So how do we find cluster? So first of all, we randomly pick two different cluster centers, okay? Then as a step 2, what we'll do, we'll assign our data set into two clusters based on minimum distance to the cluster centers. Fine. Then we'll calculate the mean distance of each member in the cluster. Then as a step 4, what we'll do, we'll shift the cluster center towards the mean, and we'll consider that two mean values are the new cluster centers. Okay. Then again we'll repeat step 2 and step 3 until no member changes the group. Okay. So I hope you got an idea of clustering from this. So let us discuss with the help of an example to make it even more clear. So let's say we have a data set in which we have coordinates as x, y, distance k1, distance k2, minimum, and cluster. So these are our attributes over there. Distance k1 is the distance between the point and the centroid of cluster 1, and distance k2 is the distance between the point and the centroid of cluster 2. So let's say we have a data set 1, 1, 2, 2, 4, 4, 5, 5, and 6, 6, and we need to divide them into two different clusters. So first of all, we'll randomly pick two cluster center or centroids. Let's say k1 equal 3, 3 and k2 equal 5.1 and 5.1. Okay. Then what we'll do, we'll calculate the distance from each point to k1 and k2, and based on the minimum distance, we'll assign them the clusters. Okay. So for example, the distance from 1, 1 to k1 is 8. But that to k2, it's 33.62. So clearly here minimum distance is 8. So our first point goes to cluster 1. From the point with coordinate 2, 2, so the distance from k1 is 2, but to k2 is 19.22. So this also belongs to cluster k1. And similarly, we'll find the distance for rest of the point, and based on minimum distance, we'll put them into the different cluster. Okay. So now after assigning the cluster, it looks something like this. So cluster 1 has the point with coordinates 1, 1, 2, 2 and 4, 4. And cluster 2 have the point with coordinates 5, 5 and 6, 6. So our next task would be to find the mean of all the member in a cluster. Okay. So the coordinate of mean of cluster 1 is 2.33, 2.33. And the coordinate of mean of cluster 2 is 5.5 and 5.5. Okay, so now consider the coordinate 2.33, 2.33 and 5.5, 5.5 as new k1 and k2. Okay, again find the distance of each point from k1 and k2. Then based on minimum distance, put them in clusters. Okay, now repeat these steps until no member changes the cluster. So in this example, we had very less number of data. So the whole calculation with repeating steps doesn't look that annoying, right? But what happens if the data set is large, right? That would be too hectic task for you to calculate it manually. So now to reduce this computational complexity, we have scipy.cluster. Okay. Now let me show you how you can use it in Python. So to perform clustering operation, we'd be needing some data. So here I have imported some car dataset using pandas. Okay. So my dataset consists of 11 columns and 32 rows. And all these 32 rows consist of different numerical data. Okay. Here in this slide, I have just shown first 13 rows of the dataset. So as you can see here, my dataset consists of MPG, cylinder, displacement, horsepower, DRAT, weight, QSEC, VS, AM, gear, carburetor. Right. So now we'll be using this dataset to create the cluster. Okay. So import pandas as PD. Data equal pd.readexcel, inside that the name of the file. So this is how you can import the data. Okay. So now to perform clustering operation, we first need to import k-means and vq from the scipy.clustering subpackage. Then we'll pass our data and the number of cluster that we need in k-means function. In our case, we need 3 clusters, right? So this k-means function would return the array of 3 centroid. Okay. So after we get the centroids, we'll pass our data and the centroids into the vector quantization function, which returns an array of cluster index values for each record. So let's see the output. So as you can see from the array of cluster index, our dataset is divided into 3 different clusters. It was simple, wasn't it? But there's a common pre-processing step for machine learning algorithm called the data whitening. We need to perform data whitening when we use features that represents different characteristics and are on very different scales. So which we are going to see in our dataset. Okay. So we'll now see if there is any change in the cluster after we perform whitening. Well, again, to perform data whitening, we'll be importing whiten from scipy.cluster.vq. Then after importing the data, we'll pass the dataset into the whiten function. Then repeat the same steps to find the centroids and the array of index. Now comparing to the array of cluster index, you can see that many of them has been changed, right? In this and in this. Okay. So this is why we need to perform data whitening before passing the data into the k-means clustering function. So this was all about scipy.cluster. Okay. Let's start with why do we use scipy.stats? Well, scipy.stats consists of all different types of statistical functions in it. Okay. It also contains a large number of probability distribution. To see or to know more about what functions or the package this library has to offer, you can just use info and inside that mention stats, and this will display you the list of all the different functions available under it. Okay, but now let's just move ahead and let me just take an example and show you how does it exactly work. So let's say the nutritionist measured the sugar content in grams for 13 drinks at a coffee shop. So this is how his data looks like. Okay. Now the drink had a mean of 21.5 gram and a standard deviation of 8 gram, and the distribution was roughly symmetric. Okay, so for that we are creating a visualization out of it. So first of all, we are importing the Numpy library and we are storing all these data in the Numpy array. Okay, so copy equal np.array, and then inside that we are passing all these values of sugar. Okay, next what we are doing, we are printing the mean and standard deviation of it. So as you can see, we got a mean of 21.5 and a standard deviation was 8.06. Okay, then what we did, we created a plot out of it. So for creating a plot, I used a matplotlib over here. Okay, and on the x-axis we have range of 30 number, that is 0 till 13, and on the y-axis we have different values of sugar in the coffee. Okay, so this is how our plot looks like. So the distribution in this plot is roughly symmetric. Now let's say a grand mocha cappuccino at the coffee shop contains 14 gram of sugar. So calculate the standardized score or z-score for the grande mocha cappuccino. So how will we do that? So for calculating the z-score, so you have to import stats. So from scipy I'm importing stats, then print stats.z-score coffee. Okay, so here we got the list of different z-scores for different values. Okay, so the z-score of a 14 gram sugar coffee is minus of 0.93, right? So but what does this mean? So any guess, anyone? What do you think it means? This drink has 0.9 gram of sugar less than the mean of the 13 drinks, or it's B, this drink is 0.9 standard deviation below the mean of the 13 drinks, or it's C, that is about 90% of drinks have a lower sugar content than this drink, or it's D, that about 90% of drinks have a higher sugar content than this drink. So what do you think the answer should be? The answer is D. That is, the value of z-score as 0.9 means about 90% of drinks have a higher sugar content than this drink. So this was about how you can use scipy.stats to calculate z-score for your data. Now let's take another example over here. So this data set consists of frequency of people going to gym and frequency of smokers. So in this example, we are trying to find out whether frequency of going to gym is related to frequency of smoking for our data or not. Okay, so how will we do that? So for doing this, we have another function offered by this sub package, that is chi-square. So this chi-square test is used to determine whether the output variable is dependent or independent of the input variable. Also remember that a chi-square test is designed to analyze the categorical data. So we'll be finding out the p-value with the help of the function offered by this sub package. But how to define whether one variable is related to other or not based on its p-value? So there should be one cutoff, right? So by convention, the cutoff point for a p-value is 0.05. So if p-value is less than 0.05, we can say that they are related. But if it's greater than 0.05, they are not related. Okay, so let's go ahead and find out. So we imported the Numpy library, created the data, then we imported the stat from Scipy. Okay, so we passed our data into the chi2 contingency function. So this function gives us the value of chi2, p-value, degree of freedom and expected frequency. But here we need only p-value. So let's just print the p-value for that. Okay, so as you can see, we got a p-value of 0.482, which is greater than 0.05. So based on our records, we can conclude that there is no dependency between frequency of smoking and frequency of going to gym for our observed data. Scipy.signal. So in this session, you'll learn about why do we use Scipy.signal and how do we use it. Okay. So without delaying any further, let's see why do we use it. Well, the Scipy.signal is used for typical signal processing. You can process your one-dimensional or periodic signals in that. Let's say you need to resample a signal with n data points to x data point. So in that case, you'll be using Scipy.signal. So what Scipy.signal is basically doing, it is resampling the data point using FFT, that is fast Fourier transformation. Okay. So now that you know why do we use Scipy.signal, let's move ahead and see how do we use it. So here we are performing the resampling. So the very first library that I have imported up here is matplotlib.pyplot for creating our visualization, Numpy for creating our dataset, and finally signal from Scipy. So here we are creating a signal with 200 data points, right? So np.linespace -10 to 10 and 200. So here we have 200 data points between -10 to 10. Okay. Next we are defining the sign graph. So y equal np.sign of t. So what it is basically doing up here, it is creating a sign graph with this data point. Okay. Next we are resampling it and we are specifying the number of required sample. So here for resampling we are using signal.resample. Inside that we are passing y, 100 sample. Okay. So number of required sample over here is 100. And then we are plotting t, y, that is these two. So our first sign graph is plotted, and then we are plotting t of :2, which means what? We are printing all the values from the t with a gap of 2. So next what we are printing? On the x-axis we have t :2. What does it mean? It means that we want all the values from the t, that is this, with the equal gap of 2. Fine. Next on the y-axis we have is the x_resample, that is this value, our resample value. And this O represents the dot, okay, these dots over here. And then finally after doing the plt.show, we get this thing. Okay, so this was about how you can use Scipy.signal to resample your data. Okay, Scipy.optimize. So in this session, you will learn about why do we use Scipy.optimize and how do we use it. So why do we use Scipy.optimize? Well, Scipy.optimize provides algorithm for function minimization. Either it can be a scalar or multidimensional. You can also use it for curve fitting or root finding. So let us discuss how can we do that with the help of an example. So here I am importing matplotlib library and Numpy library. I am using Numpy library to create my dataset and matplotlib to plot this particular graph. Okay. So here I have generated one function f of x where x varies from 0 to 1 evenly with a step size of 0.1. Okay. So when you plot this function, it looks something like this. Okay. So as you can see, we have a global minimum of this function at this particular point. So now our task is to find the value of x at which we get the minimum. So you must be thinking that you can find the minimum by plotting all the values of x in that function, right? But that increases our computational complexity. So this is where optimization function comes in handy. So you can directly use optimize.minimize, and inside you can pass your function over there. Then with the help of result.x, we'll find the x at then with the help of result.x, we can easily find the value of x at which the function is minimum. So as you can see, we got the output as 0.69. So this means that at x equals 0.699, we get a minimum out of our function. Scipy.integrate. Well, this is another very important sub-package in Scipy. So in this session, we'll learn about why do we use Scipy.integrate and how do we use it. Okay, so without delaying any further, let's start with why do we use Scipy.integrate. Well, this library is used to perform integration. I'm sure you guys are familiar with what exactly is integration, right? When analytical integration becomes difficult, numerical integration comes handy. So this sub-package offers number of routines for performing numerical integration. Okay, so here we have something called quad for single integration, DBL quad for double integration, TPL quad for triple integration, and N quad for n-fold multiple integration. Let's see how these things work. Now let's move ahead and let me just show you an example. So if function of x equal x square where y equal f of x, then find the value of integration of a to b y of dx, where a equals 0 and b equal 1. So there's my problem statement. So mathematically y equal x to the power n, right? So here the value of n is 2. Okay, so integration of a to b x to the power n dx equals a to the power n plus 1 divided by n plus 1 minus b to the power n plus 1 divided by n plus 1, right? So here n equal 2 and a equals 0 and b equal 1. So once we put all these values to our equation, we get something like this. Integration with the limit of 0 to 1, x square dx equal 1 to the power of 2 plus 1 upon 2 plus 1 minus 0. Okay, which equals to 0.33. Let's take an example. Let's say I have a function f of x equal x square where y equal f of x, then find the value of integration of y dx with the limit of a to b where a equals 0 and b equal 1. So mathematically y equal x to the power n equal x square, right? So if you see the formula, integration with the limit of a to b x to the power n dx equal b to the power n plus 1 upon n plus 1 minus a to the power n plus 1 upon n plus 1. So here if you compare these values, you can say that the value of n equals 2, right? So if you put all these values over here, the value of a, b and n to this equation will get something like this. So integration of 0 to 1 x squared dx equal the value of b was 1, right? So 1 to the power of 2 plus 1 upon 2 plus 1, that is 1 by 3 minus value of a is 0 itself, so it will be 0. So 1 by 3 equals to 0.333. Okay, so this we calculated it mathematically. So now let us see how Scipy.integrate function work and make things easy for us. So here the very first thing that I'll do is import the integrate library from the Scipy. Then I'll define a function integrate which returns the value of x square. Okay, then what we'll do, then we'll apply the intg.quad and inside that we'll pass the function integrate and the value of a and b, that is 0 and 1. Okay, so this function returns answer as well as the error value, but we are just concerned with the integrated answer. Okay, so here we got the answer as 0.333. So similarly for double integration you will be using DBL quad and for triple integration you will be using TPL quad. Okay, so this was all about the integrate function of the Scipy. Scipy fast Fourier transformation pack. Okay, so in this session you'll learn about why do we use Scipy.fft pack and how do we use it. Okay, so I hope the agenda is clear to you guys. So without delaying any further, let's start our session with why do we use Scipy.fft pack. Okay, well, this sub-package is used to compute fast Fourier transformations. Fast Fourier transform is an efficient implementation of the discrete Fourier transform. Okay, it also provides function as Scipy.fftpack.fft. It is used to compute fast Fourier transform. FFT-fric, that is used to generate the sampling frequencies of the digital signal. And finally, IFFT, that is used to compute the inverse Fourier transformation from frequency space to signal space. So now let's move ahead and see what fast Fourier transformation package has to offer. So let's check its behavior in the frequency domain. So in order to work with our fast Fourier transformation subpackage, the very first thing that we are going to do is generate one digital signal which has some noise in it. Okay, so we can easily do that using Numpy library. Okay, so let's see what we have done here. So here the very first thing that I'm doing up is importing my Numpy library. I'm defining a time step as 0.02 as I need to have equal number of spaces over here, right? You can directly put this value over here. So using np.arrange, what it will do, so your initial point is 0 and ending is 20. So np.arrange will give you all the points between 0 and 20 with an equal interval of 0.02. Okay, and all these values will be stored inside time vector. Okay, so we have also defined a period as 5. Okay, so next thing what we are going to do is define a sine wave. So signal equal np.sine of 2 pi by 5 times of time vector. Okay, and this part is what? This is our noise, that is 0.5 times of np.random.random time underscore vector dot size. Okay, we are adding any random value just to create noise. Okay, finally we are defining a figure size for it and we are plotting it. So on our x-axis we have time vector and in our y-axis we have signal, that is this. Okay, and finally we are doing plot.show to create this particular visualization. So now that our signal is ready with its noise, so we can apply some fast Fourier transformation on it. So let's move ahead. So here we are applying the fast Fourier transformation. Now that the signal is a real function, so its Fourier transformation will be symmetric. So here the very first thing I'm doing is importing FFT pack from Scipy. Okay, so inside FFT pack we have FFT frequency. The FFT frequency function is used to estimate the sampling frequencies. Okay, and we have FFT over here. So this FFT is what? This FFT function will generate the fast Fourier transformation of the signal. Okay, and finally we need to check the peak. Finally the peak signal can be found with the help of frequency inside that power dot maximum argument. Okay, so after applying the fast Fourier transformation, our signal looks something like this. Fine. Next we are applying IFFT to get the noiseless signal. So now that we have already applied the FFT, so our next task would be to apply IFFT to get a noiseless signal. So here the very first step is to filter out sample frequencies that are greater than 0 with numpy.where condition. So position under mask equal numpy.where. So wherever the sample frequency is greater than 0, all the values would be stored in position underscore mask.
Just a quick info, guys. Test your knowledge of data science by answering this question. Which of the following approach should be used to ask data analysis question? A. Data cleansing. B. Data integration. C. Data replication. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Then apply the filter of sample frequency and store the positive sample frequency on freq. So I have a variable as freq equals sample underscore freq, and inside that I'm passing position underscore mask, this value. Okay, so if you want to get the peak signal frequency over here, you can just print power of pos underscore mask dot argument max. Okay, then what we are doing, then our next task is to find the peak frequency. Here we are focusing on positive frequency. So peak frequency equal frequency of power, inside that power mask dot arg max. Okay, so the maximum peak frequency value would be stored in peak underscore freq. So now our next task would be to get an array copy of the signal where we have already applied FFT. So high frequency FFT equal sig underscore FFT dot copy. Then what we are doing, we are assigning the ones greater than frequency as 0 in order to remove the noise. So high underscore frequency underscore FFT, inside that absolute, we are checking the absolute value of the sample frequency. If it is greater than peak frequency, then assign it 0. So if you want to check it, you can just print the high frequency FFT. Okay. Next task would be to apply the inverse FFT on a high frequency FFT. So this will be the filtered signal. So filtered signal equal FFT pack.IFFT, and inside that we are passing high frequency FFT. Okay. And finally we are plotting it. Here we are defining the figure size, then plt.plot time underscore vector signal label. So label what we have is original signal. So here we are differentiating the original signal with the filtered signal by changing its line width. So we are defining a line width as 3 and its label as filtered signal. Then we are finally adding some X label, Y label and a legend to our graph. Okay, and finally we are showing it. So this would be the output of our code. This yellow signal, what you can see up here, is nothing but our filtered or noiseless signal. So here we have applied IFFT to get the noiseless signal. Okay, so this was all about FFT pack.
So have you ever wondered which book to read next? Well, I often have, and to me, book recommendations are a fascinating issue. And that is exactly what we're going to do today. So our dataset for the case study comprises of these 4 files: ratings.csv, books.csv, booktags.csv, and tags.csv. So as the name suggests, ratings.csv contains all users' ratings of the books. So there are a total of 980,000 ratings for 10,000 books from 53,424 users. So the books.csv contains more information on the books, such as the author's name, publication year, book ID, and so on. Then we have the booktags.csv file. So this file comprises of all tag IDs users have assigned to the books and the corresponding tag counts. So the tag IDs basically denote the categories into which the books fall into, and the counts denote the number of books belonging to each category. And we have the tags.csv file. So this file contains all the tag names corresponding to the tag IDs. That is, it gives out the labels corresponding to different tag IDs. So these are the tasks which you'd have to perform in this project. So in the first phase, we do a bit of data cleaning. So we'll start off by removing the duplicate ratings. That is, there are cases where a user has rated the same book more than one time. So we'll go ahead and remove all these instances. After which we'll go ahead and remove those users who have rated fewer than 3 books. Right guys, so we are into our studio now. So let us go ahead and load all of the packages required for our case study. So these are all of the packages required. Alright, now after which I'll load the 4 files from our dataset. So these are the 4 files. So we have books.csv, ratings.csv, booktags.csv, and tags.csv. And I'm storing this in objects books, ratings, book tags, and tags. So we have loaded these 4 files. Now let us have a glance at these 4 files. So I'll be using the view function to have a glance at our 4 files. Right, so these are our data sets, guys. So we have the ratings dataset, which comprises of these 3 columns: book ID, user ID, and the rating. Then we have the books dataset, and these are the columns. So it has ID, book ID, work ID, ISBN, the author's name. Then we have the original publication year, original title, language code, and so on. After which we have the book tags. And here the columns are Goodreads book ID, tag ID, and the count. And then we have the tags dataset. Here we have the tag ID and the corresponding tag name for that tag ID. Alright. So as part of our first phase, we had to do a bit of data cleaning. And the first task of our first phase was to remove all of the duplicate ratings. And to do that, we'd have to find out how many times has one single user rated one particular book. And this would be the command for that. So here what I'm doing is I am grouping this ratings data set by user ID and book ID. After which I am using the mutate function, and I'll add a new column to this, and that new column would be given by the n function from the deployer. So this basically would give us the number of times a single user has rated one particular book. And I'm giving the name of the new column to be capital N. And I'm storing the result back to ratings. So let me have a glance at ratings now. View of ratings. So we see that a new column has been added. So this is the user number. So the user number 314 has rated the book number 1 only once. Similarly, if we take this case over here, the user number 2900 has rated the book number 1 only once. So let me go down and see if there are some changes over here in the count of n. Right, so let's have a glance at these two cases over here. So the user number 4206 has rated the book number 8945 two times over here, right? So these are the duplicate ratings which I'm talking about. So these records need to be removed, right? Right, so now let me also use the table function to find out the distribution of these duplicate ratings. So I'll use table function and I will give in ratings $n over here, which would give me the count of the different ratings given by one particular user to one particular book, right? So this value over here tells us that there have been 5 instances where one particular user has rated the same book 5 times. This tells us that there are 28 instances where the same user has rated the same book 4 times. This tells us that there have been 156 instances where the same user has rated the same book 3 times. And this tells us that there are 4,298 instances where the same user has rated the same book 2 times. And this is all of those cases which are not duplicate. That is, the user has rated that particular book only 1 time. Right. So now what I'll do is, from this ratings data set, I will filter out all of those duplicate records and I will store them in a new object. So I will put in the name of the dataset, which would be ratings over here, and I will use the filter function to select all of those records where n is greater than 1. That is, which have duplicate ratings, and I will store it in a new object. So we have successfully created this new object. Now let me have a glance at this view of duplicate ratings. Right, so there are 4,487 entries in total which have duplicate ratings. Or in other words, there have been 4,487 instances where the same user has rated the same book more than 1 time. Right, now we'll go ahead and remove all of these duplicate ratings. Now this is a very simple command to do that. So from the ratings object, all you have to do is filter out only those records where the value of n equals to 1.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So this basically means that we are filtering out those records where one particular user has rated one particular book only once, and I am switching this result back to the ratings dataset. Right, so we have done the changes. Now let me have a glance at it. View of ratings. Right, so these are all of the records where there are no duplicate ratings. So our second task was to remove all of those users who have rated fewer than 3 books. So for this, we'd have to start off by grouping the users with respect to user ID first and find out the number of ratings given by each user. So I will select this command over here and I'll paste it over here. So I have given ratings over here and I'm grouping this ratings with respect to user ID. After which I am using the mutate function, and over here again I am adding a new column, and that new column would be ratings given. And I will get that ratings given column with the help of this n function from the deployer package. So this n function from the deployer package would basically give me the number of ratings given by each user. Right, so I will store this back into the ratings dataset. Now let me have a glance at it. View of ratings. So this is the user ID. So the user number 314 has given 181 ratings in total. The user ID 439 has given 173 ratings in total. Similarly, the user ID 9246 has given 190 ratings in total. So now we'll go ahead and remove all of those user IDs who have given less than 3 ratings. So this is the command for that. I have again given ratings over here and I am filtering out only those records where the ratings given by each user is greater than 2. That is, each user has at least rated 3 books or more, and I am storing the result back to ratings. So view of ratings. So this is our final data set. So we see that there are 960,595 entries in total. So we are done with the first phase. In the second phase, we'll do some data exploration. So we'll start off by extracting a sample set of 2% records from the entire data set. Then we will make a bar plot for the distribution of ratings. That is, we'd want to analyze the count of different ratings. After which we'll make a plot to understand how many times each book has been rated. Then we'll make a plot for the percentage distribution of different genres. Going ahead, we'll find the top 10 books with highest ratings. And finally, we'll find out the 10 most popular books. Right, so we are back to our studio again, and it's time for phase 2 now. So the first task in our phase 2 was to select a sample from the entire data set. So I'll go ahead and set a seed so that if I ever want to run these commands again, I can get the same results. So I'll set the seed value to be 1. And I'll set a user fraction of 0.02. That is, from the entire user base, I need only 2% of the sample users. So I am assigning this value of 0.02 to a new vector and naming that new vector to be user fraction. Now after which I will find out all of the unique user IDs. So I am using the unique function over here, and I will give in the user ID column from the ratings dataset. So this will give me all of the unique user IDs, and I am storing the result in the users object. Now after this, let me have a glance at the number of the unique user IDs. So length of users. So we see that there are 45,016 unique user IDs in total. So we need 2% of these unique user IDs. So 2% of this would be 0.02 into 45016. So this would give us 900 users. So from 45,016 users in total, we would need 900 users. Right. So we'll do a random sampling of 900 users from the entire user base. So this is the command for that. So I am using the sample function, and this is the list of all of the users. And from all of the users, I only need 900 of the users. So earlier we had multiplied the user fraction into the length of the users, which gave a value of 900 point something. So we are basically rounding that off. And I will store that result in sample users. So now let me have a glance at the length of sample users over here. Length of sample users. So we see that there are 900 sample users in total. Now let me also have a glance at the number of ratings. So initially the number of ratings which we have is 9,60,595. So now what I'll do is, from this ratings data set, I will be filtering out only those user IDs which are present in the sample users object. That is, I would need only the sample users from all of the users. And I will store the result back to ratings. Right, now let me have a glance at the number of ratings. So n row of ratings. So now we see that the number of ratings has reduced to 18,832. So initially we had more than 9 lakh ratings. So now after filtering the data set, we have just 18,832 ratings. Alright. So our second task was to make a distribution of these ratings. So let me go ahead and do that. So guys, this is the command for that. So again, I am using the ratings data set, and on top of this, I am building the ggplot. So here, I am mapping the rating column onto the x-axis. So this column over here, so we have different ratings, 1, 2, 3, 4 and 5. So I am mapping this column onto the x-axis. So the fill color would also be determined by the rating column. And after that, since we'd have to make a bar plot, I am using the geom_bar function. And the color which I give to the boundary of the bar plot would be gray 20. And the color which would be coming to all of these bars would be from this palette over here. So the palette is YLGNBU. So this stands for yellow, green and blue. So we'll be giving this inside the scale fill brewer function. Right. And I am also setting the guides to be false. Let me hit enter. So this is what you get. Let me zoom this now. So this is quite an interesting plot, isn't it? So let's have a glance at this bar over here. So this basically tells us that there are more than 6,000 cases where a rating of 4-star was given. Now similarly, we see that there are more than 5,000 cases where a rating of 5-star was given. And this bar over here, so this tells us that around 4,700 times a rating of 3-star was given. So the count of these two bars is quite low. So there have been very less cases where a rating of 1-star was given. So maybe not even 500 times a rating of 1-star was given. So this is for the rating of 2 stars. So around 1,000 times rating of 2 stars would have been given. So guys, this is the distribution of the ratings. Now after which we had to find the number of ratings per each book. So let's also do that. So here again, I start off by giving the ratings data set, and I would have to group this with respect to book ID because I'd want to find the number of ratings per each book. So that is why I am grouping it with respect to book ID. Now after grouping it, I will use the summarize function. So basically inside this summarize function, I will basically get the count of number of ratings for each book. So here I am again using the n function. So this n function would give me the number of ratings per each book, and I'm also naming the result to be number of ratings per book. After which I'll again use the pipe operator and add a layer of the ggplot on top of it, and I am assigning the number of ratings per book onto the x-axis. The fill color is orange, the boundary color is gray 20, and the x-axis values would range from 0 to 40. Right guys, so this is the plot. Let me zoom this now. So from this graph, we can basically infer that there is not even one case where a book was rated more than 10 times. So let's have a glance at this bar over here. So this tells us that there are more than 2,500 instances where a single book was rated only by one user. So this is for those instances where a single book was rated by 2 users, or in other words, a single book was rated 2 times. This is for those instances which tells us that a single book was rated by 3 users, or in other words, a single book was rated 3 times. And the count for this is around 1,500 times. Right, so this plot was for the number of ratings per each book. Then we had to get the percentage distribution of the different genres. So what we'll do is we'll start off by making a new object and giving it the name genres. So this genres object would basically have a list of different genres in it. So I have basically listed down a bunch of different genres over here, and I am storing all of these into the genres object. So the different genres are art, biography, science, thriller, travel, humor and comedy, and so on. So after building the genres object, what we'll do is from this tags data set, I will be extracting only those tag names which are present in the genres. Or in other words, I am extracting only those genres which are listed down over here. So this is the command for that. So what I'm basically doing over here is I am finding out if the listed genres are present in the tag names or not. And if they are present, I am extracting only those genres and I am storing them in available genres. So let me hit enter and let me actually see what are the available genres. right? So these are all of the available genres in the tags dataset. So there are 27 genres in total, and these are Christian, business, poetry, philosophy, science, and so on. Now similarly, I will extract all of the corresponding tag IDs with respect to the tag names. So let me find out which are the available tags. So over here, I am basically extracting all of those tag IDs if the tag name is present in one of the available genres, right? So if the tag name is present in one of the available genres, only those tag IDs I'm extracting. And similarly, if the tag name is not present in the available genre, then I won't be extracting those tag IDs. And I am storing the result in available tags. So next we have to make a plot for the percentage of each genre. So let's go ahead and do that. So before we do that, let's actually get a count of the different genres available. So this would be the command for that. Let me print it over here. So what I'm basically doing over here is from the book tags dataset, I am extracting only those tag IDs which are present in available tags. And then again, I am grouping it with respect to the tag ID, after which I'll use the summarize function and get the number of counts of each of these tag IDs. Or in other words, I'll get the count of the different genres. So let me hit enter and let me see what do we get. So this is the tag ID 2938, and for this corresponding genre, the count is 436. That is, there are 436 books belonging to this genre. Similarly, this is the tag ID 4605 and the count is 1109. So this means that there are 1109 books present for this particular genre over here. And let's take this over here. So the tag ID is 7778 and the count is 469. So this means that there are 469 books present with respect to this genre. Now let me go ahead and also find the percentage. So let me select all of this code over here. Right. So now we had run the command till here. Now, so we basically got the count of each genre. Now, after getting the count of each genre, I am ungrouping it again. After that, I will use the mutate function and find the total count. That is the total count of all of the genres combined. And I am also creating a new column percentage. So this percentage over here, I am dividing n upon sum of n. That is, this would give me the percentage of each of the genre. And after getting the percentage of each of the genre, I will arrange the dataset in descending order. And after arranging the dataset in descending order, I will also left join the tags dataset to the book tags dataset. And the joining would be done by the tag ID column over here. So let me store this in a new object. So let's say book info. Now let me have a glance at it. View of book info. Right. So guys, this is the tag ID. This is the count of the tag ID. That is the number of times this genre is present. And this column gives us the total count of all of the genres. This gives us the percentage of the genre. And this is the tag name, which is fantasy. So we've got our dataset ready. Now we'll go ahead and make a plot on top of this. So now let me go ahead and make a plot. So the object name was actually book info. So let me change this to book info over here. And on top of this book info object, I am adding a ggplot layer. So here I'll be mapping the percentage column onto the y-axis and the tag name column onto the x-axis. And the fill would be determined by the percentage column. And since we'd want to make a bar plot, we'll be using the geom bar function. And the stat which I've used is identity. And I'll also use the quad flip function over here because I'd want these bars to be stacked horizontally and